Class has
highlight.
started. If you're having any kind of audio issues, one of the biggest challenges we find that interrupts audio is being connected to your corporate VPN. I recognize that there's work to be done, but at the same time, if you can be less distracted with work, that's a better thing. Disconnecting from your corporate VPN solves two of those problems, right? First of all, gives us better audio, and second of all, hopefully keeps your focus a little more on what we're presenting here. The way to, if that's not an option for you, if you're already disconnected, then go into the WebEx control panel and disconnect from computer audio, and then reconnect. Or if that doesn't work, quite frankly, folks, just log out, log back in again. You know, close the WebEx session, restart the WebEx itself, reconnect to the session, and away you go from there. Use the same way that you connected, and you will still get credit for the class. There we go. Fantastic. And by the way, interesting. I appreciate the comments, the introduction stuff. That's really, really good. For those who are joining the class with no experience, that's fine, right? That's kind of where we're at. And for those of you who feel like you've got a lot of experience or you have a lot of knowledge around AWS, remember this course is set up to prepare you to get your thoughts aligned behind the Cloud Practitioner Essentials certification exam. So I'm going to be talking about that as we go through the class. So even if you've got lots of experience, that's cool. Let's just make sure that we're focusing on the things that are relevant for the test, and that's really why you're in this class, right? That's the kind of the idea. And even if you're not going to be shooting for the certification exam, which I believe all of you should be, it's still a great way to be able to talk the talk when you're discussing AWS with your customers. So on that note, let me give you a bit about me. Obviously, AWS Partner Trainer. That's my role. I am in the Pacific time zone, which is where this class is being run. I live and work in a small town called Kelowna, British Columbia, Canada. So West Coast-ish, right? So certainly in Pacific time zone. But for those who are not familiar with this area, for me to drive to Vancouver would take about 5 hours. So I'm inland from Vancouver. Of course, the other way it would be rather wet, but that's a whole side discussion. Anyways, my AWS experience goes back several years. Got introduced to AWS when I was actually staff at VMware, working in the curriculum group there. I was one of the primary liaisons for the VMware Cloud on AWS product. And that started to introduce me to the whole concept of, exactly what AWS was all about. So I would say, what, 4 or 5 years ago, somewhere around about there, and got me digging into it. And then an opportunity arose where I could join AWS in this role, and I jumped on it. It's been a great opportunity for me. It's also a fascinating piece of technology where, if you like change, trust me, you're in the right place. There's one constant in this business, it's change. And it has been that way in the IT world ever since I started. And, that was a long time ago. Uh, First professional teaching gig. For those of you who have never heard of that, that's cool. That just gives you a little bit of background as to where I've been in the world. So, Novell, Microsoft, Compaq, HP, Cisco, all the big players. I've had a certain amount of time in the classroom teaching mostly network infrastructure technologies in the back end. So this is a next natural progression for me. Um, I'm a car guy by default, right? That's just kind of what I do. I've got a couple of hot rods in the garage, one that I built myself. Spent last Friday at the racetrack here in Oliver, British Columbia. Um, Work on a Porsche race team on the weekends. Yeah, if it's got to do with cars, I'm interested. Whether it's hot rods or modern day performance cars, either way. Seems to work pretty well for me. And again, I got a buddy who's got a couple of really nice cars, and we get together and have some fun on a fairly regular basis, usually at the racetrack. So it's good fun. Anyways, so that's a little bit about me. And thank you very much for the ongoing introductions. I've been reading those as we go. That's one thing I'm reasonably good at, multitasking on the chat process. Let's talk about logistics. So this class is 9 till 5 Pacific time. We don't record these. And that's simply because the content changes too rapidly. If we were to ever record something, it would end up being stale. And that would do you guys a very big disservice, right? Is having stale content when you're preparing for an exam is not the right answer. So in order to achieve the minimum attendance requirement for you to be marked as attended rather than no-show, you do need to be here for 60% of the overall time of the class. And again, WebEx calculates that for me. The way they do their algorithm, heaven only knows, but at the end of the day, well, maybe more like tomorrow morning, I will get a report back from WebEx, at which point I will be sending you a copy of the slides, a PDF copy of the slides, assuming that you met that 60% attendance requirement. So you'll get the slides tomorrow. Okay, let me be crystal clear about that. You don't get them 5 minutes after you finish the class. You get them tomorrow, at least in my time zone. Okay, and that's only because there's a delay in the communication between WebEx and our systems and getting that all updated and yeah, all the logistics there. So no big deal. And again, comments about the VPN and disconnecting from audio if you have issues, right? So with that said, we have an awfully large agenda, right? This content is aligned behind the Cloud Practitioner Essentials certification exam. Module 10, we're going to talk about the exam itself, right? But I do want to make sure you understand right up front what this course is and what it is not. And I think sometimes going into a class understanding what it's not is almost more valuable than what it is. So obviously you guys can read. I'm not going to bother going through each individual module on this slide. But recognize that this exam and the certification behind it and this course as it aligns is all about how to talk the talk. In other words, can you sit down and have a competent conversation with somebody else about AWS, at least covering a certain amount of the fundamental products and processes, right? So if you're in front of a customer, you can have a conversation with that customer and you'll be able to understand everything they're saying, they'll be able to understand everything you're saying, and you'll be getting the message right. So that's really what this exam is all about. There's not a lot of hands-on in the exam. Well, there's no hands-on in the exam. They don't test you on where do I go in the user interface to do such and such a task. Now, a lot of us learn by going and doing things. I've got some hints for you at the end of class around, where you could go to get some more exercise in that area. But it is certainly not a requirement to take this certification exam to be able to know how to work with the user interface. Okay. So on that note, for those of you that are in different time zones, I do want to make mention of the fact that, the class will run all the way till 5 o'clock in Pacific time. I've never finished this class early. I've actually run late on a few occasions. Really depends on the conversation. We've got well over 300 slides to get through. And again, I don't like slides. I would prefer to do it another way, but slides keep us on track. They keep us focused, and it also gives you a great reference point for afterwards. So I'll be doing some diagrams. I might do a demonstration or two in the user interface itself, despite the fact that you don't need to know that. Sometimes people learn better from that. So we'll vary things a little bit. The other thing I would like to mention about the class, and I think it's a great thing, one of the more common questions I get towards the end is, hey, Andrew, where can I get a practice test for this? Okay. And the first practice test that you're going to have access to is actually embedded within this course. We've got a bunch of review questions at the end of every module, or quite frankly, scattered throughout the modules. And we go through those as a class. We have an opportunity to answer the questions in chat, and then we'll take a look at the actual answers and discuss why the answer is correct in some cases, right? Some of them it's pretty obvious. Others might require a bit of discussion. So your first practice test is actually going to come by hanging out with me today. And then I'll point you at some additional practice test resources a little bit later on. Okay. So that's kind of the daily overview. And because we've got so much content to roll with, let's just jump right in. We do take a break about every hour, again, because I'm feed you a lot of information today. The one way to make sure that some of it sticks is to be able to get a break once in a while. So I will be stopping about every hour of lecture for about 10 minutes, and then we'll come back. There will be a 30-minute lunch break, and I call that lunch in air quotes, mostly because, again, it'll be lunch in my time zone, which means it'll happen probably around about 12:30 Pacific time. But again, based on whatever time zone you're in, just recognize that's what it's at. And again, maybe if you got somebody who can help you out, if lunch falls more aligned with one of those coffee breaks, maybe you could poke somebody to get you to get something. Whatever happens. Anyways, so let's go. So introduction to AWS. Right, we might as well start at the beginning. This module is going to be about the 3 cloud computing models and the 6 benefits of cloud computing. Now, before I go down this path, let's talk about the exam. So everyone here recognizes that the cloud practitioner certification is in fact an exam which is sponsored by AWS, right? This is an AWS exam. It's focusing on AWS technology from the AWS perspective. This course was written by AWS and is from the AWS perspective. So why am I going down this path? Well, the primary reason I'm going down this path is some of you may know things from other cloud providers. And that's very cool. It's incredibly powerful that you might know something from another cloud provider. However, recognize a couple of things. We use terms that they use that don't necessarily mean the same thing. For instance, an availability zone, if you're comparing an availability zone in our world to an availability zone in, say, the Microsoft platform, you're going to find that they're actually slightly different. Don't worry about the difference. Focus on what the AWS version is, okay? So if I were to give you a hint, your first hint of the day for getting ready to take the test is, if I'm going to teach you something in this course, and you know something slightly different from another product's perspective, don't fight it. Take my word for it. This is the way it is, right? And then leverage that content that you already know so that you can become a better consultant or what have you. Because again, that's valuable knowledge when you go out into the real world, right? But from the exam's perspective, hey, it's an AWS exam. This is an AWS course. The two are aligned. Let's focus on what's delivered here. So this module, we're going to talk about the 3 cloud computing deployment models from AWS's perspective, and also talk about the 6 primary benefits of cloud computing. There are many more than that, but the 6 that we talk about. So cloud computing, generally speaking, our description is, access to services on demand. You don't need to build a data center or install a server to be able to stand up a compute resource or a storage resource or an artificial intelligence resource, right? Whatever it is, those services are available to you. And when you choose to use them, they're available, right? You just log into your AWS account and you start to use the services. And that means, by extension, you automatically avoid large upfront investments. There's no upfront cost to this, right? You simply log in and start to use the services. And at the end of the month, you get a bill for the services that you've actually used. And that goes to the 4th element on this slide, pay only for what you use. Now, I'll show you how to get a better deal, but essentially the primary tenets behind cloud computing is you don't have to spend a bunch up front and you only pay for what you actually use. In other words, let's take a look at a situation. And again, I like this one because it's a fairly powerful statement of where this is valuable. Let's assume that I'm a restaurant owner. Right? I've got a chain of restaurants that are operating all across North America. I've been very successful. And the current date is back in 2019, right? So we're going to go back a few years. So I'm there, got my own data center, got my own stuff. It's time to do a hardware upgrade. I need some new storage. So I'm going to provision some new 50 terabyte SAN, spend a whole bunch of money on this thing, maybe even into 6 figures, maybe 7, if I buy the right stuff for my organization. And again, I purchase when I'm building my own physical hardware environment. If we go back in the day, if a customer is going to buy that, they usually look at purchasing something that's scalable for the next 2 to 3 years, right? I mean, that's a good, wise investment, right? So I go and spend my 6 or 7 figures on the stuff that's going to get me through the next 3 years. So I got lots of spare capacity, right? Great big storage array. It's going to be awesome. And then the pandemic hits. And restaurants are one of the first things that end up closing down, right? They're not able to do much business because the world is locked down, and you guys know the history. So now I've got this huge investment in a bunch of stuff for the next 3 years. I've paid for it. It's taken money out of my bank account already, or maybe I've amortized it over time and I've got a loan to pay for it, whatever it is. But at the end of the day, I'm paying for something that I'm not actually using, right? I think that's a fairly accurate statement in a lot of cases. If I was actively growing my business and that thing was provisioned for me and I could grow into it, that's awesome. But what if that customer had actually chosen to deploy their storage infrastructure in the cloud? Well, if they're using, 10 petabytes of storage now, then and then the pandemic hits, well, they just continue to pay for the 10 petabytes that they're actually using on a monthly basis. They didn't have to tell us they were going to use 50 petabytes later on, right? That's not relevant. All they do is use the storage that they're using, and we bill them for the actual storage consumed. Okay. So, Howard, you clearly missed the introduction. Yes, slides are coming tomorrow if you're in attendance for 50% of the time. Or 60%, sorry, my bad. 60% is our threshold. So, anyway, so that is the basics. And that really comes down to the third bullet on this slide, right? Which is compute provision of resources as needed. So if I need more storage, I just use it. If I need uh, a new virtual machine to run some new application, I simply provision it when I need it. If I need to deploy a new database, I deploy it when I need it. I don't have to go out and acquire a fancy new license and get all sorts of weird stuff up and running in terms of hardware and configuration and rack and stack it and all those other goodies. I just simply say, I need a new database. Well, what kind do you need? Well, I need a non-relational database. Well, let's go ahead and deploy a DynamoDB database, right? And we'll talk about the details of that. Don't get too bogged down in that idea. But the short version about cloud computing is this. I don't need to sit down and have a big committee meeting to figure out what resources I need for the next 2 years. I simply use what I need when I need it. Right? So in terms of deployment models, there is the all-in in cloud. In other words, this is a customer, maybe a new startup organization who's decided, this whole idea of running a data center is not for me. I'm going to go ahead and deploy everything in cloud. Alternatively, this could be a customer who has completely migrated from on-prem to cloud. Right? The hybrid approach, skipping over the middle one for now, is usually what you'll find in most organizations today. They're exploring cloud, they're starting to experiment with it, they've started a migration project where they're halfway to cloud, or perhaps they've using some technology like the VMware Cloud on AWS, where some of the stuff is on-prem and some of it is in the cloud, and they're doing that on purpose. Some hospitals, based on regulatory reasons, are doing things like that. They're still using cloud technology, but some of the tech is actually in their own data centers. Some of it is in the cloud. So a hybrid approach. The oddball one is for customers, and there are a bunch of these, that leverage cloud-like technology to build their own private cloud on premise. There are a number of organizations that have done this historically using things like VMware infrastructure, where the IT department builds a self-service, on-demand, cloud-based platform that they're running in their own data center. So in other words, the IT department is essentially the cloud provider for the organization. And then when a department requires a resource, they simply go to a portal and deploy said resource, whether it's a new virtual machine or some new intelligent software package or whatever it happens to be. These are not the most common deployment, but you need to be aware that they do exist, right? So customers that are building their own cloud, and it gives them access to services on demand. The departments pay only for what they use. Like I said, it basically takes the IT department and turns them into a cloud provider. Not the most common scenario. Okay. And we can help with that, by the way. We have technology that will allow them to do that, right? And typical again, defense customers, we've got a, if you're talking U.S. Department of Defense, we've got GovCloud, right? We've got a private area for government-based, U.S. government-based cloud deployments. And again, what you'll find is which one is being used is usually a maturity model discussion, right? Where are you at in the journey? Are you a fresh startup company and you don't want to deploy your own data center? Are you one of those historical companies that's got a whole bunch of stuff on-prem? Generally, if you're on-prem, the hybrid model is going to be by far the most predominant model. Right? And it really depends on the deployment. And, Melanie's suggesting that, hey, we use all three. Well, sure. I mean, depends on what you're doing. So why AWS Cloud? And again, this is not a side-by-side class where we sit down and compare, AWS versus Google Cloud versus Microsoft solution, right? Let me give you a hint right now for those of you who are relatively new to the environment. If you try to take that story to your customer and try to have a side-by-side comparative, you will probably not be successful. Okay. Then the reason is really easy. If you're wrong on any one statement, your customer loses your trust, right? They don't trust you anymore. Oh, well, clearly this guy's trying to sell me something because he got the Microsoft solution wrong. Do you want to put yourself in that position? This stuff changes daily. What I'd rather do, and the more successful sales approach, and trust me, I've been that in my career, and this is the approach I always took, is let me tell you how my solution is going to solve your problem, Mr. Customer, and give them absolutely no reason to doubt that. And if you present your solutions that way, then the whole theirs does this, ours does that becomes background noise, right? If the customer really trusts that what your solution is going to do is going to solve their problem, then they are all in, right? When I go shopping for a car, I want to know about this car. I don't want the salesman to start off by telling me, well, this car is better than that car because of this. Maybe he's going to have to answer that question a couple of times because the customer's looking at two different cars. Fair enough. But what I'd rather hear about first is all about the one I'm currently looking at, right? Present your solution to solve the customer's problem. It's always the best battle. And again, remember from the certification perspective, we never ask you questions about the other guys, right? It's not there. Okay. So let's talk about cloud computing benefits. And this is primarily, if you understand this, and again, I'm having taken well over 100 certification exams in my time frame. If you understand rather than memorize, you will be more successful, right? There's a lot of content here. Memorizing everything I tell you is not going to be possible, not unless you have an eidetic memory, and I suspect that most of us don't have that. I know I don't. So if we focus on why and how, then I find that a lot easier to understand, right? If I understand something, then I can fit the other pieces in around it, right? If this operates that way, then it makes sense that, the following. So that's kind of the focus of this module. So let's take a look at these cloud computing benefits. So we move to a variable expense model with cloud computing. In other words, I don't have to spend a whole bunch of money up front on, building out a data center, getting all the square footage, installing heat and cooling, and perhaps even a backup generator. I don't have to invest in any big technology before I actually get to use it. All I do is deploy what I need and use it, right? And then as I continue to consume that resource, I pay for it. If I consume more of that resource, I may pay a little bit more. But recognize one of the other things. If you consume a lot more of a certain resource, there are often discounts available. So, if you're a large consumer of certain types of resources, you can actually get a good deal every month. And, because we recognize, hey, you're a valuable customer, you're using a lot of resources. So you pay for only what you use, but there are discounts to be had if you use a lot of it, right? Cost optimization. So here's my question. And again, I go back to the restaurant scenario. If I'm an owner of a restaurant, what should I be focused on in terms of my business? Well, perhaps the customers, maybe the menu, so that customers have got an appealing choice when they come to my restaurant. Maybe the way I present the content. Maybe I've got a fancy new automated menuing system that is tablet based, so I don't have to deal with paper menus anymore. Focus on the things that the customer is going to appreciate and subsequently, spend their money with you as a business or with your customer's business, right? Because you guys are all partners. I'm assuming you're helping that restaurant owner set up their environment. If I have to run a data center just because I need to, because, I got some application that does credit card processing or whatever, running that data center does not add to my bottom line. Nothing about running that data center increases my revenue. It allows me to maybe take revenue, but the act of running the data center itself does not add to my bottom line. The only time that it does is if I happen to be a data center provider. Well, if I'm running a restaurant, I am not a data center provider. I'm feeding people. So let's focus on that. And that should be where your investment goes. So let me put it in black and white. I think all of us can understand the data center. Let's talk about security patches. So most of us here are aware that operating systems need to be patched. Well, if I'm running a data center and I've got a whole bunch of Windows, Linux, whatever operating system it is, they're going to need to be security patched. And maybe my process is that I have to do a test on whether I security patch that particular operating system. Does that patch work with the applications I have installed on the server? So you're now spending money testing patches and then subsequently deploying the patches into the systems that are running in your data center. What if I could deploy an infrastructure where that was no longer necessary? What if I could use what are called fully managed services so that I don't have to worry about things like Windows patching and Linux patching? Would that be of value to the customer? And it really goes towards this second part of the conversation, which is take your IT money and spend it on the things that customers care about, right? Focus your investment. What about capacity? Well, I alluded to this a little bit earlier. If I have to upgrade my storage for the next predicted 3 years, honestly, I've been in those meetings. That could be 6 months of meetings where everybody brings their perspective to the table, and you have a big argument about who needs what and how much. We can't afford everything, so we have to scale back on what we do need. And then we buy a storage array that, when the pandemic hits, sits there twiddling its thumbs. Right? At the end of the day, there's nothing good about that entire process. And so avoid that. Don't even worry about it. It doesn't even become part of the conversation. When you have a cloud-based infrastructure, you have the ability to elastically move your resources to where they're needed. You either deploy more virtual machines as they're needed. Maybe your web server is very busy one day and we can set up an automatic process to add multiple web servers to support that. We'll talk about that later. Maybe it's just that, hey, we got a big bump in storage, so we're going to actually use more storage. But you don't have to tell me up front that you're going to do that. And at the end of the month, you simply get billed for what you've actually used. And by the way, if you don't need those multiple web servers anymore and you turn them off, you stop getting billed for them when you turn them off. Right? That's a huge deal. And I don't have to go and invest a whole bunch of money up front, go to the banker or the leasing agent and figure out how I'm going to spend $10 million refreshing my data center. And that's a huge appeal for a lot of customers. Economies of scale are interesting. If I'm that restaurant customer and I'm going to go buy maybe 10 petabytes for a storage array, some ridiculous number, or maybe it's even 50, right? That's a big storage array. But in the big picture of things, that's a big storage array for one company. What if I could benefit from somebody like AWS who goes off to those storage array vendors and purchases literally thousands of petabytes worth of storage all at one time? Just to put this in perspective, when AWS builds a data center, our starting build is 50,000 physical servers. Has anyone here ever seen a data center's insides that has 50,000 or more physical servers in it? I mean, that's not just a data center, that's a building, right? And to be honest, when we stand up a region, we typically start with 2 availability zones minimum. Each of those availability zones typically has 2 or 3 data centers in it. So we're usually starting somewhere between 200 and 300,000 physical servers when we stand up a region, to say nothing of the storage arrays. Well, trust me on this. When we say we buy hardware by the truckload, actually, we're lying to you. We actually buy it by the trainload, right? So when we go to the storage vendors and ask for a good deal, yeah, based on that capacity, we get the very best deal that's even available, right? And of course, we price our services based on what it costs us to deliver them. So if we get a good deal up front, then when we make that service available to you as a customer or to your customers, then we can offer a very good price because we got a very good price going in simply because of our capacity, right? The needs. So economies of scale become a big deal. One single customer buying something does not have the buying power that we have to run the cloud. And subsequently, we price our services according to the prices that we get, right? So speed and agility, if today's supply chain issues, and man, I could share stories on this, in the IT business, and then quite frankly, even dealing with cars. We've had problems getting tires for our race car. Supply chain issues. You order the stuff, and weeks and weeks and weeks go by before you even get a shipping confirmation. Whereas if you needed a resource, maybe you hired a new data scientist and you wanted to deploy a new machine learning model within your environment, and this is a really cool deal. Well, if you were doing that in your own environment, you'd have to go and get the servers, get the software. Whereas in AWS, you simply say, oh, yes, we'd like to deploy some machine learning today, please. Click, 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 and job done. And you start to pay for it when you use it. And in some cases, we even give you free trial periods. We'll talk about that a little bit later on, right? Going global. So for those of you who've got customers who have a worldwide web presence, right? They've got a web server. Well, they're already global, right? Well, kind of, right? They can perhaps service customers from across the planet. But in reality, what if they need to do high bandwidth across the planet? Well, if they've got their web server somewhere in the central United States, then that means everybody from across the planet has to be able to transfer their data from that location. So think Netflix, right? Let's talk about a service that a lot of us understand. Streaming video, lots and lots of content. Every movie's big. And when you want to watch a movie, it needs to be streamed to wherever you are. So let's say the customer's in Japan and the movie's in somewhere in Ohio. Well, that's a lot of internet between the customer and the movie. What if we could provide you services where at the click of a couple of mouse buttons, you could actually set up a caching server such that when the customer in Japan wants to watch the movie that's physically resident in Ohio right now, that movie gets copied through a dedicated private high-speed network to a caching server very close to that customer in Japan, and then it's only streamed to the customer across the internet from a local connection. Well, that's going to be a much better experience for that customer in Japan. Much better. So wouldn't it be nice if you could provide that service for your customer, right? Your customer. So Netflix, and by the way, that's what we do for Netflix. Netflix is in fact one of the larger AWS customers, and we provide this type of service. And I could flip that on its head too. Perhaps another scenario would be maybe as a business, I'm running a video editing service. So you got lots of people out there with these fancy 4K and 8K cameras these days, and they want to upload their videos so that they can be put into a professional format. And that's your business. Well, uploading that movie from Japan to Ohio is going to be just as problematic as downloading one, perhaps even more. Well, what if we could provide automatic upload capabilities? So again, the customer in Japan doesn't know. They just connect to your web server and they say, I want to upload this video. And they go ahead and say upload, and we automatically detect where they are in the world, and we direct them to a local caching server that they can upload that video to. The customer doesn't know anything about this. It's completely transparent. And yet, from the perspective of the video editing company, we're providing outstanding performance for customers doing uploads because it's essentially local. It's, to a server in Japan, in my example. And that's some of what the AWS global infrastructure brings to the table. We're aware of where people are in the world. We understand we've got worldwide resources that are set aside to be able to enable this functionality. And again, I'm scratching the tip of the iceberg with respect to the global infrastructure. Right? These are great examples of why this might matter to an organization. And at the end of the day, isn't that what's relevant? Right? Oh yeah, AWS is a big global infrastructure. I'd go back to the same question every time. Why is that relevant? Well, two examples, right? The Netflix scenario and the customer who wants to upload content. But it's way more than that, right? Maybe we've got regional things. Maybe we need to take advantage of, and here's a great one, regulatory rules. For those that are aware of the GDPR, which is the European Union's rules for global data protection and privacy, if you're going to do a certain type of business and collect personally identifiable information from customers in, say, Germany, some of the rules, depending on the type of information you're collecting, mean that you have to store that data in Germany. It must be stored on physical compute resources that are inside the country's boundaries. How do you do that if you're based in North America? Right? I mean, well, that's really easy. With the AWS global infrastructure, you deploy the resources you need into the Frankfurt region and job done. Right? It literally becomes that simple. And how much extra does that cost you? Well, what did you deploy? It was a couple of EC2 virtual machine instances and some storage that's provided there. Well, it costs you for those two EC2 instances and some storage. No big deal, right? Again, you only pay for what you use. So these are the types of things that really become a big deal. So in as much as AWS has got well over 200 services right now, we break them into categories so that we can more effectively talk about them. And from the perspective of this exam, I think it's reasonable to assume that we're going to talk about the 6 items on screen. We're going to delve into some of the detailed services, like in compute, we're going to talk about EC2. We're going to talk about auto scaling. We're going to talk about load balancing, right? You know, those are compute functions. We've got a lot more in the compute area than just those 3 functions. We're going to talk about networking and content delivery. We'll talk about storage and management and security. Security is a big topic. And we'll talk about databases. So don't panic. There's a lot of content here, but it is broken down into fairly organizable and understandable pieces. Okay. And that is the high-level overview. So remember, I suggested that we were going to do a knowledge check. So we were going to do a practice test as a part of this class. Okay, everybody good with me? So module 1's knowledge check. What I'm going to hope for is answers in chat, but let me set the rules first. This is a non-threatening environment, right? If you get the answer wrong, learn from that. Nobody's judging, right? A lot of you guys are seeing this stuff for the very first time. I deliver a lot of content in a short period of time. So give it your best shot. Provide the answers in chat. I think it's always proven to be a fairly cool process, because it also tells me if everybody gets the answer right, I probably don't need to talk about that anymore, right? But if I get half of the people who get the answer wrong, clearly it's up to me to fix that, okay? So I am relying on you to help make this class better. So here we go, knowledge check. Question number 1, answers in chat. What is cloud computing? Is it A, B, C, or D? What do you guys think? Oh, this is an awfully strong start to the day. Fantastic. Oh, you guys rock. Oh, that's outstanding. So yes, using on-demand delivery light. Again, ladies and gents, I think you already got this. You're looking for the best answer, right? And while you could argue that you could back up files that are stored on the desktop on mobile devices to prevent data loss using cloud computing, right? And believe me, you can. That's not the definition of cloud computing, right? And you guys nailed it, right? So if I give you an exam taking tip, and again, this is going to sound ridiculous, and I talk about it in every class I've ever delivered. Answer the question that's being asked, right? And you guys did a great job of that one. So yes, I agree. C is the on-demand delivery of IT resources and applications through the internet. And remember, when I get you the copy of the slides tomorrow, these are included in the slide deck, right? These are slides, right? So what is another name for an on-premise deployment? Oh, look at that. So yeah, again, the best answer here ends up being private cloud, right? That is the definition of an on-premise deployment. Right? Customer chooses to deploy cloud-based technologies in their own data center. So private cloud. How does the scale of cloud computing help you save costs? Now, before you answer this, so step away from the keyboard, recognize what the question actually is, right? So on that note, Now that I've given you something to think about, how does the scale of cloud computing help you save costs? Yeah, I'd say you guys are pretty much on fire. We've got a couple of dissenters here. Primary answer appears to be B, right? With a couple of folks grabbing C and A as the alternatives, and maybe even some D's, right? And the actual AWS answer, as it fits, is the aggregated cloud usage from a large number of customers results in lower pay-as-you-go prices, right? And really, ladies and gentlemen, it gives me an opportunity this is a teaching opportunity for me. And remember I said, answer the question that's being asked. This question is all about the scale of cloud computing. It is not about how does cloud computing help you save costs, because if that was the answer, if the question was, how does cloud computing help you save costs? I could argue that all of the above is the right answer. You guys see where that comes from? Right? Because, hey, I can save costs because I don't have to invest in the technology. Aggregated cloud usage, certainly. Accessing services on demand helps prevent excess or limited capacity. Sure, that helps me save costs. And you can quickly deploy applications to customers to provide low latency. Well, that can also help me save costs, right? But that wasn't the question, was it? The question was, what is it about the scale of cloud computing that does help you save costs? So it's all about, the fact that AWS goes and buys trainloads of hardware all at one time. So again, if I just get rid of this mess, right? The question ends up being the scale of, and subsequently the answer is, whoopsie, scooted a little bit too fast, the aggregated cloud usage from a large number of customers, right? Everyone good? That makes sense? You got to be critical when you read the questions. By the way, 65 questions in an hour, or sorry, in 90 minutes. Yeah, geez, didn't want to panic you there. Um, you know, this isn't an exam that you get to dawdle. You do have to approach it uh, such that there is a time limit, but at the same time, slowing down enough to read the question for what it is will actually save you time. Remember that old statement, haste makes waste. I cannot tell you the number of times I have marked a question for review on an exam because I don't know the answer to this question. It's driving me crazy. When I go back and reread the question at the end of the test, I realize that, yeah, if I had read the question properly the first time, the answer is pretty obvious. Okay. And I kid you not, that happens time and time and time again in these exams. You're the nerves are high, the adrenaline's pumping. It's really easy to be distracted by what is not a part of the conversation, right? Okay. So that's module one. And we pretty much knocked that one out. That's a good deal. So again, 30 odd slides later, away we go. So let's jump in before we do our first break. We'll start talking about compute in the cloud. And forgive me for a moment. I'm just going to go and close my office window because somebody's decided to mow the lawn. All right, back to you. Sorry about that. I don't know how much of that comes through on my fancy microphone, but it certainly distracts me. Anyways, so compute in the cloud. This discussion is going to go into, at the end of the day, a virtual machine, right? Let's call it what it is. EC2 is the AWS virtual machine in the cloud, and it stands for Elastic Compute Cloud. We'll get there, right? We're going to identify EC2 instance types. We're going to talk about different billing options, auto scaling, elastic load balancing, and all the rest of that stuff. But first, he says, hang on a second, but first. Yeah, so one of the things I'm going to do is teach you how to fish. You guys are going, what? Yeah. And again, this is it's a term that we use in the learning world. The whole, I think the phrase goes something like, if you give a man a fish, you feed him for the day. If you teach a man to fish, you feed him for a lifetime, right? So, and thank you for the feedback, Erkan. That's great news. So learning to fish, the very first thing that's going to happen is, and I get this question a lot, Andrew, is the content in this course enough to pass the test? And, that depends on perspective. It depends on how good your memory is. It depends on how well you understand the material that I'm going to deliver today. At the end of the day, and this is speaking specifically of me, and I suspect a lot of you, I like to know where to go to look for stuff, right? Sometimes hearing something from a different perspective is a good idea. So what I'd like to do is figure out the actual source of truth. So everything about AWS is always provided by aws.amazon.com. Right? Okay, so great. You go to that link, you bookmark it. That's great, right? aws.amazon.com. If I need to know something about a particular service, the URL, and we've made it very easy, is always aws.amazon.com/name of the service. So if it's EC2 or Lightsail, right? aws.amazon.com/Lightsail is information about the AWS service called Lightsail, right? That seems pretty straightforward. And so let me show you this, right? And we do not talk about Lightsail in this course. I'm using this one as a, hey, I don't even know what this thing is. Let's go ahead and have a look, right? I know what it is, but maybe you haven't heard of it. So one of the things I want to point out is every single page on the web that we build in this architecture, if it's about one of the products that we have, whether it's Lightsail or EC2 or S3 or whatever, this white banner in the middle here is always the same, right? It's got the name of the service. It's got a brief overview, which is the page we land on. There is a features page. There's a pricing page. So if you guys are going through this class and I introduce a new service like Lightsail, and you're interested because, hey, Andrew, that'd be great for my customer. I wonder how much that costs. Just go to the Lightsail page and click on the pricing tab. Right? There's a getting started tab, but for the exam, for the purposes of the exam, if I talk about a service in this class, your best resource for right from the source information is the frequently asked questions page. Every service has got a landing page, whether it's EC2, S3, whatever. You go to the appropriate page, you click on the frequently asked questions dialog, and you go through what's here. And I kid you not, for a lot of you guys, you go, wow, this is a lot of stuff, right? Notice we're still in the general section. And then it rolls down to Lightsail resources and billing and account management and block storage. And it would be a very good use of your time, particularly if you are going to be talking to customers, to have at least gone through the frequently asked questions for each of the services that we're going to cover. Okay. I will cover a lot of the content, but remember, sometimes hearing it from more than one source is a good idea. Okay. So that's all about learning to fish, right? And I, it's something I've done for years. I've been a big fan of teaching my students, what is it that you can do to help yourself? Because at the end of the day, I'm not going to be there when you go to study for this stuff. Some of what I say may resonate, but here's how you find the stuff yourself. So aws.amazon.com/name of the service, for instance, Lightsail. This is a wonderful page. There is a landing page for all the new announcements. And again, we keep it historical. So we go back over several months and it's organized according to a timeline. So if you're going to go in and talk to a customer about a particular solution, my suggestion would be before you go and talk to the customer, have a half an hour and spend it on the new page, aws.amazon.com/new. Now that talks about all the new announcements, right? All the things that are either coming up or have been announced as available. Because there's nothing more embarrassing than showing up in front of a customer, having them ask you about something that was just announced and having you not have any idea, right? So there you go. And to kick things off in the compute in the cloud section, we have the aws.amazon.com/EC2 page, right? So this gets you going. So is everyone good with this? Did that help? Right? Knowing where to look is half the battle. And the good news for me, and again, I used this a lot, is they organized it in a way that makes sense. Right? If I know what the name of the service is, chances are good I can find it. Now, the other thing I'll tell you is not only do I share with you a slide deck at the end of the course, I will be sending you a document which has got most of these links on it. So all of the relevant links for the things that we talk about in the course are going to be provided to you in a single document. Now, a lot of folks want to make sure they're in control of their own destiny. They jump on these things, and I will occasionally plug one into chat, right? But because there's only me here and I'm focusing on the content, hopefully this gives you guys enough to know where you can go to look for it. Okay, so EC2, let's talk Elastic Compute Cloud. And the name comes from the fact that it's an E and two C's, right? EC2. So here we have, there's E, and then there's two of those, right? So it's EC2. There we go. Not that that's particularly exam relevant, but there it is. So what it is a virtual machine in the cloud. It's secure, it's scalable. If I need a new virtual machine, I'll log into the console and I deploy the thing. I choose what operating system I want, whether it's Windows or Linux or otherwise, even Mac. It will boot almost, it boots very rapidly because depending upon how you configure it, but still, it's all based on relatively high performance hardware, typically solid state drives in the back end, and you only pay for what you use. In other words, if I start up a new EC2 instance and I run it for 2 hours and I shut it off, I literally only pay for 2 hours of use. Well, that's kind of nice. What if you wanted to do testing on some new application? Well, you need a new Windows server to do that. You launch it. By the way, it's a fully licensed Windows server when you do that. And then away you go, right? You use it, you shut it down, you only pay for the time that it was up and running, which is fabulous. So you launch it, you then connect to it, you install whatever software is relevant for that instance, because don't forget, a virtual machine with an operating system is not a very useful tool, right? Operating systems by themselves don't do much. It's all about supporting the applications that run on top of them, whether it's your own database server or maybe a web server, perhaps some sort of other application server. Maybe you've developed some specific code that you need to run. Fantastic. Create a virtual machine, install whatever it is that you need on it, make it available and use it. And we'll talk about the networking piece in a later module, right? So EC2 instance types. So when I go to buy a computer, and again, probably like a lot of you, I'm in the IT business and my family knows that. So guess what? Whenever one of my family needs a new computer, they come to me and say, "Hey, Andrew, what should I buy?" And I generally ask a few questions, right? Primary question I like to ask is, what are you going to use it for? And so when my nephew comes to me and says, "Hey, Andrew, I want a gaming computer," that immediately tells me something. So let's stretch that. Take my nephew, go to the computer store, right? We physically go to a store together, and I talk to the sales rep and I say, "Hey, my nephew here is looking for a gaming computer." Well, at that point, that sales rep knows something about the system I want, the computer I want, right? Knows that it needs to be targeted for gaming. It probably has a good graphics engine. It might even have a graphics co-processing engine. It's probably got some fast video, right? In other words, the video display itself will respond rapidly. Refresh rates are very, very short. So that's going to tell him that I need to go and look at a certain collection of computers in the store. And maybe they organize those computers according to, that table over there has got all 10 of our gaming-based computers on it. And then when I get to that table, I subsequently choose the configuration that I want. Maybe I want one with, 2 terabytes of storage rather than 1. Maybe I want one with more memory as opposed to the other. But I know when I'm making that choice, I'm already sitting in front of a bunch of gaming-focused computers. Okay? So what's that got to do with this? So hopefully that story resonates. You guys are going, "Oh, okay, yeah, I can imagine that." Well, when I go to build a virtual machine, the same choices are essentially presented, right? So I want to run a basic web server or a basic application server. Well, I give you over 400 different configurations inside of the EC2 console. How do you pick one? Well, the way you pick is you start by telling me what you want to use it for, right? Is this a general purpose system? Well, if it is, maybe it's a basic web server, basic applications server, something just to be a utility server somewhere. A good balance of compute, nothing fancy. No, I don't need ridiculous performance on the compute engine. I don't need huge performance on the networking components. I just need a good basic utility server. Guess what? These are pretty cheap, right? As an EC2 instance type, they're fairly inexpensive, right? Now, don't forget, once I've chosen the type, I can then choose the capacity. You know, even though it's a good basic computer, I might need one with 4 processors and with 64 gigabytes of memory, as opposed to one that's got 1 processor and maybe only 4 gigs of memory, right? Maybe what I need is something that's going to be for batch processing. And batch processing typically happens, hey, at a certain time in the day, we've gathered a whole bunch of information, and now I need to do some number crunching against that. So I want that to go rapidly. Well, that's generally going to be compute optimized. And so what we do is we build a virtual machine on top of physical servers that have got incredibly high performance processors. So that would be a compute optimized one. But again, once I've chosen compute optimized, that says, oh, I got access to that fancy processor. Well, how many do you need? Right? Is this a 4 processor setup? Is this a 16 processor? But now there are 16 really high performance processors, as opposed to the general purpose ones, which were more basic. Maybe I've got an application like a database, which really works well for queries when it maintains a lot of the content in memory. So giving us a high performance memory channel with a lot of memory relative to the number of processors can often be a good characteristic for a high performance database. So memory optimized. And again, once I land there, I get to choose how much memory and how many CPUs and how much network. But the basic characteristics of the virtual machine are going to be focused around being very performant on the memory level. We also have accelerated computing, and a lot of people confuse this with compute optimized. Compute optimized says, give me a big fast processor or multiple big fast processors. Accelerated computing says, give me that big fast processor, but also give me a co-processing engine. You know, maybe this is some sort of an NVIDIA co-processing card that's actually in the physical server. And typically your application will be looking for that resource when you run the app, right? Now, again, obviously you have to have an app that is looking for that in order to take advantage of it. So maybe it's a streaming or a graphics workload type process. So accelerated computing usually relies on not only a core processor, but a subordinate co-processing engine, second processor as it were, that's of a different type. So it's not 2 CPUs, it's one core CPU and one co-processing engine, or it's 16 core CPUs and 16 co-processing engines, whatever, right? It doesn't have to be one-to-one. We've also got storage optimized systems, which are set up on physical servers where they have enormous bandwidth to the storage infrastructure. Usually really good for any server that's going to be supporting some sort of a big file system. So lots of different types of instances. So what we just showed you here, 5 main categories. Once you've chosen a category, you go in and pick it. So remember, it's like going to the computer store and saying, I'm looking for gaming computers. Maybe that's like looking at accelerated computing. And then once I've chosen accelerated computing, I then get to pick the configuration that works for me. I might need a small version. I might need a very large version. And I simply pick from there. Right? So here we go with a review question. And again, we're going to do these one at a time. So I only want the answer to one question at a time when I give them to you. So question number 1 is ideal for a high performance database. Based on what we just talked about, which of A, B, C, or D would you choose for question number 1? So high performance database. Now, according to the slides, that was a memory optimized configuration because databases, particularly for high performance, rely on the ability to get the information for queries rapidly. And the way you get high performance queries to work is you keep the content in memory rather than putting it on disk. Or you leverage lots of memory, high performance memory channels so that you can access the memory rapidly, right? What about suitable for data warehousing applications? What do you think number 2 is? Yeah, so data warehousing implies a large amount of storage, and if I had a really fast storage channel to get to that data, that would be good, right? So certainly, storage optimized seems to make sense. Hopefully number 3 makes a little bit of sense. We've only got 2 to choose from. A balance equals general purpose, right? Pretty much what you guys are answering. And then by process of elimination offers high performance processors, which, by the way, obviously compute optimized. If this were an exam question and you were not sure about the answer to question number 1, or portion number 1 of this question, maybe what you do is you look at 2, 3, and 4, and based on a process of elimination, you come up with the idea that high performance databases, right? Maybe you didn't know that, but if you know the others, so sometimes an exam taking technique, which is completely valid in all cases, is knowing what the right answer is not, right? What are the wrong answers? That can often lead to a process of elimination where you do select the correct answer. Okay. And that brings us to the EC2 pricing conversation. And I think now would be a really good time for us to take our first 10-minute break of the day. Before I fire off on break, I do want to make sure everyone understands the rules of engagement here. You have not been asking a lot of questions in chat, and that's okay. I'm hoping that nobody's feeling intimidated or shy. Please ask the questions, right? Chat is your primary channel for me to be able to deal with this, and I'm sorry that I've had to mute all of you, but history has taught me that far too many people unmute themselves at times that they didn't mean to. Just leave it at that. I could tell stories, and I don't want any stories coming out of this class. So if you've got a question, send it to me in chat. You can continue to do that during break should you want to, right? If that's a good thing. And it's a good question. So grading is partial, and the answer is no. You either get a question right or wrong. So if it's choose 2 and you choose 1 right and 1 wrong, you get it wrong. Right? The rating on a question by question basis, the grading of the scores is in fact you either get it right or you get it wrong. However, if you don't answer the question, you also get it wrong. Right? So there's no penalty to getting the wrong answer other than the fact that you don't get the marks for it. In other words, we do not select wrong from right. Okay. So there we go. So good question. So on that note, I have got a fancy little timer here. Let's fire up my break timer. And there it is. Let me choose a nicer background than that. We might as well start in the tropics. Why not? We're going to call this break. And we're going to put 10 minutes on the timer in Pacific time zone. It's a countdown timer anyway, so time zone really doesn't matter. I'm going to click start and go on mute. Again, keep the questions coming should you have them. And I would suggest stepping away from the desk, get a break. Literally, you're going to need it by the end of this day. We're going to cover a lot of material. So here's the break. I'm going to go on mute. I will see you in 10, of course, all virtual. All right. And we are back from break. At least I am. Hopefully the rest of you guys are. So several questions in chat that I do want to address before we move on. Again, you guys did exactly what I asked you to do, which is great. Dennis, previous slides on financing still being exercised to determine budget requirements for AWS. Yes, we actually have a dedicated tool that we leverage, or that you can leverage. It's called the AWS pricing calculator, where you can actually set aside enter the parameters around which you're actually building. So how much storage, how many EC2 instances of what size and all the rest, and come up with an estimated monthly cost. And it can also be estimated annually depending upon how you're purchasing it. We're going to talk about pricing shortly. So Dennis, you're on target. Yes, we can actually do budgetary process, but recognize that doesn't need to be an upfront investment, right? That's really the point to the early modules. We'll talk about the details of what you're asking later on. Dedicated servers for longer period of time. Again, this question came to me privately. Is it install the same software you want to access every time without installing it again and again? Well, an EC2 instance is a virtual machine, right? So if I configure a virtual machine with storage, etc., and I install some software on it, then that's my virtual machine. If I turn it off, it's still there for me. I will still pay for the storage that it's consuming because, of course, you installed stuff on it and you kept the disks. But if it's only running 2 hours a month or, however often you need it, it's still always there for you. Now, an alternative is you could build um, essentially a self-configuring EC2 instance. And again, there's ways to do that where I could deploy an EC2 instance with the same software on it from scratch every time, right? You can build essentially take an existing EC2 instance, take a piece of software that we use to essentially create a template based on that instance, and then subsequently deploy multiples of that, right? So yeah, uh, Darcy, I think that's appropriate. I think that's the question. And again, easy to do. If that's not addressing the question, then perhaps we'll try it again a little bit later on, and we're going to talk about some of this stuff later. Um, Anas, explain more about the difference between memory optimized and storage optimized. Essentially, it's very simple. When you configure, when you go to buy a physical server, you buy it with certain parameters. Some servers are built so that they've got extremely fast memory controllers, and it gives the CPU extremely fast access to the memory in the back end. Well, that's a physical server characteristic, right? When we build a virtual machine, it runs on top of a physical server. So when you say you want a memory optimized virtual machine, we'll run it on one of those servers that's got that specialized dedicated memory pipeline. Okay. In much the same way as if you had a storage optimized environment, that type of server would be characterized by having an extremely high performance disk channel available to it. So when it goes to access its disks, think of it as going down a 6-lane road rather than a 2-lane, backcountry road. Uh, it's really all about the physical server under the covers of the EC2 instance itself. And you simply choose the right type of server based on your anticipated workload. If the thing you're using doesn't do lots of disk I/O, then you probably don't need a disk optimized or a storage optimized instance. Right? For most of us, to be brutally honest, you go to deploy your software, you talk to the software vendor, and they will tell you what they want from a performance characteristic perspective, right? They'll tell you you should be looking at a certain type of physical server or at a server with these types of characteristics, high performance access to the memory channel. Well, then I'm going to go memory optimized, right? So that's where it comes down to. This just makes it easier. If I give you 400 EC2 instances to choose from, you're gonna be there for days. Well, which one should I pick, right? Because which one is memory optimized? Heck, we break them down. Here's the memory optimized one. Great big long list, and I'll show you that. All good? All right, so give me a +1 if you can see the EC2 pricing screen. There we go. That also tells me that you can hear me, which, after I've been talking for this long, will be a good idea. So let's talk about pricing options. The default pricing when you launch an EC2 instance is this. It's you pay for it as you use it. It's what's called on demand. It's very simple. There's no upfront costs. There's no minimum usage times. There's no minimum configurations. You simply launch the workload and you use it. And then when you turn it off, you don't get billed for it anymore. Okay. Relatively straightforward. Okay. This would be great for things like, maybe you want to do some software testing. Maybe you've got a project that's going to only last for 3 months. Well, on demand is great. But the characteristic of on demand from a price perspective is that compared to some of the other pricing methodologies, it's typically more expensive, right? Because there is no commitment. It's kind of like a pay as you go cell phone plan. Right, that makes sense to everybody, right? If you're going to go in and use a pay as you go plan, then your cell phone provider is not going to offer you a great deal on it. So on a per hour basis, you're going to pay a little bit more. And that's on demand. And that is the default. I could, if I understood my workload, maybe it's going to be my web server that's going to be running for 365 days of the year, 24/7. I know I'm going to be running that thing all the time. So when I start up my EC2 instance, I say, well, I'm going to do this as a reserved instance. That'll give me up to a 60% discount, depending upon the type of configuration that you have, over running it on demand. Right? So a one-for-one configuration, exactly the same config, comparing on demand to reserved, you can save almost 60%. That's a pretty good deal. But here's the trick. It requires a commitment. You have to tell AWS, all right, I want a reserved instance. I'm willing to pay for it. And you have to commit to either 1 year or 3 years. And of course, as you commit to a 3-year term, your discount increases. If you do a 1-year term, it's a smaller discount. Okay, probably makes a little bit of sense. Again, think about your cell phone plan. If you're going to commit to your service provider for 3 years, they're going to give you a good deal on that latest and greatest iPhone. Right? That's kind of the plan that works here. So, but here's the challenge, right? Reserved is a setting which is assigned to a single virtual machine or a single EC2 instance. Well, if I'm an organization that's got 500 EC2 instances, who here wants the job of figuring out whether this particular instance should be reserved or should be on demand? If I got 500 instances, I don't want that job, right? I would like a better way to do that. And of course, when we were young and when customers are first starting off, this is easy, right? They've only got 5 instances. They can pick which one they want for what. However, as you grow to be larger, maybe what you should do is consider purchasing what's called a compute savings plan. Now, compute savings plan, we got a couple of them. But in general, what you need to know here is that these are also a 1 or a 3-year commitment. But the way they work is a little different. When you acquire a compute savings plan, you're essentially purchasing compute credits. So I'm no longer allocating the discount to a single EC2 instance. What I do is I configure my EC2 instances to use the compute savings plan. So if I'm running 5 instances, they draw credits from the compute savings plan. If I'm running 10 instances 2 weeks from now, all 10 of them draw credits from that savings plan. So it's a bulk purchase of compute capability that you distribute across a whole bunch of different EC2 instances. So you're no longer managing your EC2 instance setting on a one-by-one basis. You get a discount on all your EC2 instances, including the ones that you turn on and turn off. Well, that's kind of cool. So I get a discount even though they're kind of on demand, right? Whenever they're running, they're drawing from the compute savings plan. But you have to purchase the savings plan with 1 or 3-year commitment. This is the oddball one. Okay, and I'm prepared for questions on this because I know I'll get them. Spot is a special type of instance. And it helps to understand where spot instances come from. So remember, when AWS builds a data center, we start with 50,000 physical servers. So I think most of you realize it's reasonable to assume that we've got some spare capacity, right? We've got enough capacity to run all of our customers' workloads. We've got enough capacity to run any workloads that we haven't thought about yet, right? Maybe my customer's got some new idea. Yeah, sure, I've got spare capacity for on-demand EC2, no big deal. But I've even got more capacity than that. And so what we do is we make available what are called spot instances for huge discounts. They're up to 90% off. With one caveat. And that caveat is we reserve the right to take that instance away from you should our capacity fall below a certain threshold, right? Should our available capacity fall below a certain threshold. So in other words, as the AWS data center gets busier and busier and busier, we're going to start to take back spot instances from customers. So why would anyone use a spot instance if it can be taken away? Oh, and by the way, the warning, 2 minutes, and it's a warning given through the AWS console. Now you can trigger it so that it sets off your cell phone with SMS messaging or what have you. That's no big deal. But think about that for a minute. Why would I want to run an instance that somebody can take away from me with 2 minutes warning? What would be the point? I mean, I get it. It's 90% off. It's a great price. But let's say that's my web server. Would that be a good idea? Let me ask a point blank question. Would it be a good idea to run your web server as a spot instance? I think most of us get that. That's crazy, Andrew. You know, the the AWS data center runs low on capacity, therefore you're going to shut off my web server? Like, forget it. So you never want that for things that have active user connections, right? If you're running a service that has active user connections, like a web server, you probably don't want Spot. But think about this. What if the application I have is a piece of facial recognition software? Again, I'm asking you guys to, put yourself in a position, imagine with me. You're running a piece of facial recognition software. You've got, 100 terabytes of graphics images, which are stored on some network available storage device. Okay. And so you want to run this facial recognition software against that library of images. Well, I could do that with a Spot instance because nobody's logged into the server itself. The process runs and does its facial recognition and writes the results of its facial recognition to some database somewhere, right? Oh, look, I found a picture of Andrew in that picture there. Okay, there we go. And if I have to shut off that instance because the AWS data center runs low on capacity, what's the big deal? It stops that back end process from running. And then when the resource is available again, we could have a process that automatically restarts that Spot instance. Let me put it another way. A customer could run 10 Spot instances for the same price as one on-demand instance. Think about that in the context of facial recognition, right? If they're all targeting that one library of files, I could be running 10 times faster simply because I've got 10 pieces. And they don't replace it with anything, Mary. It's your EC2 instance gets shut down. Right? That's a characteristic of losing a Spot instance, right? Spot is a characteristic of an EC2 instance. So if you choose an EC2 instance with Spot as its licensing model, when we shut it off, the EC2 instance gets shut off, right? It's no longer running anymore. So I think for a lot of people, recognizing that while Spot looks really appealing on the covers because of this huge discount, it's only really good for the right type of workload. Think about test and dev. Maybe you've got a whole test and dev team that's going to build out an entire. You could do that on Spot because if it gets reclaimed, well, the test and dev guys aren't able to run their tests, right? And yes, that's correct. And Dennis, you're right. If you have 5 instances, you would lose them gradually as capacity is needed. Now, again, it would also depend on what those instance types are. It depends on how big the spike is in our environment. But yeah, you might lose them gradually, but gradually in our world might be one every 30 seconds. It's like, oh. So you can't really predict is what it comes down to, right? And so, Mary, you're right. Ouch, right? That's a problem. And there is no transfer. There is literally nobody's responsible for transfer. If you're running a web server and it gets shut down, it's shut down. There is no transfer to anything else. It's a workload that you chose to run in this format, and you were taking advantage of a really good deal. But the downside is it could be taken away from you at any moment in time. And that means you have to architect the application properly, right? In the case of my facial recognition example, I was getting all the data from a network piece of storage somewhere. So it wasn't associated with the Spot instance. It's the Spot instance connected to it across the network. Maybe it's across the storage network, but it's still across the network. And then it's writing its data out to some database somewhere else, right? So when you shut off that instance, well, it doesn't do facial recognition anymore, right? What's the big deal? And if you architect your application properly, Spot makes sense. I think for a lot of you, you've probably realized Spot just doesn't make a lot of sense for the traditional day-to-day workloads. Everyone agree with that? Right? It is a special use case. And it's a great special use case to save a bunch of money. Test and dev. Oh, absolutely. You can mix reserved with Spot. Absolutely. So Dennis, in the case of your web server, maybe you want to run one reserved instance and then a bunch of Spot for the additional workload. But I'm also going to suggest that maybe even that is not the best answer. Because again, when are you going to lose capacity? Well, when the AWS data center is busy. When do you need capacity? Well, probably when the AWS data center is busy, right? Think about Black Friday. If you're running a web server as an e-commerce customer, on Black Friday is probably the time that AWS has the peak load on its resources. Well, I don't want to run my extra web servers as spot instances at that point because, like, wow, when I need it the most, when all my customers are hammering my website, AWS is going, yeah, I'm low on capacity, so I'm going to take away those spot instances, right? And no, we don't actually provide that on a day-to-day basis. So Daniel, good question. Any way to get visibility into the data center capacity levels? I will tell you that you can run some historical reports on particular, because each instance is based on what is it? Is it a particular instance type? Because we may have more capacity on one instance type as opposed to another. So if you're running that particular instance type where, that particular processor is at a premium, then maybe that's the one that gets shut off first, right? Yeah, absolutely. So, that Dennis, you're right on target, right? If you lose spot, then it just slows down until you're left with just the on-demand stuff or a reserved instance, as the case may be. And absolutely right, Oleg. The customer is responsible for saving the state of the workload. When you set up a workload, you can define exactly how it shuts down. It could be just a terminate where it just turns off, or it could be a proper safe shutdown when EC2 starts to reclaim its capacity back for spot. Your thing could do a proper Linux or Windows shutdown. And of course, if it writes the disk and all the rest. And it is done on a region by region basis, right? It's regional, David. So good question. Again, because it's the data centers within the region that actually deal with that. Okay, two additional types of instances, and these are special. Okay, and what I mean by that is, and I think what you need to know for the exam purposes is what's the use case, right? At a certain point, we can spend a lot of time understanding the underlying details, but a dedicated instance, if you read what it says on the slide, says it's an EC2 instance that runs in a VPC, don't worry about that, virtual private cloud, on hardware for a single customer. In short, if I'm running an instance, I'm only ever going to be running on servers that are running my instances. So let's say I'm the company called Coca-Cola Company, right? I'm running the IT shop for Coca-Cola. If I choose dedicated instances, that means this EC2 instance will be running on a physical server in the AWS data center that is only running other EC2 instances for the Coca-Cola Company. Everyone good with that? That's what it means. But the question is why? Why would I need that? And that's, like I can talk about what it is. Security, maybe, good answer from both of you. But generally speaking, and again, security could be relevant in your world. I mean, maybe your organization has got some reason that they believe that that's the right answer. But generally, what happens is this is based on regulations. Something in your company's operating model, whether it's because of the industry you're in and the industry regs say when you're running servers, they have to be on hardware that are only running servers for your organization. I know that HIPAA has got some of this requirement. So it's all about compliance. That's right. Right? Compliance is the other term. Regulations, regulatory compliance. Okay. So this is a cool option because it says with a couple of clicks of the mouse, you can set this up so that your EC2 instances only run on servers that are also running your other EC2 instances. Okay, so that's pretty cool. Now, one of the things about this, let's assume for a moment, and I'll draw a little picture. These two are physical servers, right? And let's say that we're running instances. These little boxes here are instances. And let's say they all belong to the same organization, right? when I shut off this instance and restart it, it might restart over here. And that is okay with a dedicated instance. Why? Because these two hosts are only running instances for that one organization. But this instance could move back and forth. Are we clear on that? A dedicated instance can move between hosts in the data center. Everyone okay with that idea? I know it says dedicated, but it's dedicated to hosts, plural, that are running instances for that one organization. Okay, and the reason I'm making a big deal about that is because of this. All right. A dedicated host is a different animal. Okay. Let me just get rid of my goofy diagram here. A dedicated host says that this EC2 instance will only ever run on this one host. Full stop. You can reboot that instance 1,000 times. It will only ever run on that one host. Why would anyone want this? I mean, this is attaching a virtual resource to a physical resource. And the reason is easy, right? Oops, I need my pen. Sorry. Let me fix that up. Licensing, right? The reason for a dedicated host is typically related to, and the best example I've got for this is database licensing. If you've got something like an Oracle database server or a Microsoft SQL server, when you read through the license agreements, if they're running in a virtual world, which is what the cloud is, then in order to be in license compliance, you have to be able to prove that this database server is only capable of running on one physical server. Right? And that dedicated host becomes dedicated to that one instance. If the customer is only running one instance in this fashion, then that entire host is theirs. Right? Now, they could run two instances on that dedicated host, but I like to read dedicated host if you change the phraseology a little bit. This is an EC2 instance dedicated to a single host. That's what a dedicated host means. It's an EC2 instance dedicated to a single host. And the reason that we do this is because if you ever got audited from Oracle and they come in and say, well, okay, according to the license agreement, everywhere that this Oracle server is capable of running, you owe us a license for it. So if you just run it as an on-demand instance, and there are 5,000 servers of that configuration in our data center, you might owe Oracle for 5,000 licenses. Ouch. And again, it's an extreme example, but there it is. So both Microsoft and Oracle will leverage this option. So this is a little more expensive for the customer, but it's a heck of a lot less expensive when it comes to the actual application licensing. But it's only required for those servers that have that, right? Yes, always. Yeah, Oleg, yes. And we haven't talked availability zones yet, but yes, you're correct. And for a dedicated instance, which is the hardware is dedicated to a single customer, yeah, that is the point to a dedicated instance, Howard. It will run many, many instances, but they're all running for just that customer. Right? But recognize if you restart an instance, it could move servers, which of course that would be a problem if you're trying to do licensing. So typically dedicated instance is based on regulatory compliance. Dedicated host is typically aligned with licensing, application licensing. Okay. So what if I need more? Right? What if I need more? Well, what do you mean? Well, in the case of, let's take a look at a coffee shop. When I go into the coffee shop and there's, one person making coffee and there's only two people in line, the lineup isn't very long. It doesn't take very long to get your coffee and everybody's happy, right? But as the manager of the coffee shop, as more customers show up, What I probably want to do is grab a second barista who might be doing some paperwork in the back room or some inventory and bring them up to the front so that we can now have two people making coffee as the lineup gets longer. Right? Very simple process that most of us have seen in real life. I'll be brutally honest, it seems that every coffee shop I go to, there is no one else to put on, but that's a whole different discussion. So let's talk about auto scaling. So EC2 auto scaling works on the basis of this. You build your first EC2 instance. You can leverage that instance to create a template so that you can launch more EC2 instances that look exactly the same. And then you configure the auto scaling process to say, what are the terms that I'm going to run more than one instance, right? So am I going to have one web server or am I going to have two or am I going to scale to four, right? And so an auto scaling group has got several parameters built into it. It says, and I'll start with the desired, because again, this is, I'll be honest, this slide is absolutely accurate, but the terminology that's used, and it's also used in the interface, is a little confusing. So your desired value equals your startup. So in this particular example, what they're suggesting is that these are EC2 instances, right? Each one of these items is an EC2 instance. When I launch this server, whatever it is, if it's part of an auto scaling group, we will start it with two, right? Because notice that the desired here is set to two, right, according to the parameter. So when I launch this, two web servers will start up in my fictitious world. Oh, that's pretty cool, right? So I don't just get one, I get two. And they're built off the same template, so that's cool. So they get started, instantiated, and run quite nicely. And then as the demand increases, according to the parameters that I set as an administrator, that could be CPU time, it could be memory utilization, it could be a combination of parameters. I can say what are the circumstances whereby we're going to add more instances to this environment. In other words, if you look at the coffee shop, what are the circumstances under which I'm going to add a new barista? Oh, well, the lineup is really long and out the door. Or, oh, wait a minute, we just got an order for 50 coffees from one customer, right? Not a very long lineup, but that one barista is now incredibly busy building 50 different coffees, right? So maybe I want to add a second barista just to handle the small amount of traffic we got over and above that. So you set the parameters. And then you set a value that says scale as needed, which is kind of cool, right up to the maximum. And the reason we define a maximum is fairly straightforward. For a lot of customers, they look at this and they go, well, hang on a second. I understand the desired, which is my startup value. I understand scaling because let's face it, if I have additional traffic, wouldn't I want to just add more resources to handle that traffic? Well, probably, right? But wait a minute. What if the traffic is fictitious? What if there's a problem in the web server software, right? So what if my software runs into an infinite loop and it all of a sudden is really busy and that says, oh, add another instance. And of course, that instance has got the same problem in the loop. So you keep adding instances ad nauseum. Well, don't forget, you pay for what you use. So we probably don't want to have some maximum or an undefined maximum. I want to say, all right, I can normally work with two web servers of this configuration. Under last year's biggest scenario, we got it up to 6 web servers. So maybe I want to set my maximum at 8, right? Because I know that, hey, if we have a great year, maybe we're going to have more traffic and I should be able to handle the traffic with 8 web servers. So that's where maximum comes in. It stops you from just spending a ridiculous amount of money in the event of either a denial of service attack or a flaw in your software. Well, what the heck is a minimum in that case? Now that we go the opposite direction, what does this minimum value mean? Well, in this case, they're setting it to 1, right? And what that means is, in as much as auto scaling will add capacity as you need it based on load, it can also take away capacity as you do not need it. So let's say I fall below the threshold where I need 2 servers to actually service the load. Again, parameters that you set. Well, it can start to turn off extra EC2 instances so you're not billed for them. And it can turn them off right down to a bare minimum, which, by the way, is also another really cool feature of an auto scaling group. Because if you say the minimum number is 1 and that server fails, it will relaunch a new one to replace the failed existing one. So think of this as almost clustering, right? You will always have a running instance if you define a minimum number. Even if something fails, it'll go, oh yeah, that's no problem. We'll just replace it with another one. And you don't have to install any fancy software within the guest operating system. That's a very cool feature. So is everyone cool with auto scaling? Startup value is desired. Scale up to a maximum based on load, and you define what that load is. Minimum value, it will shrink down to a smallest amount. And again, you could set the minimum to be 4 if you want, right? If you know that's what your web servers need to be able to be efficient and scalable, etc. That's your challenge. And if you fall below the minimum, the auto scaling group will replace anything so that you are now, again, back at minimum, which I think is a really cool process. Well, that's wonderful. So I've got more web servers than I need, right? Or I've got more web servers than I had. The problem with this is like, in the coffee shop instance, it's pretty easy. Everybody goes through the cashier and then the cashier hands the work to the web server, right? Well, or to the barista. In the case of the auto scaling group, as you add more web servers, you're going to need a way to distribute the traffic that's inbound so that they don't just all keep going to the same one web server. And that is the point to load balancing, right? So we've got this thing called the Elastic Load Balancing Service, which is generally speaking meant to balance the load coming to your various different targets. And what ends up happening is you register the Elastic Load Balancing Service with DNS as the front end of your web servers. And then at that point, all your customers go to this one IP address, which is the Elastic Load Balancer. And it then figures out how many running web servers there are as a part of the auto scaling group, because again, they talk to each other, and it will distribute the traffic as appropriate. So generally speaking, auto scaling groups are cool because they give you the ability to scale and handle more load. And the elastic load balancing combined with it automatically distributes the load to the available web servers. Okay. And settings are absolutely adjustable after first setup. Yeah, I mean, you can change this all on the fly, up to you. So, Spencer, did I cut out? So can somebody else answer that question for me, please? I don't know because I can't hear myself. Okay, thank you. Yeah, so I'm going to enable you for you guys. If someone comments about audio and you're not having any problems, please let them know. Yeah, and that's cool. Yeah, I get it, and that's exactly the behavior I want. I need you to be empowered to ask the question about audio. So yeah, absolutely, great way to handle it. So, and if you guys see a question in chat about audio, please feel free to respond. Because hey, it's important that I know too, right? Because what happens if everybody's audio goes down? Well, the problem is probably on my end. I need to know that. All right. So elastic load balancing, really cool process, right? So during a period of low demand, the elastic load balancing service handles the inbound traffic and sends it to the available EC2 instances. And during a period of high demand, as the EC2 instances, add more instances to the environment, the elastic load balancer simply distributes those. And this is one of the big advantages we bring to the table. Both the elastic load balancing service and auto scaling groups are services that are inherent to AWS. And what I mean by that is you don't have to install a server and then install the elastic load balancing service on top of it. It's built into AWS. So as a customer, you are no longer responsible for worrying about is the load balancer up and running, right? The load balancer is an inherent service. You configure it for your use, and you don't have to install any more Windows licenses. You don't have to manage any more Windows patches or Linux patches for that matter on that engine. Whereas if I was doing this in my own data center, I would have to install my load balancer on a server and then continue to maintain that server. And I would probably have a, a process where I would have two load balancing servers running as a cluster, right? So there's a lot of maintenance involved in running a load balancer on premise. As we've alleviated all of that, it's a fully managed service called Elastic Load Balancer, and it's available to you. You simply configure it, right? And so Everett, yes, the Elastic Load Balancing service is an added feature cost, right? So there is a cost associated with it. And how would I find that? So believe it or not, aws.amazon.com/ELB as in Elastic Load Balancer. I think that's correct. This is one of those where I'm going to look like an idiot, but there you go. No, it's not there. Rats. That's right. This is the one that spells it out. Um, Elastic. Yeah, Elastic Load Balancing. There it is. Sorry. I'll give it to you in chat again. Copy, paste. And come your way. Okay. And folks, one thing I can guarantee you on this exam, you will never, ever, ever get asked a question around how much does something cost? Because it varies by region. There are all sorts of parameters under, you could never remember it anyway. Now, from a point of interest perspective, when you're talking to your customers, absolutely, you're going to want to know this. So again, here we go with the pricing page, Elastic Load Balancing, go to pricing, and you can either run the pricing calculator, which I talked about, or you can actually look at the various different configurations, these things, so for application load balancers in AWS regions, it's $0.0225 per application load balancer hour or partial hour. In other words, not a lot, right? It's just not that expensive on a day-to-day basis. This is a relatively inexpensive service. In short, if you're going to have any kind of auto scaling, you should have elastic load balancing, and the overall incremental cost is negligible. And again, you can work through the pricing calculator that we're going to show you in the last module, or second last module, I guess. Okay. So bear with me on that one. Stay tuned, as it were. All right. So there is elastic load balancing. So here's the question, right? 6 questions that we're going to go through in chat. Give me either an A or an E. That's all I really need. So it's either auto scaling or elastic load balancing. So question number 1, removing unneeded EC2 instances when the demand is low. Is that auto scaling or is that load balancing? Yeah. Anytime you add or remove instances, that's auto scaling, right? Adding a second instance during an online source popular sale. Again, it's adding an instance, so it gets auto scaling. Distributing a workload across several instances. You betcha, right? That would be E. Ensures that no single instance has to carry the full workload on its own. Similarly, again, there's no additional removal of services here. We're distributing, so that's load balance. Automatically adjusting the number of EC2 instances is, you guys are on fire. Auto scaling, and then providing a single point of contact for traffic into an auto scaling group would be elastic load balancing. You betcha. Right on, right on. So hopefully that was useful. And I do want to emphasize, and again, this is me trying to make a point here. To do either auto scaling or load balancing in your physical data center, you would typically start by installing at least one server, if not a pair of servers, configuring your auto scaling software on those 2 servers. And from now on, you're now managing those 2 servers. You're taking care of the care and feeding of these servers. They need patches, they need occasional maintenance, they need to be backed up, they need to be configured. That's not part of it in AWS. You simply go and configure the auto scaling group or the elastic load balancing service to do those things for you. And you do not patch those servers, nor do you have to license operating systems to make those work. This is a huge advantage to running auto scaling and elastic load balancing in the cloud. Yeah, sure, we charge you a little bit extra for it, but trust me, you'd pay more than that for the licenses on the servers that you would need to run them in your physical data center. Okay. All right, so let's talk messaging. What do you mean messaging services? Well, here's here's the thing that you run into. If you've got a customer who's developing their own applications, then they've got a couple of different ways to build applications, right? And historically, applications were written in what's known as a monolithic application, meaning that for any application, all of the parts of the application are installed on one server, right? All of the bits. So there's, for instance, component one could be video. Component two could be the actual calculation capabilities. That's the compute engine. Let's say it's a spreadsheet type application. Oh yeah, that's where we do all the calculations. Component three could be keyboard, right? And component four could be, I don't know, network access. But all of those things are built together. So in order to make a monolithic application run faster, in other words, you didn't write the code. This is some program that you've got, and it needs to run faster than it currently runs. How would you make it run faster? How do you make a canned application that only runs on one server faster than what it is now? It's not a trick question, even though it appears to be. Yeah, you typically have to run it on a bigger computer, right? You need to do a hardware upgrade. You need to run it on faster processors. You need to run it with bigger memory footprints. Something about the one server that's running that program needs to be increased. Okay. So how do we get away from that? How do we make it so that we don't have to just build great big monster servers to run an application faster? Because at a certain point in time, let's face it, you can build a bigger server, but there is a finite limit to that, right? Well, the answer is to write your applications differently. Now, again, if you're self-developing, in other words, you're building your own apps, then this is a process that a lot of customers have taken on. They've gone about building what are known as microservices-based applications. So in other words, you know, interfacing with a particular component of the application is written as a standalone component. And in order to make this program go faster, right, because the program itself is still the program, it's built up of 4 components. But I could now make this a little bit easier, right? What I could do is I could run, let's say component 2 was my compute one. I could give it its own server, and then I could run the other 3 components on a different server. Right, because they're just utility components. And I could make this some great big smoking 16 CPU monster, whereas these could be on a good basic utility server with 2 CPUs, right? And if I want it to go even faster yet, I might even run this component, that component number 2 could actually get run 2 times. I could run it on a second server or a third server or a fourth server, right? Because I've broken my application into discrete components, I can now place those components on a resource that makes sense so that they run the best way possible. In other words, I got flexibility. But what's the challenge, right? And the challenge is always this, right? So you've broken up your application into components. How do those components talk to each other? Well, as a developer, I could write that code myself. Who here wants that job? And feel free to say not me, right? I mean, no. Why would I want, under what world would it make sense for me to build a microservices-based application and then have to layer on for every single component, I have to write the code necessary to talk to the other components? Why don't I call a network provided function? And that's exactly what happens, right? So we provide 2 underlying services. And again, remember, these are services, and that's a big deal because these are they're just available. You don't have to install an operating system. You don't have to patch an operating system. These are services that are there. You call them. So we have the simple notifications service where we take messages that get published to topics. And then anyone who subscribes to that topic will receive any messages distributed there, right? We've all seen this, right? If you go to a particular website and you subscribe to their mailing list, if they send you stuff about coupons, coffee, trivia, and new products in the monthly mailer, then guess what? You get all those topics. Right? It's not selective. I could, however, build out 3 separate topics and ask my customers to subscribe to the newsletters that make the most sense to them. And then when I publish updates with new coupons, only one person gets it, right, in this scenario. Whereas if I publish information about new products, only one person gets it. However, coffee trivia goes to 2 people, according to this scenario. Because again, the individuals themselves can subscribe to either one topic or multiple topics. Think about that from a distributed application perspective. You've got component 1, 2, 3, and 4 that need to talk to each other. And, well, when do they need to talk to each other? Well, when an update happens from one component, it posts a message to a topic, and then that's automatically read by the receiving component. So a developer could choose to write their application to leverage this thing called the Simple Notification Service, or SNS, right? Alternatively, because notification isn't necessarily the best way to talk between applications, I mean, it depends on the app. Sometimes it is the best, but what are the characteristics of the application itself? Sometimes a queue is more appropriate. So let's take a look at a queuing service in real life. If you take a look at a typical coffee shop scenario where the customer comes in and places the order with the cashier, right? So this is step one, customer comes in and orders. Well, the cashier says, okay, great, takes the money from the customer and then hands the order to the barista. Well, that's great. But what if, in this particular instance, this customer orders 50 coffees, right? So if they've ordered 50 copies and the cashier gives that order to the barista, now there's an incoming order of 50. Is it safe to say that the barista is going to be busy for a bit? Well, of course, right? That makes sense. And therein lies the problem. Because what happens if customer number 2 comes through the door and wants to place an order with the cashier? Well, the cashier can't really do anything about it because the barista hasn't completely received the order yet, right? He hasn't been able to, it's not a handoff process. They're just sitting waiting, right? I'm still working on those 50. Give me a break, right? So the answer, of course, I think most of you have guessed what this is to change the program, is to have that customer come in, place an order for 50, that order goes into the queue, and now this cashier is available. They have handed off that process. And now the cashier is available to take my order. And maybe my order, when I come through the door, all I'm looking for is a pastry, right? I don't even want a coffee. In which case, my order never goes to the barista, and maybe the cashier can just hand me that pastry and I can be gone. And that's where the advent of a queue becomes really important, right? Is it frees services so that they are not reliant upon other services. And quite frankly, the barista is not reliant upon the cashier in this case either, right? All they care about is the queue. Let me go check the queue. Oh, the barista or the cashier went to the restroom? No problem. I can just go check the queue. Oh, there it is. And I got to build these 50 coffees. It depends what your application is. This is an example, right? It's a very simple example. So we provide both the simple notification service, which deals with topics, and the simple queuing service, which introduces a queue to the program, and away you go from there. All right, developer chooses which version they want. That becomes relevant, particularly in the advent of microservices-based applications, right? Where we're taking that monolithic application that normally lived on one server, and we're now trying to write it in such a way that it can be distributed across multiple servers. Well, what if when I'm building an application, I don't need to deploy a server first, right? Our typical world of building applications, whether they are monolithic or microservices based, has been to have some servers installed with an operating system, have some interpretive languages installed there. Maybe it's a .NET application, so I need the .NET framework installed. And then I write my code to do what it's supposed to do, install it on those servers, and then that code runs under the right conditions, and the software does what it's supposed to do. But what I've now introduced to the world is that I've got 2, 3, 4, 10, 50 servers that the IT department needs to maintain. You guys agree with that? I mean, it's a very simple process. If you install servers in your data center, you have to maintain them. If I need servers to run my software, I need to install the servers. It's straightforward. What if I could tell you that you don't need to do that anymore? What if I could tell you that all you need to do is write your code according to a standard and then upload it to a service? Remember the characteristic of a service? Service is sitting waiting for you to do something with it. You configure it for your purposes, and you no longer worry about things like patching operating systems because, frankly, you, the customer, doesn't worry about the operating system anymore. And that's exactly what serverless computing is. It's serverless from the perspective of the customer. The customer writes the code that's going to execute. The code has to be written to a certain standard. And again, the development environments include things like Python and C++, and all the .NET type environments, right? There's loads of programming environments available for this. You upload your code to the serverless compute engine, and when that code is triggered, it runs. So what's the advantage? Well, obviously, I don't have to worry about servers and patching them. Step one. Secondarily, you get billed for, like, this costs you only when the code runs. So think about this for a moment. Let's imagine a scenario where you're running a web server and it's an up and running 24/7 activity. It's running on a fully fledged EC2 instance. So everything's happy, right? One of the pages on your web server says subscribe to our mailing list. So it's a form, right? Fill up a web form. Customer fills in the web form, contact information, mailing address, email address, blah, blah, blah. And then they click submit. What if that submit button actually ran some serverless code, which said, upload this to a database, right? So you click submit, it triggers a piece of Lambda code or serverless code running on a server somewhere, right? That AWS manages. And that code then triggers an event which updates the customer database. Andrew just registered to receive the mailing list. And then that subsequently triggers another piece of serverless code that notifies the marketing department, and then triggers another piece of code to send Andrew a copy of the latest newsletter. Right? Because I subscribe to the mailing list, I should probably give him the latest newsletter, even though it was out of sequence. So Andrew submits his information through the web server. That triggers 3 pieces of serverless code, and the customer literally only pays for the amount of time it takes that piece of code to run. So Dennis, you are right on target. AWS Lambda is the name of the service which we use to be serverless, right? Lambda is our serverless compute engine, right? So serverless is a generic statement. Lambda is the name of the service that we use in order to run this code in a serverless fashion. Well, so the scenario that I gave you is pretty cool. Some guy lands on a web page, fills in his form, and it triggers it, and I may get billed for, 50 milliseconds worth of compute time. Well, think about that for a minute. If I only get one person subscribing a week to my mailing list, I literally pay for a few milliseconds of compute time when they subscribe. And on a weekly basis, that falls into the almost nothing category, right? It's so cheap, it's ridiculous. And in some cases with Lambda, you may find that actually falls under the free barrier. So, it may not cost you anything. But what about the opposite? What if all of a sudden we get 1 billion people subscribing to our mailing list? Let's say we took out an advertisement on some incredibly popular, maybe it's a soccer program, World Cup type thing. And we've got this new thing and we want everybody to subscribe. So we go, ta-da, away we go. I've got 1 billion people trying to subscribe and they all do so in 10 minutes. Well, hang on a second. If I was running a piece of software on my servers and all of a sudden 1 billion people tried to launch that piece of software, I would probably cripple my server, right? I mean, depends what the server's doing, but that's an easily predictable scenario. And that is simply not the case with Lambda, right? Lambda is infinitely scalable in the back end. It's a service provided by AWS. We provide what we call unlimited scalability for this thing. So if you got a billion people hitting your Lambda code, who cares? And Daniel, I'm assuming your question is there the same challenge as Spot Instance, talking about it, shutting down. No, Lambda services are always running. It's just the software itself has to be built in such a way that it is triggered to run. There needs to be a start and an end to every one of your software functions, which is why I said subscribing to a mailing list may be made up of three components. One, I'd like to subscribe, submit, right? Okay, so that triggered a database update. That's one function. The next function might be send an email to marketing to say we had Andrew subscribed. Okay, there's a second function. Every piece of Lambda code has a start and an end. And the other trick with Lambda, when we're getting way beyond what you need for the exam, is it does have one side challenge in that any code that runs must complete within 15 minutes. So if your code is going to be a continuous query of a database somewhere where it's a cyclical thing and it's going to be running for 7 hours at a time, or you want to use it for facial recognition and you write a single piece of code that does all of that, that may not be the right answer, right? You may be better off served by installing a piece of service or maybe running it as a containerized app, which we'll talk about in the next module. Okay. Did that answer your question, Daniel? Perfect. Yeah. So, Ebenzer, stay tuned with Docker, um, because Docker is container based, and that's a different thing. Right? Lambda is serverless compute, and you write the code to run natively on the Lambda engine, right? So it's a very cool thing. And as in the case of traditional cloud, not serverless, servers management consists of for. So good question. So, and again, that's a really good question because I think it factors in here. It tells me that we need to step back. So if in the case of a traditional cloud where I'm not running serverless, right? Let's assume I'm running servers, like I want to run a couple of EC2 instances running Windows, and I've got some .NET code that's installed on those. Well, it's just like running a server in your data center. I don't worry about the physical hardware because, again, that's handled by AWS. But I do worry about the operating system, and I am responsible for all security patches for that operating system, right? So if Microsoft ships updates on a Windows server for security patches, it's the customer's job to maintain those. So that's what you get away from when you deal with Lambda, right? You don't have to worry about the servers anymore. And I don't have to worry about how many there are or how big they are. Because remember, in the case of I only get one update to my mailing list a week, and then all of a sudden, because of an advertisement, I get a billion updates. I mean, who here could predict how big that environment would need to be? You know, whereas with Lambda, you don't have to. You just make sure the code is loaded in Lambda, and when you get a billion accesses to it, AWS scales the back end for you, right? And Dennis, I can't answer that question absolutely specifically, but if Microsoft or Azure has a serverless compute engine, they are typically going to be serverless around a programming language like .NET, right? And we support code written in .NET. We support code written in C++ and Python and all these other languages. It's just code, but it has to be written to be triggered, right? And away we go from there. Yeah, so it's a pretty cool process. So for the purposes of this exam, and I recognize that a lot of you guys are very inquisitive, and I totally love that from the perspective of my students. You're paying attention. But for the purposes of the exam, what does Lambda do for me? Well, it's fully scalable, triggered compute capabilities that I only pay when the code is actually running. So I can run as little of it or as much of it as I like. AWS manages the scale in the back end without the customer having to worry about any of that. And the customer literally pays for the compute time that is consumed. And by the way, it is billed down to the millisecond. So 1 millisecond of compute time is the smallest interval that we're going to bill you for. and it's relatively cheap. Plus, I can give you a little hint. All customers, regardless of how long they've had their AWS account, get access to 3 million compute seconds of Lambda every month for free. Yeah, yeah. Oh, Oleg, I can get myself in all sorts of trouble by saying that. I think I understand why you're saying that. It's more like it's more like writing your code to a standard and uploading it to a server that you don't manage, right? Not really an API because it's your code that still gets, you're not calling an API. You're writing your code and you're uploading it to a server, right? The trick is you don't own the server, right? The server's not yours. You don't worry about the management, the care and feeding of your server. And we only bill you when your software runs, as opposed to a typical Windows server that if it's running an EC2 instance, you got to pay for that for the entire time it's running, even if it's not doing anything. Yeah, and it's 3 million compute seconds per month for free, right? So where would I go to find more about this? Do you believe? aws.amazon.com/lambda, right? David, good question. So let me talk about the next piece, right? Again, this is the tail end of the Lambda piece, right? Upload your code to Lambda, set the code to trigger from an event source. I click on the subscribe button on the web server, right? The code runs when it's triggered and you only pay for the compute time that you use. Pretty simple, right? We do provide container services. So things like Kubernetes, right? Why would I use Lambda versus Kubernetes? Well, so let's talk about what we do for containers. And again, I think it's reasonable to talk about a brief history of containers before we go there from here. And actually, you know what? I'm looking at the clock and I just realized that's probably a bad thing to do right now. Tell you what, why don't we take a break, right? And I sincerely appreciate the questions. This is a good spot for us to interrupt the flow, and then I'll come back and pick up the ball and run with container services. So bear with me for a moment while we break out of here and get back to my fancy break timer. And I'll get rid of the configuration there. There's my break timer. And there's 10 minutes. We'll click on start. Okay, so we're going to take 10. I will come back and answer any outstanding questions that are still here, and I know there's a couple of them. David has asked a great one, which I will address once we talk about containers first. Okay, so quick break, get a stretch, beverage, whatever it takes, and we'll be back. Alrighty then. So, give me the old +1 if you can see the AWS Container Services slide. Thank you. The question we left off on was David asked, why would you use Lambda as opposed to, say, Kubernetes or some other container management services? And that really was a spectacularly well-timed question. And I mean that sincerely, because we're about to talk about container services. So if you have a customer, well, let me back up for a moment. What I'd like to do is take a moment about what containers are and why they came about, right? And at a very, very simple level, back in the day, you had a virtual machine or a physical server with an operating system installed, right? So as I'm showing you here on the screen, if you take a look at this, so I got a VM or a physical server, there's an operating system installed. As a part of an operating system, part of what it does is it provides a foundation upon which programs can run, right? There's shared libraries and function calls and so on and so forth. And so those are considered common to the operating system. And then if you install app 1 and app 2 on that operating system, then those two apps will call those shared binaries and libraries, the software that's available made of the system. Those we'll call it. The problem with this history is that if we were going back to the days of Windows 3.1 and other versions of multitasking operating system, if app2 needed an update to one of these libraries, often app2 would try to update the library when you applied patches, and that would cause app1 to fail, right? Oh, right. Okay, so in other words, for those of you who have the strong Windows background like I do, running Exchange and SQL on the same server, while it was technically possible, was considered a very poor best practice for many reasons, not the least of which was potential conflicts. So the answer was very easy, right? You would build two different servers, right? You would build two different virtual machines, two different physical servers, whatever it was. You would install an operating system on each one of those, and app1 would have its own server, app2 would have its own server. And this is where virtualization just exploded, right? The whole idea behind being able to run virtual machines on one physical machine, yet each virtual machine has its own unique operating system, thereby allowing me to run SQL Server as app1 and Microsoft Exchange as app2 on two different virtual machines that are potentially hosted on the same physical server. This is a great deal, right? So that works really well. So that's still not containerized. So the problem ended up with being this. What if app1 and app2 were relatively small? Think about that microservices based thing. Well, an app now could be a very small piece of code that does one function. Well, okay. Does it make sense to run a very small app1 and a very small app2 on a unique server? Well, don't forget, typically at the operating system level, there is dollars involved. There might be dollars for licensing it if it's Windows or similar. Now, you could say, oh, yeah, but Andrew, we use open source versions of Linux. We don't pay licensing. How much does it cost you to maintain those discrete operating systems? Right? Don't forget, you still got to patch them, you still got to maintain them, you still got to take care of them. The care and feeding of an operating system is far more expensive than the licensing cost. Okay? So what if I didn't have that? What if I could make sure that app1 as a small component and app2 as a small component did not interfere with each other at the operating system level? And the answer is to move to a container orchestration application like Kubernetes or Docker, right? So what happens is you take your server, you install your operating system, you install the container orchestration application, Docker Kubernetes. And now what happens is this program is responsible for giving each of these apps their own unique copy of the binaries and libraries that they need that may theoretically be shared from the operating system level, right? And that allows you to scale this out, right? You can now scale out to many, many more. You could have 50 or 60 apps on this one server, these small microservices-based apps. And then if you really want, you could scale it so that your container management system is working across a cluster of servers, could be 1, 2, 3, 5, 6, 10. And you've got essentially almost unlimited scalability to support your small applications with absolutely no challenges with conflicts between shared libraries. Okay. And again, this is an incredibly high level look at this. I'm trying my best to simplify. And customers do this, right? It's called either Docker or Kubernetes. Those are the two predominant container orchestration platforms, right? So you could have one host with multiple containers. You could have tens of hosts with hundreds of containers. It's incredibly scalable, and away you go. So what happens if you run into a customer who has this? What if they're already doing container-based stuff in their own data center? Well, you could have them build EC2 instances and install their container management software and run their containers exactly the same way as they're doing it on-prem. Or you could say, get your customer to configure the Elastic Container Service or Elastic Kubernetes Service, depending upon whether they're a Docker or a Kubernetes customer. And all they do is go in to configure these two services to represent how much capacity they need and so on and so forth. So they configure their Kubernetes cluster, but they don't run the operating systems underneath, right? It's a service. Like, this is the beauty of these things, is this is now a fully managed service that AWS takes care of the feeding of the actual servers under the covers. All the customer does is configure EKS, right? How big do you want to be, scalability, how many nodes, what's your expected workload, and so on and so forth. And then they simply upload their containerized to this service. Okay. So the answer to the question that was asked earlier, and forgive me for scrolling back through the chat, I think it was Dennis. I hope it was. David, sorry, apologize. Struggling why I would use Lambda versus Kubernetes. In the case of York, if they're already doing container-based deployments, then stick with Kubernetes. It's fine. If they've already done their development of their applications to the Kubernetes standard, then go there, right? Deploy EKS, right? Job done. If they haven't yet standardized on some sort of a development platform whereby they're going to do this, Kubernetes adds an additional layer, right? It's got the Kubernetes engine itself is the layer in the middle. Whereas if they develop to a Lambda-based spec, all they do is they write their code and upload it to the Lambda server. There's no extra containerization piece in the place because Lambda kind of provides that in the back end. So and yeah, so Dennis, me talking about it ain't gonna help, but sorry. Yeah. Thank you for the feedback. I appreciate that. So is everyone cool with this idea? If you bump into a customer that is already doing container orchestration, like container management, whether it's Docker, Kubernetes, Windows Container Services, whatever it is, upload their containers to one of these two services and they will run natively. But you still have to configure the services. There is a better answer now, and this is a relatively recent, as in the last 3 years, service that we brought out. And this is essentially, hang on, he says, clicking on the mouse, not having anything happen. There we go. This is known as Fargate, which is essentially AWS Lambda for containers. What this means is the customer just says, all right, I don't want to configure EKS or ECS. I just want to upload my containerized apps to this thing called Fargate, and you guys bill me when they run. And it completely removes all of the configuration of the containerization platform from the customer's purview. Right? They do not care about the build of either EKS, ECS, or anything else. All they say is, hey, I've got containerized apps. I wrote them to the Kubernetes standard, upload them to Fargate. I'll get billed when they run. So if you've already got containerized apps, Fargate is your target. If you are looking for a new way to write apps that's going to be serverless, I would skip the idea of using Kubernetes or Docker. Just go straight to Lambda. So to answer the question, you know, it depends where your customer is at in the development cycle. If they're already doing containerized development, then hey, we have a target. If they're not doing containerized development and they want to start writing microservices-based applications, I would encourage them to look at Lambda because it's one less layer, right? Yes, it's simpler. It's simpler. It's one smaller layer. It's thin. Again, same concepts in place, but because containers have already got a standard structure involved in them, in the back end, Fargate is still running basically EKS and ECS as a fully managed service. You'll find it's more efficient using Lambda. Okay. But hey, lots of options, right? Who dreamt that that would be there? All right. So module 2, this is a knowledge check for the overall module itself. So customer wants to use EC2 instance for a batch processing workload. Now this is tricky because we're assuming that you remember what we talked about, but given no other information, what do you think? A, B, C, or D? Yeah. Batch processing in my world implies I need to do compute quickly, right? Because I've saved up all the stuff to process it as a batch. And now, oh, here it is, let's go. And that's why I say given no other information, because they haven't told you whether this is, heavily compute centric or not. You just draw an assumption. And that's a great way to go, right? So absolutely compute optimized is the answer we're looking for. So what are the contract length options for reserved instances? There's two answers here, folks. So looking for two answers. And the answer is A and C. Seems to be what most of you are choosing. Absolutely correct. 1 year and 3 years. What if I need a 2-year contract? Well, you do a 1 year and then you renew it in 1 year, right? There is no 2-year option. Customer has a workload that can run for a total of 6 months that can withstand interruptions. What would be the most cost-efficient EC2 purchasing option? You guys think? It's like we got universal agreement on this, and you are absolutely right. And what drove that conversation is, first of all, this. If I say 6 months, boy, sorry about the horrible scribbling. If we say 6 months, a reserved instance is generally 12 plus months, right? Right? It's 1 year or 3 years. Well, so that makes no sense to say something's going to run for 6 months and I'm going to buy a 12-month subscription. It's like, no. Dedicated instance, there's nothing about this being dedicated to either one customer or license centric or whatever. So that's nothing in the question indicates that's there. An on-demand instance is not the most cost efficient, no matter what the story might be, right? That's got a dollar value associated with it. So spot instance ends up being our answer. And again, this is the other trick. And withstand interruptions, right? Hey, it's that piece of software that goes and does facial rec, right? So off to the races. So good answers. Again, you guys got it. I didn't need to prove that to you, but again, I just wanted to work through the logic of how you would choose if you didn't really know. Customer wants to give users messages for the specific topics to which they have subscribed. Which service are we describing here? Yeah, topics and subscribed is the simple notification. Absolutely. Okay. All right, so good module. Good module. Lots of talking. So module 3, global infrastructure and reliability. Again, according to my clock, we're looking at just 10 minutes before noon. Again, as I suggested, I'm shooting for around about 12:30 Pacific time, so about 40 minutes from now-ish for lunch. So if you need to contact a significant other or otherwise to organize lunch for you, now would be the time to let them know. 12:30-ish, give or take 5 minutes. So module 3 is the global infrastructure and reliability module, right? So what we're going to talk about here is, what exactly is the global infrastructure? What is an availability zone? Why does it matter? We'll talk about things like CloudFront as a service and what that actually brings to the table. And then we'll talk about how to provision various different AWS services. So there's a link to the global infrastructure page, which is a web page. Again, you'll at the end of class. But what I want to talk about more than anything else is, think about this. As I said in the intro module, if a customer has a web server on the internet, they're viewed as being global, right? They may view themselves that way. Well, okay, I get it, but it's not really, right? How would I get there from here? Right? So in the case of their one web server, what happens if something happens, right? What happens if a chunk of the internet goes down? Or in the case of the coffee shop with only one location, what happens if there's raid? Well, the answer is easy. You become Starbucks locations, and if one Starbucks can't be reached, you just go to another one. And that's what we're trying to make available here. Maybe it's because of regional requirements of being able to collect personally identifiable information inside the European Union. Hey, we can figure out this customer's coming from the European Union, and we'll direct them to a web server that's in the same country that they are. That's fabulous. Maybe it's more about delivery of high bandwidth services a la Netflix, right? It's what we can build with a global footprint. It's not just having a presence on the World Wide Web. Anyone can do that. What we're you a meaningful that is scalable, redundant, performant, and also able to live up to requirements. So we have the AWS infrastructure is broken down into what we call regions, right? A region is a geographic location of the world, right? You'll find that we name our regions according to where they are. So, for instance, we've got Northern Ohio, Ohio. We've got Canada Central, which, believe it or not, is in Montreal. Um, um, Virginia, that's one of our very large regions. We've got Northern California. We've got Oregon. There's a bunch of them out there. And the region is made up of multiple availability zones, and those availability zones are made up of a collection of data centers. So the smallest is a server, which is in a data center, which is in an availability zone, which makes up a region. Okay, so I'll come back to that. Why would I choose one region over another? Well, why would I choose Northern California as opposed to, say, Frankfurt? Well, maybe it is a data governance issue. Remember, if I'm doing business in the European Union and collecting a certain type of information from my customers, I might have to keep that in Frankfurt. Okay, so maybe I choose the Frankfurt region because of that. Maybe it's because I want to be close to my customers. If I do business in one region of the world, one locale, maybe it's all in, maybe I do mostly business in Eastern Canada. Well, Canada Central might make sense because all of my resources are stored very close to where the customers are going to be using them, right? From time to time, we release new services. And when we release new services, they are not all available in every region at the same time. For instance, when I joined AWS in December of 2020, we had just announced Mac EC2 instance, but they were only available. We make available is Mac actual, and then they provision them on behalf of our customers when you choose a Mac instance. Well, that means the regions that are going to deliver Mac instances have to have minis physically there. So it took us a while to Apple's production to the point where we could buy enough Mac minis to be able to solve this problem. And lunch will be 30 minutes. Sorry, just noticed the comment in chat. Yeah, we've got a massive pile of information to get through here. So sometimes it's going to be based on what service you need. Generally, if a service has been available for 8 or 9 months, it's pretty much available in all regions, right? We don't take a long time about making them available. If they're available and they're popular, we distribute them as quick as we can. And the last one that confuses people is pricing is region-centric. So for me to give you an EC2 instance of a particular configuration in one region, you might find that it's a different price in a different region. And the reason for that is because we charge our customers based on what it costs us to deliver that service within the region. An example, Sao Paulo, Brazil. The corporate tax structure in Brazil makes it expensive for us to do business there. So we have to charge more when we're providing services that are hosted inside that region. And if you compare that to, say, I don't know, Oregon, you'll find that the price for the same instance is actually cheaper in Oregon than it is in Sao Paulo, to the point of almost 50% more, right? And again, you won't ever be quizzed on the actual numbers, but it's reasonable to know that pricing varies by region simply because it costs us a different amount to deliver a service in each region that we have. And that's how we base our pricing. Okay, so that's choosing a region. Well, what the heck is this thing called an availability zone? And I want to take a moment to talk about this. Let's discuss Northern California as a region. So that is a region, right? As notated by US West 1, Northern California. We're showing you, hey, that this thing is made up of these 3 blue dotted things, right? These guys here are what we call availability zones. And of course, there are data centers in each of the availability zones, and in there are 50,000 plus servers in each data center. Okay, so why is it called an availability zone? Well, In order for these servers, these data centers, to speak to each other, AWS has determined for some of our services, we need extremely high bandwidth, extremely low latency. Latency is the time it takes, right? Not just the overall speed of transition, but the delay between point A and point B. And when you're dealing with things like fiber optics, the speed of light is our determining factor. So if we start to introduce a lot of distance between two data centers, the latency grows to a point where certain services don't function quite properly. Okay. So what we've said is, in order to build an availability zone that has the services that we need that are able to talk to each other reasonably well, we need to keep these data centers very close together, right? So an availability zone ends up being, again, another more or less geographic area within the bigger region. Let me put this in context. Northern California, let's say San Francisco, I'm sure most of you are aware that that area of the world is subject to earthquakes. I can speak to this from personal experience, having been in San Francisco during an earthquake. Very fun. And no, it's not. If an earthquake occurs, it is conceivable, because of the proximity of these three data centers, that we could lose all of them, right? Something really bad could happen in Northern California, and that entire availability zone could go offline, because they need to be together for that latency value. But that also sets them subject to potentially being broken if a disaster occurs. Now, we use 100-year modeling of natural disasters in the area wherever we're working, and we figure out where we should place these things. And that brings up this point. This availability zone will not be affected by that same earthquake, right? But also the communication between availability zones has a higher latency value. Again, this is just back-end stuff. So what an availability zone is it's an a sub-area of a region that has a bunch of data centers that are relatively close together to give us the performance we require under normal operating circumstances. But due to that, they are subject to potentially being unavailable together. So I could lose an availability zone. What I should not lose, according to the 100-year modeling, is more than one availability zone at the same time. Okay? And that's a very powerful conversation, right? The ability for us to withstand that kind of loss is pretty cool. But hang on a second. What if everything I deployed was in US West 1A? Well, then you're down, right? Well, not necessarily. Remember those auto scaling groups? If I built my auto scaling groups and I said my minimum was 1 and US West A went down, that would take your instance down. And subsequently, that instance could, in fact, start up here, right? Remember, auto scaling groups say, hey, minimum is 1, 1 is down. Oh, let's start it up on somewhere surviving. And it will be within that same region, but potentially in a different availability zone. And what did you have to do to make this happen? Well, almost nothing, to be honest. You had to build an auto scaling group, which most people would do given what it can do. Very, very cool. Now, just for the sake of argument, AWS currently has 26 regions worldwide that are currently up and running. The minimum stated requirement is 2 availability zones per region. I am here to tell you that in all 26 of the regions right now, we have 3. So every one of them has actually got 3 availability zones, which is a good deal. And we've got 8 more regions scheduled to be deployed in the next 2 years, not the least of which is Canada West, which will be built in Calgary, Alberta. Again, since this is a hosted class, I feel appropriate to talk about that. Hang on a sec. Our 4-legged cat. Not that all cats aren't 4-legged, but you get the idea. Our critter that runs around the house is being particularly obnoxious today, so I had to close my office door. So there you go. So there's part of the conversation. So the other piece of the global infrastructure that becomes important is that whole idea that I introduced earlier of the ability to your customers based on their activities. So, if I'm Netflix, for instance, or in the case of this example where I'm the coffee shop and I'm looking to distribute my fancy grind of coffee that, I roast a particular way and it's can become the best thing in the world, I may get a reputation and I want to send that to people all across the world. But the reality is, if I just drop this in the hands of the postal service, my customer may not get it in a good time frame, right? So maybe the best answer is to have a distribution center where I can actually do a bulk shipment of my coffee to the distribution center and then subsequently deliver it locally to my customers. Right? That would make things better. And that's where CloudFront comes to play. So CloudFront is the name of the service, right? Up here, CloudFront. CloudFront is the name of the service, and the actual functional device that it uses is known as an edge location, right? This is at the minimum, it is a caching server. It could be a collection of caching servers in an AWS-owned location, which is not necessarily associated with our regions, right? It could be co-located at a service provider. What's happening is, as the customer says, I want to watch a movie, so they fire up their browser, they go to netflix.com or, fire up their app on their TV, whatever it is. They go and they say, oh yeah, I want to watch this movie. It's currently stored in Brazil. Well, what ends up happening is that movie is then copied through the AWS network, which is a private dedicated network. And we copy that movie through extremely high bandwidth station up to the edge location, and then the simply the edge location. And the coolest part about all of this is that the customer is oblivious. They have no idea this is happening. They have no idea that the movie lives in South America in the first place. They have no idea that they're streaming the movie from some local edge server. And in order to make this work, you simply go in and configure CloudFront to say, all right, I want to use CloudFront. I want to enable geolocation awareness so that I detect where the customer comes from. I can specify exactly what I want to cache at the edge locations, whether it's all movies, one movie, the top 10 movies. And I can also define how long I want to cache it there. So if I only cache it for 8 hours, if no one else has watched the movie, it'll be deleted from the edge location. But if someone else watches the movie, it'll stay for 8 hours from when they watched it, right? So I'm in full of how the content is cached, and then the billing works on how to use it, right? The data transfer get to it in the first, the amount of time it remembers, number of times it's delivered to your customer. But this is really easy because now you don't need to figure out where should I copy these movies around the world. I simply say, my movies live in this one location. If somebody requests it, it'll show up where it the customer. And that is incredibly cool. The service is called CloudFront. Edge location delivers the content. And by the way, it works in reverse. Remember, I suggested that maybe I'm a video editing service and the customer could be uploading content. They would upload the content to the edge location. It would be transferred back to the corporate location through the AWS private network. So this one's a bit of an oddball one. In the case of stepping outside of the IT world, if I'm a factory owner and I've got 1,000 employees that work in my factory, and there's a coffee shop 2 blocks away, when the bell goes for coffee break, there's a mass exodus from the building to get to the coffee shop. And of course, there's a race because everybody gets coffee at the same time. And then there's a lineup at the coffee shop. And then by the time my employees get back to work, that 10-minute coffee break has now taken 30 minutes. So for a lot of employees, going to the coffee shop is not even an option. But what if I could actually say to that coffee shop owner, look, I'm going to give you some space inside my factory, so you can have your coffee shop there so that when my employees get their break, they don't lose a whole bunch of time in the transit, right? They don't have to walk to the coffee shop and back. It's just in the lobby. Okay, well, that has its advantages. And we make that same service available for AWS Outposts. For certain types of customers, they require data to be stored on their physical premises. If you look at HIPAA on hospitals in the US, there are certain types of data within a hospital's purview. If they're a HIPAA compliant medical organization, they are required to keep certain things on-prem. Well, they could do that two ways, right? They could still run their own data center. They could still manage their own Windows and Linux servers for all of the things that they need to keep on-prem. And then they could run all their non-on-prem stuff up in the cloud with AWS. That would work. It's known as a hybrid approach, and it works fine, right? But now they got a bit of a problem, right? They're managing their AWS resources using AWS tools, and they're managing their data center using their old traditional data center tools. And there's two completely different skill sets involved here. What if we could deliver a stack of AWS hardware into your data center so that you could deploy those things that physically need to be in your data center on resources that are in your data center, but using the same tools that you use to manage your based resources? And that, ladies and gentlemen, is Outposts. It is a physical configuration of a rack of server gear and storage. AWS brings it into your data center, or your customer's data center, I guess. We drop it in place. AWS manages the physical aspect of it, right? We may need access to your data center once in a while. Most of what we do is remote in terms of the physical servers. But the customer now views it as an extension of AWS, and they use their AWS management tools to build EC2 instances and S3 buckets and CloudFront and all the rest. But they get to define what stays on their physical premises. It is a very cool tool, right? And again, people go, "Wow, that must be expensive." And actually, it's not. This is again another one of those things we've realized certain type organizations are subject to these types of things. Just make sure I didn't make a typo here. aws.amazon.com/outposts. Right. And you can go and poke around there, have a look at the various configurations that are available. Because again, it's not one size fits all. You get to choose your configuration. And then, of course, the costing structure is associated with that. So we've had a great deal of success with this because it allows people to have a hybrid, which is managed in a unified fashion. Right? Very cool. And AWS does. AWS typically makes sure that happens. In answer to the question in chat. All right, so quick review, AWS Global Infrastructure customer might be out there. We choose to deploy in the Sao Paulo region. The region itself is made up of multiple availability zones that theoretically, according to the 100-year modeling of natural disasters, if an availability zone goes down, should survive, right? So that's good. We can leverage edge locations in order to make content available to customers. They don't have to always come back to the main region query there, caching service. And away we go. So let's talk about interacting with AWS services. So the way we interact with services are generally done through an API, right? You can launch an EC2 instance, you can create a load balancer, you can invoke a Lambda function. All of this stuff is done through APIs. And to be honest, basically every management task in AWS is done with an API. So whether you're creating a new user, assigning somebody, creating an EC2 to an S3 bucket, it's an API call. And the reason that's relevant is because we automatically call in the entire, and it's automatically logged. We're going to talk about CloudFront and CloudWatch, which will give you some view into things that have happened. But that also becomes important. An API, an application programming interface, if we give you the tools necessary so that you can call these API functions from things like .NET, things like Python, then you can write your own software that actually makes AWS function calls. Anas, I'm assuming you're going back to And so I'll answer your question first because it's easy. AWS uses, yeah, it uses whatever internet connection you've got. Um, mentioned the need to have the same tools to manage on-prem servers in the cloud. So in the case of us, you would be simply using the AWS Management Console, right? Our standard AWS Management Console is what you're going to deal with. And what I mean by that is we're not using Outposts. You would then have whatever tools you're using to manage your on-prem things, whether they're Windows, Linux, or otherwise. And then you would have to use the AWS management tools to manage what you're running in the cloud. This gives you an opportunity to manage your on-prem and your cloud stuff all using the AWS tools. That's all it is. Which, trust me, while it seems simple, that's actually a pretty big deal for people. So did that answer the question appropriately for both of those? Okay, perfect. Good. So to interact with AWS services, we provide three different primary methods. You can either use the management console, right? Graphical user interface. I'll show you that a little bit later on once we've talked about a little more networking and storage. You can use the command line interface. This is a downloadable tool that you can download for Windows, for Linux, and for Mac so that you on your own desktop can make AWS command line function calls. So you can create a new AWS user. You can create an EC2 instance from the command line, right? And again, this goes to that consolidation of tools. Plus, there are software development kits for C++, Java, .NET, Python, you name it, right? I think we support 9 different development environments last I knew. So if you've got a preferred development language, chances are good we can provide you an SDK so that you can write code that directly calls AWS functions, whether that's interfacing with existing services or whether it's creating and managing services. Okay. So pretty cool. So module 3, let's walk through the knowledge check very, very briefly here. The following is true for the AWS global infrastructure. So the big question becomes, which is the biggest thing? What contains others? Yeah. The region is the big item, right? So regions contain availability zones. And then in order for a region to be redundant, we say it has to contain 2 availability zones, which is answer D. But recognize our current configuration is all of our regions have at least 3. And I think Northern Virginia has 6. It's really quite a massive region in Northern Virginia. It was our first region that we deployed. All right. Which factors should be considered when selecting a region? And we're looking for 2. So which 2 of these do you like to determine which region you should choose? Ooh, looks like we've got more or less universal agreement here. I like it. And yeah, you're absolutely right. Just for the purposes of argument, access to 24/7 tech support has got absolutely nothing to do with where you are. You either have access to it because you got a support contract or not. And quite frankly, you've even got 24/7 tech support, even if you've got a free account. You just don't have access to the same things as someone who pays for it. The ability to assign custom permissions to different users, again, not based on regions, right? That's the same across the board. And access to the command line interface, again, that's a tool which is universally available. It's not got anything to do with the regions themselves. So you're right. A and B are the best answers here, right? Which statement best describes Amazon CloudFront? What do you guys think? A bit of disagreement here. So I'll take a look at the answers being provided here. Well, it looks like A, C, and D seem to be the ones that seem to be coming up. Yeah, so we're pretty sure it's not B, right? That's Lambda, right? B is Lambda, so that's definitely not it. Um, A service that allows you to send and receive messages between software components through a queue, that's SQS, right? SQS. So that's not what CloudFront is. A service that allows you to run infrastructure in a hybrid cloud approach. You could argue that this is Outposts, right? If we were to take what we've already discussed, so that would be Outposts, and D is in fact the answer that we're ended up looking for here. Just FYI. I understand why A might be tempting because it almost appears kind of sort of hybrid, but it is all truly still leveraging cloud-based services, global content delivery service. So which site does Amazon CloudFront use to cache copies of content? Yeah, there you go. Well, we got resonation. That one, that one really hit home. Yeah, the edge location is in fact the caching service itself. And last but not least, which action can you perform with AWS Outposts? Yeah, absolutely right. Answer C, extend your AWS infrastructure and services to your on-premise data center. So you can run EC2 instances in your data center. You can have S3 storage in your data center. You can have EBS storage. You can build VPCs. I mean, all that stuff that we build in AWS now physically lives in your data center, usually for purposes of compliance, right? All right. So that wraps up module number 3, which, believe it or not, we're doing okay, but we got a long way to go yet. So what I'd like to do is we got 15 minutes left before our declared lunchtime. So I would like to start to talk about the networking module. So let's keep on rolling. So yeah, lots of stuff to talk about in networking. Here's the good thing, ladies and gents. Again, I come from a long, long history of networking background, including Cisco from a formal level. One of the things I find is once you get your head wrapped around what it is we're building here, the networking guys are actually pretty comfortable, right? The same things happen in networking in the cloud as happen on-prem and in the physical world. It's just, how do we get to them? How do we build them? What does it mean, right? So take that for what it's worth. I'm not to simplify this by any stretch, but I'm trying to say to you guys, look, this is not drastically different than what you might do physically. There's a lot of similarities. So if you had a private network and a public network in your physical environment, or a DMZ, as some people have referred to them as, we would build that same construct in the cloud, right? So let's take a look at that. So a virtual private cloud enables you to launch resources in a virtual network that you define. If you look at the coffee shop, it's basically defining the coffee shop itself, right? Well, great. So the coffee shop exists at a specific location. Well, wonderful. If I don't subdivide the coffee shop into a counter and maybe a cashier's area and a barista's area, then when people come through the front door of my coffee shop, they just kind of mill around and maybe somebody tries to order a coffee directly from the barista. Well, that's not good. So we want ways to define what's going on. So in the coffee shop environment, we would define what would be known as a public workstation, which would be where the cashier would, take orders and take money and give change and all that good stuff. And then a private workstation area where the barista gets to do what they do, right? So that seems to make sense. And in much the same way that you would build your environment. So the VPC is the virtual private cloud. And the best way I've ever seen this described is you create a virtual private cloud, and that's where your network belongs, right? So you then subsequently define your network. So you build subnets within the VPC. One might be a public subnet, one might be a private subnet. Heck, you might have 8 private subnets, right? You can have as many subnets as meet your needs in much the same way as you could carve up your physical network into the appropriate number of subnets for whatever that purpose is, right? We can provide access to subnets using an internet gateway to the VPC, right? An internet gateway is a required logical construct. It's just a definition, right? We say, all right, I'm going to apply an internet gateway, click. define how it works, and that will allow us to have clients deliver traffic inbound, which I think this is really cool. You can build your entire VPC internally. So you build your private, your public subnets, you define the rules of behavior between them, you deploy all the various different workstations, and then when you're ready to go live, you can enable the gateway, update your DNS records, and all of a sudden you're live on the internet, right? And yet you've built all the other stuff, potentially days or weeks ahead of time. So kind of cool, right? Kind of like saying, all right, we're ready to do business. I'm going to open my front door. Until then, traffic only, as it were. Well, what if somebody needs to get to your private subnet? Maybe the DBA needs to manage the databases that live in the private subnet. Well, that's going to require what we call a VPN connection. Shocking. I know most of you are familiar with this. Oh, yeah, no, I use a VPN to get from my home office to the work network, right? And in order to connect, we need to establish a virtual private gateway to allow us to form VPN either from that remote worker who's at home or perhaps from my corporate data center, so that I build a continuous pipeline between my corporate data center and my databases that live in the private subnet. I mean, maybe you've still got some reporting going on back at corporate. You've got some servers that live back at the corporate network, right? You got some server here that needs to do queries of those databases. Well, wouldn't it be nice if there was a pipeline that they could do that? That is established using a virtual private gateway and then subsequently a VPN connection from corporate to the VPG, right? Virtual private gateway. All right, very cool. All of that happens through the internet. Everyone good with that? That happens through the internet. I don't need anything special. I just simply have the resources in place. I place them. I can now, once I've built the virtual private gateway, I can establish a VPN through my regular VPN, through my regular internet connection. But sometimes, if we assume the customer has got an internet connection here to connect them to the cloud, right? Maybe they've got an internet connection because they got a lot of people here who are doing outbound internet connections, right? Well, if I all of a sudden connect my corporate network to the AWS cloud using that internet connection, I'm now maybe replicating data back and forth between corporate data center and the private subnet. And that's going to take some of that internet bandwidth. So two ways to fix that. I could have a second internet connection. Or what I could do, even better, is I could establish a relationship with what we know as an AWS Direct Connect partner. Okay? And what happens is this AWS Direct Connect location here, this is actually a partner organization. These are typically ISPs, right? And I'm going to show you this because I think it's a really cool function. So http://aws.amazon.com, shocking, direct connect. Right. So if we go to URL, I'll click on it for you. What you can do is go over to the partners dialog box, and this will tell you who the AWS Direct Connect delivery partners are within the regions. Now, notice the default is to show you all regions. So if I choose North America, so that's relevant to me, I can look at things like Bell Cloud Connect for AWS Direct Connect, which means I can establish a relationship from my corporate office with Bell Canada, and that provides essentially a dedicated connection. So let me explain that by going back to the slides. So you've seen where you can go to find who the partners are. So that's all good. Oh, come on. Every so often PowerPoint just doesn't want to cooperate. So let's assume that this is now Bell, right? Rats. Sorry, my fault. Entirely my fault. Let me fix that. Pen went away. So if this is Bell Canada, let's say I've chosen to do business with them as my Direct Connect partner. What happens here is this connection ends up being a dedicated leased line. typically fiber, right? So I go to Bell and I say, I need you to lay in some fiber, or I need you to get me a fiber connection from my corporate office to your physical facilities. So that becomes a dedicated lease line that I pay Bell for, right? I pay them for that lease line. That then gets me into their physical environment, and they then direct me here through the AWS Direct Connect endpoint, and they, Bell Canada, are on the AWS network. So if you look at this, remember we had our connection out here to the internet itself. So I'm surfing and all that stuff out through the internet. If there's any traffic that comes from my corporate data center, it goes through my internal leased line, which is a fiber connection to Bell Canada, that then gets directed through the various different routers that they have, that basically puts me right on the AWS network. So if you extrapolate, a direct connection puts your corporate office on the AWS backbone. So on the AWS backbone. And could I use outposts? Absolutely. You could have your out server could be in here. What we're talking about is two different things. That is my ability to host AWS services on-prem. This is my ability to corporate network to the AWS network. You can either go through the internet with a VPN, or you can go through a direct connect partner location. Now, recognize there's a cost for this, right? First of all, you got to pay for that leased line fiber connection. That'll be a contract you establish with the service provider. And then there's a cost per hour, and then a certain amount of cost for the amount of data that you transfer when you use through this portion of the connection. Established on the pricing page on that link that I provided earlier. So, Erkan, did that get the answer to your question? Good with that? Perfect. So here. So what do you guys think? I mean, pretty cool stuff, right? I can get to the network from anywhere. So let's wrap this up with a VPC component conversation, a match the component. So in terms of question number one, isolate databases containing a customer's personal information. A, B, C, or D? So isolate databases and customers' personal information, that's going to be private, right? It's going to be the best answer for that one is private. Create a VPN connection between the VPC and the internal corporate network. What do I need for that? Absolutely be a virtual private gateway. Support a customer-facing website. So number three, looking pretty unanimously like A, best answer, and I agree. And then establish a dedicated connection between an on-prem data center and the VPC is AWS Direct Connect. And if I was to give you a hint on this, ladies and gentlemen, that term right there, dedicated connection, is almost always the big flag that says AWS Direct Connect, right? As soon as you say corporate dedicated connection to AWS, that is Direct Connect. So even if you remember based on word association somehow, that would be a good, solid best practice. Okay. That looks like it's an outstanding time for us to stop for our lunch break. So what I'm going to do is I'm going to put my timer up for lunch. We're going to come back and talk about network access control lists and security groups, again, continuing the networking conversation. But at this moment in time, I'm going to go back to my lunch timer. I'm going to change the picture just because I can. We'll go to the Amazon Seattle Spheres, which is kind of cool. We'll put 30 minutes. Actually, let's be generous. We'll start at the top of the hour. How's that? We'll give you 32 minutes. Very exciting. Again, keep those questions coming in chat. I'm going to step away as you would expect because I'm going to grab a bite to eat. If anyone's got any questions, please feel free to deliver them. I will deal with them as a group when we get back. I'm going to go on mute and grab a bite. So I'll talk to you guys in. Easiest to assume here that, this is some sort of a www server, right? We got a web server here. We got a web server here, whatever.
If a customer sends a packet, of course, they're going to fire that packet off. It has to go through the internet gateway, so that has to be there in the first place. The very first thing that happens is on the subnet itself, there is a thing called the network access control list. And again, this is the same as your networking guys have been dealing with for years. So this defines what can pass through onto this subnet. So what traffic is allowed on the subnet. And then once that traffic, passes through this direction, we introduce a new element, and this is different than what you would be running in your physical network world, right? So before you ever get access to the actual EC2 instance and its operating system, you then have to pass through a security group that's associated with the EC2 instance. So in short, let's assume that this is a web server, and just for the sake of argument, we'll say that it's running Windows, right? Well, you might have some Windows security set up here on the web server. Well, that's great. This piece is an additional layer provided by AWS that you can optionally place security into, or, rules, as it were, so we can further define what gets access to this EC2 instance. Because remember, network access control list allows you to control who has access to the entire subnet. Well, maybe you want to allow everybody into the entire subnet, but you want to restrict it on which of these two servers they're going to. So maybe we do different rules as part of these two different security groups. So it's a combination of the two that typically sets up the way things work. So let's talk about the details. So a network access control list, by default, virtual firewall for the entire subnet. By default, and folks, if you were looking to study for an exam, nudge, nudge, wink, wink, the default network ACL allows all inbound and outbound traffic. In other words, if you just create a public subnet and you install an internet gateway, there's no filter on the network ACL, right? It's wide open. If you choose to implement a custom ACL, in other words, if you go and change the default, then it will allow whatever you say is allowed and deny everything else, right? Notice it says custom network ACLs deny all inbound and outbound traffic. Well, not really. They change to operate in such a way that you define what is allowed, and then once you've done that, everything else is not allowed, right? Doesn't matter inbound or outbound. So that's fair, right? So network access control list, and that's for the entire subnet. Now, these are known as being stateless. Now, again, the problem I have with this particular fact, while it's true, is it's not particularly useful to us at this level, other than to say that if you're looking to do very low overhead filtering, that's what stateless is, right? Think of it as, and the way they provide it here, it's actually a really great example. If I take my passport and I'm going into a country, when I arrive in the country, I go and see the passport control officer, I hand them my passport, I say, hey, this is me. They then use their system to check to see whether I'm allowed or denied, right? And then as soon as I'm allowed or denied, whatever the action they take, let's say they allow me in, that passport control officer has forgotten that I was even there, right? Stateless. There's no memory of the fact that I passed through that checkpoint. So that when I leave again, I have to present my passport again, right? So when I go to leave the country, it's like, oh yeah, you're leaving now, give me your passport. And again, they will check the list a second time to see whether I'm allowed to leave. Well, heck, if I've been there for 2 weeks and I did something wrong, maybe I'm not, right? But the message is the same. This is an example of stateless packet filtering. The agent responsible for doing the security does not remember that you passed through there in any way, shape, or form, right? So that's fair. That's stateless packet filtering. I see a question in chat. How does this apply to auto scaling? I'm not even sure I understand the question. Right? Auto scaling is the ability to add and remove EC2 instances. Those instances would typically live on a given subnet, so you would set the security rules according to the subnet, choosing you're doing network access control lists. If the question is more around security groups, then I can configure as a part of my auto-scaling configuration which security group every auto-scaling instance belongs to, and they don't necessarily have their own. So if that's the question, I'm going to go back here to this diagram where there's the two different security groups for two different instances. It is possible for us to have, oops, draw on the right screen, one security group that both EC2 instances share, right? So in the context of an auto-scaling group, as I'm adding more and more web servers, they would all be sharing the same security group. So we set the rules once in the security group, any new instances just belong to that same security group. That's something you get to decide though, right? Okay, yeah, so I wasn't sure what the question was, but working through what I knew about it, maybe that covered it. So good deal, thank you. All right, so, and that follows nicely, right? Because here is the security group discussion. A security group is in fact a virtual firewall for the EC2 instance. And by default, security groups deny all inbound traffic, but they allow all outbound. Right? So you've got to open up a security group. So what will happen is when you're building, let's say I'm building a Windows EC2 instance, if I don't tell it anything else, and I say build a new security group to go with it during the wizard, so I'm building an EC2 instance, it's running Windows, it knows that. By default, it will open up for RDP. Right? It'll open up port 3389, I think that's the right one, for RDP traffic, and it builds it into the default security group for a Windows server, because the assumption is if you're building a Windows server, you're going to need to connect to it using a remote desktop, so it opens it up with the appropriate setting, right? The cool thing about security groups is that they're a little bit more memory intensive in that they do remember when you show up. So any inbound traffic is remembered by the security group process. And then when you go to leave, it will say, "Oh yeah, no, I know I let you in," right? So there is a memory process rather than a double lookup. A little bit more overhead if you've got a lot of traffic, right? Because there's a memory element that has to be added, right? The actual security process has to remember. So, okay. So overall, again, as a review, network traffic comes in from the internet through a packet through the internet gateway, evaluated by the network access control lists, evaluated by the appropriate security group or groups associated with the EC2 instances, and the connection request is either allowed or denied. But don't forget, we still haven't talked about what the operating system does. Because if Windows has got security set on it, which does not allow for anonymous access to the web server, Windows itself could deny this person. So you've essentially got three areas that would prevent somebody getting access to your resources. So lots of control is what it comes down to. All right. So when we go to interact with the AWS global network, one of the things that becomes apparent is, look, I got all these resources. I got these web servers. I've got these private networks, database servers. I've got auto scaling groups, load balancers, the whole deal. In short, just about everybody needs DNS in order to make this go, right? When somebody is surfing the internet, they type in some www address, right? Some friendly name. And that process kicks off a request to however this customer's browser or their system is set up. It says, okay, well, where's your DNS server? Let me go ask that guy what www.anyserver.com's address is, right? And if this DNS resolver knows the answer, in other words, it's maybe looked it up before, it'll directly respond, right, if it's cached. But if it doesn't, then it works its way through the hierarchy of the internet DNS servers, and again, they don't document that here, essentially ending up at the DNS server that owns the records for any company, and thereby any company will then, any company's DNS server will then provide the IP address for the www server. That'll be cached here, and then subsequently sent back to the user, and off we go, right? All right, so fairly obvious that DNS plays a big part in this, which we get, right? There it is responding with the IP address, and et cetera, et cetera. So it can perform lookup requests. Well, why is this relevant, right? What's in it for me in this case? Well, if you're deploying resources in the AWS cloud, you're going to need a DNS server. Now, could I use a Windows DNS server and install it on an EC2 instance? Well, sure you could. Right? For a lot of customers, that's what they're already doing. They could just deploy a server, they could install DNS, their chosen DNS platform, and away they go. However, I'm going to put it to you that that might be something you want to re-examine. One of the coolest things about AWS is we have this product called Route 53, which is our DNS service. And okay, so it does DNS just like a bunch of others, right? It already understands how to talk to the World Wide Web. It understands how to integrate with the overall structure of the World Wide Web. When you create AWS resources, they can be registered with the Route 53 service. But ladies and gentlemen, it's much, much more than that, right? First of all, any AWS service that needs DNS is already aware of Route 53. Route 53 is an incredibly intelligent DNS service which understands things like geolocation awareness. So it understands when a client comes from a particular IP address that belongs to a particular region in the world, that they should redirect traffic to perhaps a CloudFront server that is in that customer's region, right? And maybe that CloudFront server front ends the application load balancer to be able to send them to the local copies of the EC2 instances that might be running in, say, Japan, right? If you've got a global network where you're deploying resources in multiple regions in AWS, you might have web servers in Japan and in Sao Paulo, Brazil, and in Singapore, and so on and so forth. Well, that's great, but how do you direct traffic to them? Well, that's Route 53's job, right? It can be made to be aware of where the customer is coming from and the rules that you wish to implement on how you redirect customers. And also we can leverage CloudFront to help cache all that stuff. So it's really wild. There's a phrase that's often used, and this is where we start to talk about, the solution itself is greater than the sum of the parts. Actually, let me go back here. So the question is, wouldn't the arrow go from Route 53 to CloudFront? That would imply that Route 53 is the thing that's going to CloudFront, and it's not. Route 53 is a lookup request from the client's perspective, and Route 53 will provide the appropriate CloudFront information to the client, and then away they go, right? The lookup is Route 53, the where I go happens through CloudFront, and it sounds like that resonated reasonably well. So good question, by the way. That was good. Okay, so, I do want you guys to understand something, and I think it's appropriate to pause, take a breath at this moment, and tell you this. You remember my introductory module to this. We got 300 plus slides to go through here, and a lot of content. But remember, this is about talking about it. It's about the talk. If you look at the details of our DNS service, well, I just delivered it to you in 3 slides, right, to give you a very high-level overview of what it's all about. I've got training material where we could spend the better part of a week working at all the detailed intricacies of this under the covers. Now, that's a bit of an exaggeration, but you get the point, right? A lot of these services were just meant to give you conversational capabilities. So Route 53 is our DNS. By the way, just before we move on to the knowledge check, does anyone know where Route 53 got its name? Good answer, Ken. Yeah, Barkey, that's it. DNS port 53. Yeah, the urban legend goes, Route 66, the coast-to-coast highway across the United States, there's something to do with that. But the actual 53 portion of it comes from UDP port 53, which is the registered port against which all DNS queries are made. So we call it Route 53. It's all about routing traffic. or routing traffic, depending upon where you're from in the world. The 53 component is because of the port number that it actually uses. So, and yes, if you look back in enough detail, there's like I said, a bit of an urban legend that has to come with associating between the various different highways and all that good stuff. So I think good answers across the board. All right, so let's go into the knowledge check. Wrap this up. Which component can be used to establish a private dedicated connection between a company's data center and AWS? Remember the key word there. Looks like you guys remembered it. Even after lunch, I'm impressed. That's a good thing. And by the way, I am sincere about that. That's really good. So yeah, that would be AWS Direct Connect. And that word that we were looking for was private dedicated, right? That was the phrase we're concerned about. Which statement best describes security groups? So these are the things that are wrapped around the outside of an EC2 instance. If you're not sure how to approach this, you ask the question, are they stateful or stateless? Because really the answers are two different components, right? It's either they're stateful or they're stateless, and then they either allow all or deny all. And which magic combination of those is it? And security groups themselves are stateful. They remember, haha, and they deny all inbound traffic by default. Right on. Okay. Which component is used to connect a VPC to the internet? Absolutely. It would be A, the internet gateway. By the way, those types of questions bother me a little bit because it seems too obvious. You guys will run into that. You'll be looking at an answer on a question and go, well, it's got to be that, but that seems way too easy. Go with it. It's okay. Easy answers are good. Which service is used to manage DNS records for domain names? Gee, I hope you get this one. Yeah, so this would be the good old Route 53 version. And then which statement best describes DNS resolution? By the way, far from an AWS specific question. But yeah, that would be translating a domain name into an IP address. You betcha. All right. So that is Module 4, the quick and dirty summary of Module number 4. So what I'm going to do right now, and just bear with me for a moment, I'm going to do a very, very quick high-level overview demonstration of creating an EC2 instance, okay? So I'm going to discard this. And again, we're not going to get into details of connecting to it and all the rest of that good stuff. I'm just going to go through the basic mechanics because we've talked about a lot of this. And it really becomes difficult for customers to, or for students to wrap their head around sometimes until they've seen it. Now, you also got to recognize that we have not yet talked about storage and some of the other items that are going to show up in the wizard here. So bear with me, right? There's going to be a few things that I hope to answer after we do the demonstration. But I'm going to do a very basic demonstration here. So first and foremost, what I'm going to do is build an EC2 instance. So all I've done is I've logged into the AWS console. I literally logged in with my private account here. It's called Andrew-Demo. My account is currently focused on the Northern Virginia region. Notice in the drop-down list here, there's my Andrew-Demo at my account ID. So that's cool. If I go to EC2, I can either choose from the recently visited list, which obviously I've been here before, or if I didn't know, or maybe it didn't show up here because I haven't recently been there, I can either search for it by saying EC2 in the search dialog, and there it is, or I could click on services itself, and then it breaks it down according to the various different service categories. Now, remember I said we broke them down into 6 categories. There's way more than that, right? But compute being one of them that we focus on here in this class, there's EC2. Okay, so click on EC2 without further ado. So what it gives is the home page for EC2 itself. It says, all right, what have you got going on here, Andrew? Well, I have 0 instances running. Again, I keep my account really clean because even as an AWS instructor that I work for the company, I'm still incurring costs if I keep my EC2 instances up and running. And since I just use them for demos, I usually destroy them right after class. So let's go ahead and just launch a new instance without further ado. So I click on the launch instance, right? And away we go. Very first question. What operating system? Well, that's interesting. Why would it want to know what operating system? Well, if you look in the back end, Linux systems are capable of running on different processor types than Windows systems, and vice versa, right? So if I choose the operating system first, what it'll then do is filter which EC2 instances are available to me. Let me demonstrate. So I'm going to go and notice the various different operating systems we have. We got Mac OS, we got Red Hat Enterprise, we've got Mac OS Catalina. If I go down here to Windows Server, let's find Windows Server 2022 just for grins. Only to show you that we do have the current stuff available, right? So Windows Server 2022 base. So I'm going to select that. And notice it tells me that it's looking for a 64-bit x86 based platform. Well, we've got, like I said, over 400 instance types. Some of them are not x86 based, right? So here's the list of types. Remember, I went to the computer store. I said I want a gaming computer. Well, what it's given me is here's my T2 instances, and the size that I get is a micro, right? If you want to know the instance type and the description of exactly what it is, we end up going to, and I'm going to pop open a new browser window here, aws.amazon.com/EC2. So again, if I wasn't sure what I was looking for, I might go here. I'll go to the instance type details. And in here, it'll let me browse what they are. Well, am I looking for a general purpose instance, compute optimized, memory optimized, or let's just stick with general purpose. So I could do a Mac, a T4G, T3, T3A, T2. Well, let's have a look at that T2 because that was the default, right? That was the one that it showed me, T2 micro. Well, T2 is the type, and this says that it features 3.3 gigahertz Intel Xeon scalable processors based on the Haswell or Broadwell chipset, burstable CPU, and the sizes as we get them are either nano, micro, small, medium, large, extra large, and 2 extra large, and that relates to a configuration of 4 vCPUs and 54 CPU credits per hour, 16 gigabytes of memory, right? So this tells you what it's used for, and it gives you a suggestion as to what you should use it for. Well, if you're looking for something a little more fancy than that, we go to compute optimized, right? Maybe I've got something that requires a really high performance processor. Well, let's look at a C6i. Well, that's interesting. 3rd generation Xeon scalable processors. Cool, right? All the details. And of course, I can build much bigger ones here, right? I can do a 96 CPU, 192 gigabyte of memory configuration. That's crazy. But guess what? It costs a lot more, right? In terms of running this on an hourly basis, this will cost you a lot more than a really basic T2 micro. Right? So it's a very cool tool to poke through and figure out what these things are capable of. And again, they do give you some extra blurbs about use cases, and each vCPU on a C7G is a core of a Graviton 3 processor, so they give you lots of details before you even choose it. So let me go back to my demo. I'm just going to stick with T2 Micro because it's free tier eligible and I'm working on the free tier right now. So that's fair. And we'll talk about free tier later in the class. If I just click review and launch, I'm going to get a Windows Server 2022 instance installed with all the defaults. Job done. Right? It'll launch. There will be a security group associated with it. It'll have a port 3389 open so I can connect to it with RDP and everything's good. But let's configure some details instead. So the details that I have is how many of these do you want? Heck, I could say 4 and get 4 EC2 instances configured exactly the same through one wizard. That's pretty cool. I'm just going to do 1. This is where we request a spot instance. Remember those that could be taken away from us at any time, right? This is where you would say, I want this to be a spot instance. If I don't, the default is this will be an on-demand instance. Which network is it going to connect to? That would be your VPC. Again, it's a rather abstract name, but it is your VPC. And then what subnet? Well, in this particular case, I've got a couple of subnets defined. Maybe I don't want to, I don't want to define it. Generally, you would, right? You would pick one of the subnets in one of the availability zones where you want this thing to live, right? And then how do you want the IP address? Well, just get it from the subnet itself. That'll be DHCP based. Well, that's fair. Host name type is going to be based on the IP name. Placement, lots and lots of options, right? All of these are way more detailed than we're prepared to go into here. Here's how you define your Ethernet adapter, right? You could do 1 or 2 Ethernet adapters. Maybe you're going to provide something that talks both to the public and the private IP with different network cards. You could do that. You can go into advanced details such as, how the metadata is accessible, all sorts of stuff way beyond the scope of this class. I can go into add storage. The default is you get an operating system drive, which is 30 gigabytes in size, and it's built on what we call general purpose SSD. Right? This is an EBS volume, which we're going to talk about in the upcoming module. So that's good old general purpose. GP2 is pretty decent solid state performance. GP3 would be higher performance, right? And then provisioned IOPS are you're guaranteeing a number of IOs per second available for that particular instance. So this is guaranteeing extremely high bandwidth for a particular system. Well, guess what? As you choose GP3, IO1, IO2, the price for that storage goes up. If you choose magnetic disk, you're willing to accept really slow disk performance. That's really what that comes down to. So GP2 is usually what we really care about, right? Tags, which is the next slide. Again, by the way, if I wanted to drive D, I could just add some more in that screen. No big deal. Tags are free-form text. I can add tag which says department, and I could say this is sales, and I could add another tag which says, managed by, and then Andrew. Something to help you identify these things, because when you get 500 EC2 instances in your console, it's very difficult to find a particular one, particularly if you didn't name it in any way other than based on its IP, right? So what you can do with tags is you can search on tags. Now, be aware, they are case sensitive, so we strongly recommend using all lowercase, and they are free-form. So if you agree that department is going to be sales, marketing, what have you, make sure that everybody knows what those keywords are and make sure that they can spell them properly. Right? If you're going to put tags on things, make sure that they are following a uniform pattern. Otherwise, searching will be very difficult. All right, so that's cool. We can configure the security group, and notice here it is. Port 3389 is the default for RDP. This came up. I don't have to accept it. I could delete that if I want, but recognize you'd have a hard time getting to this Windows server now. And yeah, tags can be added and changed afterwards. Absolutely. Yeah, you can do whatever you like. But strongly recommend best practice. If you're going to use tags that are built in the first place, have a standard so that you don't have to figure out what went wrong when you created this thing. So I could add another rule, or I could remove this rule, or what have you. In this case, they're saying, look, allow port 3389 in from any range of addresses, right? Good to go. And at that point, I simply click review and launch. It says, okay, here we are. You've built it. You can look through all the details, and that's your final summary review, and click launch. This is where we get to choose a key pair, because notice I did not define an administrator password in any of that, and it's actually going to install this process. There are ways and tools that we can use later on as part of the advanced deployment tools where we can set all those parameters, but by default, when you initially connect to this server, it will prompt you for a key pair. The private key is stored locally, the public key is stored with the resource. And that's really all this is asking. I created one already called a Win 2022 key pair. I have it on my laptop. I'm just going to use that one. I acknowledge that I do have access to that, and I'm going to click Launch Instance. And at that point, it goes and installs Windows. Given 3 or 4 minutes, I could come back here and actually review the instances. There it is in pending state, T2 micro, no alarms, right? It's not up and running yet. But again, I can click on the instance ID and it gives me all the details about it. Okay. Now, literally none of that is useful for the exam in terms of, hey, I need to remember how to do that. You do not. Okay. But like I said, for some customers, some students, they really do like to see the overall process, where some of that stuff that I talked about actually now has a, oh, that's where that came from. So I hope that was somewhat useful. Again, I won't worry about waiting till the server installs. We'll just go back to the slides and keep cooking because, hey, we got a lot to do. All right. Yeah, no worries. You're quite welcome. I like going in and doing the demo anyway, and it's at least something. So let's talk storage and databases. And a lot of students look at the title of this slide and go, wait a minute, storage and databases in the same module? When you really think about it, they both do the same thing, right? They store data. One of them stores data in files, and one of them stores data in an actual database engine. So yeah, it's how we put stuff that we care about in the cloud, right? It's either in a file or it's in a database. You could argue that just about every piece of data is stored that way. So fair enough, we'll treat them sort of together. To be honest, we do break it in pieces. So we're going to talk about lots. So let's talk storage. AWS gives a customer a choice. You can have block, object, or file storage, and that is often dictated by the use case. Block storage is what you and I have been dealing with for years. So if I were to do something like, if I were to say, oh, come on, that wasn't what I wanted. Gee whiz. You guys have dealt with block storage forever. Drive C, drive D, your root volume, right, on your Linux box. Internal drive for a system. That's block storage. We don't typically deal with object storage in the regular PC world, but I'll show you where that comes to play and why it's useful. And file storage is, double backslash share name, backslash, folder name, etc. Typically where we're going to be looking at, more or less shared file storage. You either connect to a network drive or some sort of a shared folder or, an NFS folder as the case may be. So let's talk about these individually and then dig our way through why we care about them. So first of all, block storage, the very definition of block storage is you take a disk, you format it into what we call blocks, whether they're 4K blocks or 32K blocks or whatever the file system dictates. NTFS, FAT are both examples of block-based file systems. And they are typically local storage to a system, right? Whether it's your laptop, it's the local hard drive in your laptop. If it's a virtual machine, it's the local virtual disk that VM boots from. And in our world, that would be an EC2 instance boot drive. It could also be an EC2 instance's data drive, right? Anything which is considered local to the operating system on that system. You format the disk according to blocks. Whenever you write a file to the disk, if it's larger than the block size that's formatted, let's say it's 32K blocks and I'm writing a 50K file, I'm going to occupy 2 blocks, right? I'm going to fully fill one 32K block and then I'm going to partially fill the next block. The cool feature of block storage is when you change a file, only the changed blocks get rewritten to disk. So if a file only occupies 1 block, no big deal, you rewrite the whole block every time. But if you're changing a large file, and you're changing just a small component of it, this can be very efficient, right? Because you're only really writing the small component of the file that changed. Cool. Interesting thing to keep in mind. We'll contrast that with another type. So we use block storage in AWS. When you see block storage, you need to think in your mind that is known as EBS, or Elastic Block Store, right? EBS volumes. So you typically have an EC2 instance with a drive C, right? And it boots and it does whatever it does. When you turn off the EC2 instance, the volume remains, right? That's cool. If you say that it is terminated in our world means you're going to destroy the instance. So if you destroy an EC2 instance, it probably makes sense to destroy the disk that's associated with it, correct? That seems to make sense. I mean, if I'm going to delete a PC, I'm probably going to delete the hard drive that it's on it. So you can set that. And you can also override this, by the way. You can, and the reason I might want to override it is maybe I built an EC2 instance with a particular instance type. Maybe I used a T2 micro. And I've come to learn that, you know what, that really wasn't big enough. What I needed was one of the larger T2 instance types. So a T2 large. So I would go into the properties of the EC2 instance, change this flag, which says, terminate on delete. I would delete the instance but leave the disk behind, and then create a new instance pointing at that old disk. Right? So I would create a T2 large and point at the same disk. As long as you're using the same processor, Windows will likely still boot exactly the same. So that's how you would easily switch between them, right? So it's kind of an interesting process, right? So we can have EBS. Now there is a special type of EBS volume that we call an instance store. And this is think of this as disappearing EBS. You go like, what? Why would I want to do that? If I add an instance store to an EC2 instance, it's essentially a disk which gets deleted whenever you turn off the EC2 instance. So I would never do that for drive C or drive D. Everyone agree with that? I mean, if I'm going to turn off an EC2 instance, I don't want to lose drive C. Because frankly, if you shut it off just to do some maintenance, you could lose the whole drive C, and then at that point you got to rebuild from scratch. But what if it was a data drive that was out there? And the best use case for this, and it's not very well diagrammed on this, but I could actually try to diagram it out. Now, imagine if you will. So we've got an EC2 instance with a drive C for its operating system, a drive D for SQL Server, right? So Microsoft SQL Server is installed on drive D, and I create an instance store as the third disk. Well, why would I do that? Well, databases, particularly things like Microsoft SQL Server, have a need for what's called a temp DB volume. Now, by default, that goes on the same disk where the actual application is. So if I do the basic install, I would end up with both my database drive as drive D, and my temp DB file would be stored also on drive D. And the way SQL works is when an update is made to the database, it writes it to the temp DB first, and then it transfers it to the actual database. Think of the tempdb file as almost a linear log file. It just receives things in sequence, and then when it's got time, it places them where they belong in the database. So it's very fast. Well, you can make it even faster by giving the tempdb file its own dedicated disk. And that's where an instance store becomes really powerful, is you can use the instance store for tempdb files, because whenever it's up and running, it's writing data to that temporary file location. It gets its own dedicated separate disk with its own disk channel, which is great, really high performance. It can then transfer data from one disk to another disk when it's time, right, which is great. But then when I shut off the instance, all that tempdb stuff, which has already been committed to the database, just gets deleted. So it's a very powerful tool. So you can shut off something with an instance store, and it automatically cleans up after itself. Now, you got to admit, this is a bit of a use case, right? It's probably not the type of thing you're going to do very much of, but there it is. The other thing that you get with EBS is you get the ability to do what's called an EBS snapshot. And what this essentially allows you to do is to create backups within the AWS console that are incremental backups. So if your Windows system has a drive C and a drive D, you could do a drive D EBS snapshot, and on the first time you do the snapshot, it backs up all of drive D. The next time you do the backup, it takes what has changed since the last backup. And then on the third time you do the backup, it takes what was changed since the second backup. Right? They're showing you here on the slide that it's day 1, day 2, and day 3, but quite honestly, that only makes sense if you're doing daily backups. The increment is not relevant. It's backup 1, backup 2, and backup 3. Quite literally, backup 2 only backs up what was changed since the previous backup. in much the same way as backup 3 only backs up what's changed since you did backup 2. These are EBS snapshots. How much extra do you pay for this? Well, you don't pay anything extra for the EBS snapshot function itself. It's there. What you pay for is the additional storage that it takes on S3, right? And which we'll get to in a few moments. Okay? So think about that for a moment. I could take my data drives, and I've got a built-in backup mechanism, which is all integrated in the cloud, and all I have to do is schedule it and run it on a process on a schedule. And job done. Where's my third-party backup software? I don't care. I don't need it. Now, that's not to say that third-party backup software doesn't provide value, because they do. But if I need a simple, fundamental, rudimentary backup that's known as an incremental backup, it's built into the system. Again, very, very powerful tools just because you're using it. So let's move on and talk about object storage. This is the one that a lot of folks haven't had a lot of exposure to. An object storage, let me start by saying, in our world, we still store a file on object storage. What defines object storage is how that file is stored. So a block data store, what we talked about earlier, we carve up the disk into segments, and then we drop the file into those segments, either one or multiple segments, depending upon how large the file is. Object storage does not work that way. When we go to store the object on an object data store, keep in mind it's still a file, we store the data itself as a single entity, right? Whether it's 1K or 1 terabyte, it's a single entity. And then there's a metadata file, and a metadata is described as data about data. So it's the reference piece that describes what it is we just stored, and then there's a key to gain access. Fair enough. The big characteristic of object storage is if you change something that's stored as an object, then you have to rewrite the entire object. Everyone follow that? If I change an object, change something that's stored on an object store, if it's 1K, I have to rewrite 1K. If it's 1 terabyte, I have to rewrite the entire terabyte. Right? There's no concept of changed blocks. We write the object as it exists. So a lot of people like to tell you that object storage is really only good for read-only data, which is a lie. That is a terrible statement, okay? On first blush, it looks like that might be the case. If you think about storing predominantly large files that change often, all right, that's not a good use case for an object store. Think about Netflix. When was the last time one of their movies changed? Right? Movies are static things. You drop them on a file on an object store somewhere, and they just sit there. Right? They don't get written. They get read an awful lot. So a movie is a great use case for an object store. Any large file that does not change regularly. But keep in mind, if I need to change it, I can still change it. The downside is when I make a small change to it, maybe I change the header information in the file itself, it has to rewrite the whole file. Okay, so there's a bandwidth issue. All right, fair enough. But keep in mind, if I put a whole bunch of small things on object storage that do change regularly, what does it matter? Right? If it's a very small object and I have to rewrite the whole small object every time it changes, this is a really high-performance storage system, so it doesn't really matter. Like if it's a small thing that changes regularly, well, big deal. So what if I have to rewrite this small thing many times? It's small. It's only an issue if we're making small changes to big things. Okay. Object storage. So the AWS Object Data Store, and again, sorry for the long-winded description, but this is the foundation to our very first service, right? The first service we ever released was S3, which stands for the Simple Storage Service, right? S3, therefore, there are 3 S's, so S3. So the very first thing we do is we create a bucket. Like that's the primary repository, that's all right, I want to use S3. I'm going to create an S3 bucket. And then I place objects into the file. Now I can create folders in there. I can drop objects into those folders or right in the root volume. And then we simply set permissions to control access. Now the interesting part about this is that every single object, so not only the S3 bucket itself, it has a URL and it is worldwide unique. So every S3 bucket you create will be unique throughout the entire world. Okay, there's no such thing as an internal S3 bucket in terms of its naming. Yes, you can make it internal by setting permissions on it, but it is still worldwide unique. So typically an S3 bucket includes some sort of a English language readable name and some random string of characters just to make sure that it's unique. But the coolest part about that is that every single object in an S3 bucket also gets its own unique URL. So think about Netflix. They're storing videos on S3, movie files. Well, every single one of those, let's say Top Gun is the movie, since that seems to be uppermost in a lot of people's mind these days. If it's stored as a part of Netflix, that object will have an actual URL associated with it, which means that if I'm serving that up from a web server, the web server doesn't have to go and get the file and deliver it to the customer. The web server can give the customer the actual URL of the movie, and the customer can go directly to the S3 bucket and get it. Again, assuming they have permissions. Right? It ends up being a very powerful tool. Again, inherently unique worldwide URLs built into those. But when you actually go to create an S3 bucket, you then get to choose what type of storage you want. What do you mean? Well, it's object-based. Those rules don't change, but we have several different storage classes. Now, there's more classes that we have than I'm going to talk about here. These are the ones you care about for the test. So if you go to aws.amazon.com/S3, you'll find that there are a few more storage classes referenced. Don't panic about that. So S3 standard is generally speaking targeting frequently accessed data. Notice I didn't say frequently changing, I said frequently accessed. So think, maybe this is the top 1,000 movies that Netflix uses, right? This is the stuff that gets accessed regularly. As soon as you choose S3 standard, it automatically copies that object to 3 different availability zones, which means you are 100% redundant just by choosing S3 as your storage environment. How many of you think your customers would buy into that? Right? Hey, you need to put some stuff on some storage in the cloud. Well, let's use S3 because it automatically gives us redundancy. And you didn't have to configure a darn thing to make it happen. You just dropped it in there. You automatically got 3 copies of it. Job done. Again, all secure, all controllable with permissions. So that's very cool. S3 standard IA stands for infrequently accessed. IA is infrequently accessed, right? The idea behind this is that if you put objects, we'll call them files, on S3 that do not get, let's say it's older movies that never get watched, we're going to charge you less to store those. We're going to make this cheaper storage. But then when you do go to access the file, the data transfer cost associated with accessing that file goes up. Right? So it's a higher data transfer cost, it's a lower storage cost. So what the administrator has to do is figure out, hey, what is this, how often is this object accessed? Should I store it on S3 standard or S3 standard IA? Still get 3 availability zones worth of storage, but the cost value is different. And then if I further want to confuse things, or optimize, I guess is the better word, I can choose S3 one zone IA. And one zone says, unlike the other 2, store this data only in a single availability zone. You can probably guess that that's going to be cheaper, right? Because we're not using as much storage to store your object. But of course, if say that Northern California availability zone goes offline, you could lose your data. Now, 3 availability zones in the same region. Okay? Has to be in the same region, Mary. And that's a really important point. Mary brings up a great point, and I'm glad you did. Recognize that governance and laws and stuff like that are a problem. Well, they're not a problem. They're something to be managed. Let's take a look at the GDPR, for instance, which is the Data Protection Privacy Act in the European Union. If I'm doing business in Germany and I'm collecting information about customers who live in Germany, I am required to store that data inside Germany. So I'll put that in my German region, right, which is based in Frankfurt. Fair enough. What you know by doing that is that AWS will never, ever replicate that content out of that region. Okay? That's what's relevant about that conversation. So if I store data in a region, it will always stay in that region based on automatic replication. So what that tells me, the answer to Mary's question in by default, is that when we replicate to 3 availability zones, those 3 availability zones are inside the Frankfurt region. Okay. Let me say it another way. AWS will never automatically replicate data from one region to another. Because if we did that, we could actually end up having the customer break international laws. Right? We don't know what that data is, so we can never make that assumption. Now, is it possible for a customer to replicate their data between 2 regions? Oh, absolutely, right? Go at it. I mean, if you choose to replicate your data between one region and another region, then that's fine, right? But you have to choose to do that. We will never automatically do it outside of a region. A region is the bigger construct. An availability zone makes up the region, right? Remember, a region is broken into smaller chunks known as availability zones. Okay, so one zone IA. Why would I choose one zone IA? Why would I want to ever put my data at risk? Well, maybe it's accounting reporting data that I can generate simply by rerunning the report. Hey, it's nice to have. It'll save me some time if I don't have to go back to the accounting department and regenerate the year-end reports. I can stick them on a one zone IA, which is really dirt cheap to store. And if I lose it, well, I can always go back to the application and regenerate it, right? That's usually the use case that goes with one zone. It's a cost savings factor, right? Let me back up just for a second. Forget about one zone for now. Let me actually just go back here. If I've got 5,000 objects, so I'm asking you guys a real question here. If I've got 5,000 objects, some of them are accessed frequently, some of them are not accessed frequently. How do you monitor that? Because according to this, you have to choose where to place them based on how often they're accessed. And there's probably a threshold in there where if the thing gets accessed twice in a month, it should probably be on S3 standard as opposed to S3 standard IA. And what if the usage pattern changes? Well, that means, again, you, the administrator, have got to sit down and figure out which files belong where. Well, of course, the obvious answer is people just say, forget it, we're doing S3 standard, put everything there, we'll pay the higher bill. But really, is that good for customers? And the answer is no. So that's where we brought out this piece. So we added a component, which is a management component called S3 Intelligent Tiering. And S3 Intelligent Tiering allows us to say, look, as a customer, I've got these S3 things created. I've got S3 standard. I got some S3 infrequently accessed. I want to monitor all of the objects that I'm storing on S3, and I want the intelligent tiering service to shuffle them around and place them on the appropriate storage backend so that I get the best price. And you don't have to write anything. You don't have to worry about monitoring API requests or anything else like that. Now, you do pay a very small monitoring fee per object. So if you're monitoring 1 billion objects, S3 intelligent tiering is going to cost you a little bit every month to keep an eye on that. But in the big picture of things, I look at this as that's a necessary cost of doing business, folks. Because I can save a ton of money by putting things on infrequently accessed S3. Because I don't need it on standard. And this tool will help me with that. And then last but not least, to wrap things up, we have 2 archival classes. And when I say archival, think of these as being almost considered offline storage. So we have S3 Glacier and Glacier Deep Archive. These are very, very inexpensive S3 storage buckets. But the idea behind them is when you request an object that was placed on S3 Glacier, you specify how rapidly you want it to be retrieved, and the time frame is between 5 minutes and 12 hours. So if you say I need it in 5 minutes, the retrieval cost will be higher than if you say you want it in 6 hours. So the object is not just there waiting for you. Think of it as nearline storage. So you say, all right, I need that object. A dialog pops up. You say, I want to go retrieve it. How fast do you want it? And, it'll give you a ranking of various different spots, and you'll pay more for more rapid access. In much the same way as Deep Archive is even cheaper, like the cost per terabyte here is pennies. It's phenomenally inexpensive. But the shortest time frame I can get you your data back is 12 hours. Right? Typically 12 to 48 hours. So the question on S3 intelligent tiering is it will do the job. S3 intelligent tiering will actually move your files around. Again, it keeps the URLs, which is kind of cool, right? But it will in fact back them up with or place them on the appropriate backend storage. So yeah, neat process. And lots of details, aws.amazon.com/S3. Okay, last but not least, in the storage area, we're going to talk about file storage. You and I have probably dealt with this for years. Everyone's got a home directory on the network somewhere, /server name, /share name, or somebody mapped your local workstations drive, R for your home directories to some network-based resource. Sure, absolutely. We have file storage. We have AWS provides a service called, at its root, the Elastic File System, right? And the Elastic File System is built around a scalable file system that's either Linux for NFS or Windows. So we got 2 different implementations of it, where it provides essentially a shared server environment where you, the customer, don't have to manage either the Windows or the NFS servers that are actually providing that backend storage. You just access them. And what's really cool, if it's a Windows file share that we're creating using EFS, it's actually running a bunch of Windows servers, which, again, you as a customer never worry about patching because it's a fully managed service and AWS takes care of that. And the other thing you don't care about is how big are the disks in the back end. You just continue to add stuff to your system and it will continue to scale out the back end disk infrastructure. So this is a very, very powerful tool. So EFS is available in 2 different configurations, right? One for Linux-based NFS style and one for SMB style or Windows style connections to shared storage. Now, I want to highlight something very quickly. I want to contrast EBS, the Elastic Block Store, with EFS, which is our shared file system. So, and I want to get you to think about this. So answers in chat if you can. Remember, EBS is associated with typically the local disks on an EC2 instance. So where does an EC2 instance actually run? Let's get back to fundamentals here. Where does an EC2 instance run? Does it run at the region? Does it run at the availability zone? Does it run at the data center? Does it run on a server in the data center? By the way, that was a hint. There you go. It actually runs on a server in the data center. Okay? So remember, if I spin up an EC2 instance, it's a virtual machine, right? So it runs on a physical server, right? It's not all of that server, it's a portion of that server. So where do you think its disk is? Is its disk available across the entire region? In the availability zone? Or just in the data center? So where does an EBS volume live? So you're right, it is actually in the data center, but a data center is what makes up an availability zone. So what we classically say is that an EBS volume is only available in a single availability zone. Okay. And remember I said we had to have minimum latency between all of the data centers that make up our availability zone? This is one of the reasons. So yes, we know it lives in one data center or another, but we treat them as a single availability zone. So when you're doing EBS volumes, they're in a single availability zone, right? So it's a portion of a region. If you're doing EFS, the Elastic File System, available across the network to multiple resources from multiple different availability zones, this is a regional resource. Okay, so EFS is a regional resource. And yet, the only way I was able to figure out how to make this work in my mind, because again, this is something you may need to know for the test, was how's it used? If I know that EBS is a local drive for a virtual machine, I know that lives on a single server. Okay, that lives in the data center. That's probably an availability zone-based resource. Whereas EFS, the Elastic File System, is available to resources throughout the entire region. And yes, we know that bits of it may be stored within very specific data centers, but it is treated as an entity. Right? So the entity itself is available across the whole region. Are we good with that? Yeah, EFS is network zone. One availability zone always contains at least 2 data centers, but the data centers more or less work together. Right? That's the best way to think of it. Yes, it is multiple data centers, but there are such low latency rates that the boundaries between the data centers become very blurred. So, and that's not a bad way to look at it. It's not quite true. Multiple data centers. Yeah, it is distributed. Yeah, if you want to look at it that way, sure. Yeah, you begin to realize just how big this thing is, right? Okay, so let's move on. Actually, just my eyeball just look at the time. It's been about an hour since we started, and we're about to start on the database conversation. So I think now would be a good time for our next, we'll call it beverage break, right? So let me go back to my fancy little timer here, and we'll change the picture again. AWS is how. We'll take a break, and we'll throw 10 minutes on the timer. Not 32 minutes, that's a little aggressive. All right, so again, keep those questions coming. They've been great, thank you. We're going to go on break now. I'll go on mute for a moment, and I'll be back in 10. So, we're back. Give me a good old +1 in the chat. I got a question presented to me, only to me, but looking for both slides and or recording. First of all, we never record these sessions, and second of all, you'll get the slides if you're in attendance for 60% of the class time, so 60%. Okay, so let's move on. AWS databases, since you can apparently all hear me, that's a good thing. So let's talk databases in general. Again, this is a bit of an evolutionary story. Generally speaking, most of the IT world works in the context of having either a relational database or a non-relational database. Relational databases we typically characterize according to their SQL situation, right? If you can query it with SQL, data is stored in a way that it relates to other pieces of data, and they are queried using the structured query language, right? And or you can use SQL to store the data as well. So, hey, every object has its own set of things. The product ID is one, it's got a name, it's got a size, it's got a price. Every object has the same characteristics. Different values, but same characteristics. In terms of creating a database, let's assume for a moment that we had a customer that we ran into that was running Microsoft SQL Server, right? Just for the sake of argument. And again, I'm gonna use this as a bit of a building example. So bear with me. So if they're in their data center on-prem, right? They've got a VM. I'm just going to assume that it's a VM of some sort. Because it's Microsoft SQL Server, they're running Windows. Sorry, got to reorganize my desk here a little bit. There we go. They're running Windows. They're running SQL. And of course, they've got their data. All right, so that's the stack, right? The typical hardware-software stack that we're dealing with. I'll try and fix this up so that it looks a little bit more like Windows. Okay, so fair enough. So this is their on-prem environment. If we go to the cloud, right? If we migrate this to the cloud, we've got a couple of ways we can go. The first of which is really, really simple. EC2 running Windows with SQL and their data. So the question I have for you is this, and answers in chat. How much of this are they responsible for? Meaning if they move from on-prem to the cloud and they do it on an EC2 instance, at what layer do they still have, do they still have to manage the data? Well, yes, right? They still have to manage SQL? Well, yes. And the rule of thumb that we typically use is if the customer installs it or creates it in the cloud, they have to manage it. Which means that even down to the Windows layer, the customer has to manage all of this. Okay? But really, is that any different than this? It's not really any different, is it? Right? So there we go. That's one way of doing this. We call this a lift and shift. We'll talk about migration strategies later on in the course. But this is the basic fundamental, hey, take what you had on-premise and move it over to the cloud. It's painless from the perspective of the administrator because they end up doing exactly the same thing that they did on-prem in the cloud. The only thing they don't manage is the EC2 instance itself, right? They sized it when they created it and they fired it up and job done, right? They don't worry about the hypervisor and the physical hardware and all that stuff's done by AWS. However, this is still, having to manage that much of the stack is not ideal, right? You remember, I've been rattling on about this the whole time we've been in class. If I can get rid of managing Windows, that's a big savings for me, right? I don't have to worry about, and it's not just Windows, it's Linux as well, right? I don't have to worry about all that security patching at the operating system level. So how else could I do that? Well, one of the other models that I could use is I could either migrate from my on-prem to this other environment, or I could go, do a two-step migration, do step one here, and then step two would be to go from here to here. And what we're going to do in this case is a slightly different version, right? We're going to migrate this thing over to this process called the Relational Database Service, right? So this is an AWS service called the Relational Database Service. One of the databases that it provides is SQL, Microsoft SQL Server specifically. And then the customer would bring their data. Whoopsie, sorry about that. So the customer brings their data. Well, the interesting part about that is that because SQL is provided by AWS at that point, AWS manages all of this stuff, and the customer manages only their data. Well, why did I draw it this way? Well, interestingly enough, RDS as a service has one of the other services it supports is Oracle, and it also supports MySQL, and it also supports Postgres, etc. Right? There's 6 different services, which we'll talk about shortly. But the reason this is a relevant conversation, ladies and gentlemen, is that you now as a customer, or helping your customer understand how to migrate, if they've got this structure in their corporate data center, right? If this is their structure in their corporate data center for their database, they could either move it over and manage it the same way as they always have, or they can say, you know what, let's just grab the data. We'll just grab the data and move that over to this thing called RDS. We'll let AWS manage SQL. SQL will take care of dealing with all security patches for SQL itself, as well as the security patches on the underlying operating system, right? It's a pretty cool option. Now, again, this costs a little bit more, but you're also eliminating the need to manage all of the noisy stuff. Yeah, the stack below EC2 is just our hardware virtualization layer. It's just hardware, right? So it's hardware in our hypervisor. So really good question, Dennis. Great question. And Dat, you have a question, a one-step shift option to RDS. And yes, there is. You could do it as a single step, and I'll show you that in the migration options shortly. But the licensing costs for SQL or the other database, these are fully managed licenses of Microsoft SQL Server, Oracle, MySQL where relevant, and Postgres and all that good stuff. And when you choose to move to one of these engines in MySQL, and again, let me jump into the actual slides rather than my horrible diagram here. The idea behind the relational database service is to take away all the pain and suffering of managing the database engine itself, right? We provide these 6 database engines. And if you want, the default is license included, which means you don't need to purchase a license. When you pay us for the RDS service, part of the price that we charge you is in fact the license for that service. So SQL Server RDS will cost a different amount than Oracle RDS, than Amazon Aurora RDS. Right? So RDS is the engine. Think of it as a service provider. And we provide these 6 databases as a part of it. And when you choose to subscribe to any one of these, things like Microsoft SQL Server or Oracle, if you want, you can pay what we call the license included price. But that also means that if you already have an Oracle license or a SQL Server license and the right process through that vendor, you can bring that license with you and run it on RDS, right? So how cool is that? And what that actually does, that's a bigger deal than most people actually recognize off the hop, because an awful lot of customers have got people that spend a good portion of their time managing software licenses. And I can now eliminate, if you've heard my story up until now, we can do a whole bunch of things rather than running them on Windows or Linux, just run them as a service. Here's another example of that. So we don't any longer have to pay for Windows licensing as a customer. So that falls out of the way. And in this case, I may not even have to pay for SQL Server licensing as a separate entity. It's included in my monthly bill for my use of RDS. But ladies and gentlemen, let's talk about the elephant in the room. I think a lot of us have heard of Postgres, MySQL, MariaDB. These are, other database engines. We got this thing called Amazon Aurora. So this is the Amazon relational database service, right? This was built as a born-in-the-cloud database engine. So it understands multiple availability zones by default, right? Whenever you create an RDS database that's running Amazon Aurora, it automatically gets 3 copies of the data. Actually, 6 copies of the data across 3 availability zones. Job done. All you got to do is create the database and pop some data in there. Already got 6 copies of it. So this is a born in the cloud relational database. The cool thing is this, it's faster than every other relational database service out there. We can actually perform at a higher transactional speed than any of them. And the cost to run Amazon Aurora is roughly 1/10, like as in 10%, of what the equivalently configured commercial database engine might cost you. To put it another way, Amazon.com migrated over 7,500 Oracle databases into Amazon Aurora when we launched this service. It's faster and it's far cheaper, and it's born in the cloud, right? Meaning, hey, this wasn't written to run on an x86 standalone platform that we're now somehow trying to figure out how to scale. The scale is built in because it was actually written for a cloud-centric platform. So Amazon Aurora is, hugely powerful SQL engine. And then the next question you guys are going to ask me is like, wow, Andrew, that's great, but how do I get there from here? And again, you've already asked some of that in the chat. Stay tuned. I'll talk to you about the database migration service as the tail end of this module. But before we go there, we're going to talk non-relational databases. So up until now, that was relational. Non-relational, hey, here we've got two different things that are stored in a database. In this case, record number 1 is John Doe who lives at a certain address, but his favorite drink is a medium latte. Whereas Mary Major lives at a different address, but her birthday is July 5th. Not very relational, is it? We're not storing the same information in these records. Think of a gaming leaderboard. First place is Bob, second place is, Mandrew, third place is whoever, right? It doesn't really matter. Gaming leaderboard is a database, right? And a lot of customers are actually running SQL-based engines to store non-relational databases. So first things first, you find your customer, figure out what databases they're using. Are they in fact relational, being run by something like Microsoft SQL Server? Or are they just using Microsoft SQL Server because it's the license of database they had? Because now we have an opportunity to optimize, right? We've got this thing called DynamoDB. Now, DynamoDB is a serverless database. It's a serverless key value database. Automatic scalability. You don't have to tell it how big it needs to be. It will scale for you. As you add more data to it and as you query it harder, it will grow. Its base design was built around 10 trillion requests per day, to the tune where during Prime Day in 2019, there were 7 trillion requests made to the DynamoDB API. And I don't know about you guys, but 7 trillion requests to me is a number that I just can't wrap my head around it. I have no context for that. Well, so to break it down, our peak access through the DynamoDB API was 45 million requests per second. 45 million requests per second managed by the DynamoDB API. That is a stunning amount of performance being delivered by a single database engine, right? So that's crazy, right? That just absolutely crazy. So wonderful. So we've got relational databases, we've got non-relational databases, we've probably got this stuff in another format. How do we get there from here? And that's where we're going to run into the AWS database migration service. So sorry. Oh boy. DMS. And again, I'm gonna follow this link. So this is the database migration service. This tool allows us to do database migration like to like. So you could go SQL on-prem to SQL in the cloud. You could go and change your database. So an awful lot of the time, if you're looking to change the database you're using, let's say you want to go from SQL to Aurora, right? The example that they had on screen. I'm going to start by using the schema conversion tool, which is built into the database migration service itself. And notice that if you're currently running Oracle, you could migrate to any one of these databases using this tool, right? It'll structurally change your database tables so that they are compatible with the target environment. Okay. If you've got something like IBM DB2, right, you could go to these types of, and so on and so forth. And this is really cool because while the schema conversion tool is one part, that's the structural piece, the raw database migration service itself can be set up to work in continuous mode so that you can say, all right, I'm going to do the migration. I'm going to keep my database, my production database up and running, dealing with transactions. So in the back end, the migration service is actually moving the data from your production database to the new cloud-based database. And you can have that set up to run for a week or a month or 2 months. And it can be set to work in what's known as a synchronous fashion so that any change that's written to your production database will subsequently be written to your cloud-based database. And when you're ready to cut over, you simply make a few DNS changes, and lo and behold, you're now running in your new cloud platform. Right? This tool gets huge support throughout the community. We've done literally hundreds of thousands of migrations using the tool, and its ability to migrate at scale is second to none. It's a remarkably powerful tool, and people are really, really concerned about their databases, right? Because in a lot of cases, it's their business. So AWS DMS, we give it a whole whopping 1 slide in this course, and the reality is, I also teach the migrating to AWS technical classes. It's a very much bigger deal than even what we make of it here. So forgive me for my level of enthusiasm, as it were. I think it's worthwhile noting that this is not a simple process. This is a very serious process, and it should be, right? It should be a serious process. Okay, so that brings up this comment. So here we have another one of our review sessions. How is the validity of the transition provided to the customer? Well, David, that's an interesting question, because if you think about what the synchronous transaction thing allows you to do, data migration is a tricky game, right? So you build a database in your production environment, you need to migrate it over to AWS. So you launch the database migration tool, you run it in a synchronous fashion, and then you test the living daylights out of the cloud-based database. That's in reality, that's what you do, right? You actually launch a test process against your database. Again, we will provide you all sorts of error reporting if there's various things, tables that don't match or what have you. But at the end of the day, the beauty of having the synchronous data transactions happening is you can do the migration and then you can test the results and you go, oh, that didn't work. We need to make a tweak to this. But you can still keep running on your old environment. You have never had to shut off the old environment in order to migrate to the cloud. And then when you're ready and you've done your testing and you have what you believe is a valid configuration, then you can transition. But again, any errors that occur during the process is a part of the core platform. I don't know if that was a great explanation, but hopefully gave you enough to hang on to for this purpose. Okay, so let's go. Question number 1, storing data in a relational database. Is that RDS or Dynamo? An R or a D will be fine. Yeah, as soon as you say relational, you know, Amazon RDS does stand for the relational database service, right? Running a serverless database. That's the definition of Dynamo, right? So that's DynamoDB. Storing value or storing data in a key value database is also DynamoDB. Using SQL to organize data, that's RDS for sure. Scaling to 10 trillion requests per day, that's Dynamo as well. And then storing data in an Aurora database. Aurora is one of our relational database engines. You betcha. Okay, so sounded good, right? Well, we're not done yet. The beauty of what we provide here, and again, one of the cool things that I love about working here is, you know, that's the low-hanging fruit. Let's give us a relational and a non-relational database. What about some other databases? Well, would you like to build a data warehouse? And by the way, I usually refer to my students at this stage to just treat this as a word association game, because that's really all you need to know for this exam, right? You can look at the details of Redshift if you want by going aws.amazon.com/redshift. But in reality, what you need to know is Redshift is our data warehousing tool. DocumentDB is a MongoDB compatible document database. And Mongo is the predominant industry standard document management database, right? Neptune, I love the description of this one. Run applications that use highly connected data sets. And some of you are probably looking at the screen going, that's fascinating. What the heck does that mean? This, ladies and gentlemen, is a graph database. As in GRAPH, graph. Amazon Neptune. And QLDB is a quantum ledger database. So complete history of changes against your application data. You can run a quantum ledger environment, or you can run a managed blockchain environment to run a ledger database in a decentralized fashion. And we have both flavors, right? And then if your databases are not performing fast enough, we could front end most of these with this thing called Elasticache, which is a Redis and Memcache compatible. You can choose the engine you use, again, open source caching engines. So Elasticache can be used to front end things like RDS, could be front ending, your Neptune database, whatever it is. But if you really want to, and by the way, that's for caching, that's for acceleration, making it faster. If you really want to improve DynamoDB, we've got a special version of Elasticache called the DynamoDB Accelerator, specifically built around changing DynamoDB's response times to now less than 1 millisecond. Doesn't matter the size of the database, we will guarantee performance such that a query will respond in less than 1 millisecond. Let me think about that for a moment. Give it the biggest database you can possibly imagine and then query the thing, and we'll get less than 1 millisecond response times. The engineering behind this, quite honestly, boggles the mind. But, that's just an editorial on my part. Take it for what it is. All right. So let's rifle our way through the Module 5 knowledge check. This is for the whole module, namely storage and databases. So which S3 storage classes are optimized for archival data? And there are 2 answers, ladies and gents. 2 answers. Yeah, there you go. Looks like we got most people. And as soon as you hear archival and storage in our world, that's Glacier. Right? It's Glacier. This one's nasty. And if you remember my little rant that I went on towards the end of one of the modules there, which option is true about EBS volumes and EFS file systems? So remember, EBS volumes are useful for EC2 instances. We talked about them storing data in a single availability zone, right? And by contrast, looks like everyone seems to be on the right page. A is your answer. And ladies and gents, I hope that you got that based on an understanding rather than a pure memorization, right? If you understand how an EBS volume is used, oh yeah, it's a local drive on an EC2 instance. Well, an instance has to run on a server that lives only in one data center at one time, which means that it's an availability zone centric resource. Customer wants to store data in an object storage service. What should they be looking at? Yeah, lower level of commitment to these answers, but yes, I'm liking D. Our object data storage service is S3. Remember all the various different categories thereof, but S3 is still predominantly object data store. Which statement best describes DynamoDB? There you go. Serverless key value database. By the way, piece of trivia. Have you guys noticed that some services are called Amazon something and some are called AWS? For instance, it's Amazon DynamoDB. Anyone know what differentiates those? And by the way, I didn't know this until last week. This was something that I learned. And the way it was originally targeted is if a service is called Amazon something, it is a standalone service. Now, it's just a standalone service. It doesn't need anything else to make it work. Whereas AWS something or other is typically going to be part of some other process, right? Kind of an interesting. I had no idea. And again, I'd also learned last week that there are exceptions to every rule, and this is one of those. So that's why we don't focus on it, and it is not an exam question. All right. So which service is used to query and analyze data across a data warehouse? Yeah, that's the word association game that I was talking about, right? Just look for Redshift as the data warehouse type program. Okay. So really cool service or cool module, as it were. You know, when you're going to store your data, it either gets stored in files or in a database. As you can see, we got lots of options for you. And of course, coming up with the right solution will be dependent upon what it is you're trying to do. So Module 6 is security, and I do like to talk about Module 6. For a lot of customers, particularly if you're going to be customer facing as a partner, you're going to be faced with dealing with the security conversation a lot sooner than where we're positioning it, right? But I think in the context of overall learning and understanding, it's not in a bad spot in the course. So here we go. We're going to talk about the shared responsibility model and why that's a good thing. We'll talk about things like multi-factor authentication and various different identity and access management, all sorts of stuff that is going to be relevant to you when you come to actually deal with your customer around this story. But predominantly, the big deal here is I want you to be able to talk the talk. And the talk in terms of security is extremely important, right? So what's going to end up happening is this. And again, I got to set the stage, so forgive me, it's another one of Andrew's stories. You're going to go in and talk to a customer, and that customer says to you during the initial meeting, yeah, this is this AWS thing, yeah, that's cool, but before we even go, I read a newspaper article or saw something online last week that company XYZ stored their or shared their credit card database with the entire world because they were running on AWS. Right? That will be the story that you have to sit down and listen to. Right? Because we all know that the reporters understand all of the technology, right? Yeah, not. But, let's face it, if a customer reads that, hey, some company has shared their credit card database with the internet and they were on AWS, that customer you're talking to is going to be concerned, right? So how do you answer that question? How do you answer that question? And that's what this module is about. Okay? So let's start with some ground rules, first of all. We'll make it really easy on you. This is how we carve up the responsibility for security. Okay? Basically, if it's in pink, right, it's the responsibility of AWS. If it's in blue, it's the responsibility of the customer. Well, let's dig a little deeper into that. Okay? So the customer is responsible for security in the cloud, right? Notice this, security in the cloud. If they brought it to the cloud, they are responsible for securing it. So let's simplify that. If the customer brings their data to the cloud, who's responsible for securing it? And again, answers in chat. That would be good. Let me know you're still out there. Yeah, there you go. Sure, the customer. Again, the rule is really simple, isn't it? If they bring it to the cloud, then they're responsible for securing it. So the story that you just got from that customer who said, oh, yeah, this guy's credit card database was shared with the internet because it was stored on AWS, right? Who's responsible for that? AWS provided the infrastructure. But quite frankly, if they were running in their own data center and they had placed that on an unsecured resource in their own data center, it would be just as shared with the internet, right? And that's really the point to this conversation. The part that I think is really cool, right? And Trust me, I'm trying to give you guys a gentle way of not throwing that customer under the bus, right? If the customer you're speaking to understands how security is managed, and then further understands that we can provide some awesome auditing tools that will tell them when configurations are not following best practices, even though we can't see their actual data, then they are going to be in a much stronger position deploying their resources into the cloud, right? Yeah, and Ercan, exactly. Pegasus Airways, 6.5 terabytes of information in an S3 bucket. Right. Well, why? Because they didn't set the security properly on the S3 bucket. That's really the answer. Right? If they deploy Windows into the cloud, who has the admin password? Well, they do. Right? They're the only ones who have access to that. So they're the only ones who can set the security on it. So the customer is responsible for everything they bring to the cloud. AWS, on the other hand, is responsible for the security of things like the raw infrastructure itself. The storage arrays need to be security patched so that they are secure themselves. The actual hypervisors need to be patched, the physical servers, the data centers themselves. And by the way, are you aware that we never actually put a sign on the side of our data centers saying that this is an AWS data center? Right? Why would we? Right? Security by obscurity may seem like a simple task, but it's a good thing, right? So we take very seriously the security of the cloud, right? So if you want to take a look at it as a way of remembering it, if you need a mnemonic, I personally don't. I feel like if I know the first rule of thumb is if the customer brought it, they are responsible for security and securing that resource, I think I'm good, right? But if you need a mnemonic, customers are responsible for the security in the cloud. That's the CI component. AWS is responsible for security of the cloud. And for those of you who have Italian in your background, that would be CIAO, C-I-A-O. And David, good comment. Yeah, your cheese, your keys. Okay? So, which one of these are the responsibility of the customer or AWS? Number one, configuring security groups on EC2 instances. That AWS is that customer? That's the customer, right? Security groups are a big part of deploying the instance in the first place, and it's the customer that's doing that task. So yeah, absolutely, this is the customer. Maintaining the network infrastructure, clearly the job of AWS, right? Implementing physical security controls at data centers, including hiring security guards with guns. I'm sorry, I don't know that that's true. Again, one of the downsides, I've never seen one of our data centers because they don't offer tours to staff. Patching software on EC2 instances. Careful on this one, folks. Patching software on EC2 instances is absolutely a customer thing. The customer deployed the EC2 instance. The customer chose the operating system. The customer deployed the software on the instance. Therefore, the customer is responsible for patching it. Right? Oh, one more ahead of myself. I give you away that one. Maintaining servers that run the EC2 instances. Yeah, that's a whole different game, right? That's the hypervisor. Right? That's the core servers, those 50,000 servers in our data centers. And then setting permissions for S3 objects. Yeah, this wraps up very clearly the Pegasus Airlines / fictitious story that I just told you, right? So who's responsible? Well, it's actually the customer. Now, what I'm here to tell you is we got some awesome tools that we'll talk about later on, which can provide you some pretty black and white stories around, hey, you've got stuff that is exposed, and you should not be having that stuff exposed, right? So first of all, Ebenezer, sorry, again, I apologize. The U.S. Department of Defense typically deploys into what we call GovCloud, right? We have a GovCloud environment, so it's specifically for U.S. government deployments. Now, I'm not 100% enlightened on what goes on behind the scenes there, but put it this way, the U.S. Department of Defense has signed off on it. So I'm assuming that they've got that covered. Right? I don't have a lot of background information on that because I don't deal with the DoD. And does the AWS have access to the customer's data? So, Mary, good question. And the answer is, it depends. Okay, this is the part that drives people crazy because it's the instructor's favorite answer. If the customer doesn't secure it, then yeah, absolutely we do. But if the customer deploys their environment, let's say they deploy a Windows server and they enable encryption on their drives, then no, we don't have access to that. We don't have access to their Windows instances, right? We can't log into them. We don't have any permissions there. We can't read the files that are underneath them. Again, as long as the customer has taken the necessary steps, and like I said, we're going to show you some tools fairly shortly, or at least briefly mention them, where you can actually be told that you've got things that are stored in a particularly vulnerable way. And that, to me, is where we really win. Oh, excuse me. Boy, that sneeze snuck up on me. Sorry about that. Yeah, our ability to actually deliver tools and give warnings and recommendations even without them really running the tools to say, hey, are you aware? And I'll give you an instance as to where that is. So in my world, if you take advantage of the things that are offered here, and most of them are not, huge cost items. These are most of them available for free in most cases. These tools can actually make your environment more secure in the cloud than you were perhaps aware of when you were running on-prem. Because you didn't have any of those tools on-prem. You just had to rely on your people, right? And I'm not saying that's bad, but let's face it, tools are perhaps more reliable than people. Leave it at that. So let's talk about security tools. Let's get into it, right? So Identity and Access Management, or IAM, often abbreviated IAM, and we don't like that. It's IAM. I'll tell you that because I got told off for it. So there you go. This is our primary management tool that allows us to create an AWS user. Now, what is an AWS user? Well, this is somebody who's going to interact with the AWS services themselves. This is not somebody who's going to access your website, right? That's managed through whatever controls you use to manage your website. This is people who are going to read security logs for S3 buckets. It's people who are going to create EC2 instances. It's people who are going to audit permissions on various different resources. Somebody who is going to interact using the AWS tools. So we're going to create an IAM user, right? We're going to assign permissions based on what we call a policy document. So you create the user, you create a policy document which says anyone who has this document applied to them can do the following things, and then we apply the document to the user, or better, apply it to the group. So you can create an IAM group, place the users in the group, apply the policy to the group, and lo and behold, anyone who's in the group gets the policy. This shouldn't sound completely unfamiliar. If you've done any kind of user management, this is a process that is fairly well known. Where we deviate a little bit is we've got this thing called an IAM role, which I'll talk about shortly. And we can also implement multi-factor authentication for all IAM accounts. A multi-factor authentication, hey, when you log in, you get prompted for an additional piece of information. Yes, I know you gave me your user ID and your password. Now I want something else that you get from either a fob that you've got on your keychain, or you're running an app on your phone. Right? I happen to use an app on my phone. So we'll talk about that shortly. All right, so AWS account root user. So whenever you establish a new AWS account, by default, one user gets created. That is the root user. They are all powerful. I know this is completely shocking. Not, by the way, that was tongue-in-cheek. I do apologize. You would typically, best practice says, all right, log in as that user, create a new super user, and then lock up the credentials for your root account. Right? Be safe. Right? Make sure that you've got a continued backdoor, and the best backdoor is the actual root account itself. And then, of course, log in as that newly created super user and continue to do the management / user creation that you need to do. Right? So the root user should have only a limited number of tasks that they actually do. So an IAM user is simply an identity which is used to interact with AWS services. Well, that's fair, right? As I suggested. The best practice is to create an actual named user account for each user. What I mean by that, again, forgive me, my security background is coming out. Help Desk User 3 is a terrible username. Because don't forget, we track all activities. They're all API calls, right? So if there's an API function call, we track not only what it was, but we also track where it came from, like who did it. And the who is the account, right? So when we have an IAM user, right, that's called Help Desk User 3, and you're trying to audit what happened in your environment, who do you go talk to when you find that Help Desk User 3 created a new user and gave permissions to something? Right. You don't really know who that is. And the other thing I'll tell you is human beings have this tendency to, well, I just use Help Desk User 3, so I'll give you the user ID and password. Right? That can be risky. Whereas if it's a user that's, Andrew or Mary or Ebenezer or what have you, and they do something and that's tracked, I can go and ask that person. Okay. Now again, like I said, I'm probably getting too excited about this. So there's a question that said, can I go back to the previous slide? What were the two types? What were the two types? I'm not sure what you mean by what were the two types. There was the idea was when you create your AWS account, you only get a single root user, and then you create another user that has all powerful permissions that you can then, I just called him a super user, right? But it's a user with roughly the same permissions as root. So just protect your root account. If you lose that, and again, people have this tendency to, forget and scramble passwords and do all sorts of, you're way better off just setting up multi-factor authentication, documenting what the user ID and password is, and locking it in a safe. Right? So that if you have to use it, it's written down somewhere, and it's somewhere safe. Okay? All right. So IAM policies, this is simply a document which describes what can be done. If we take a look at a policy document, this is an example of that. Now, you will not be required to write a policy document on the exam. However, it's quite reasonable that they might give you something like this and ask you what it does. So let's look at it, right? So first of all, things like version and statement, or say, that's necessary header information. The effect is allow. All right, so this is some sort of an allow statement. And the action is for the object S3, right? S3 is a bucket, right? And we're giving it the list object permission. We're also giving it the get object permission against the S3 bucket called AWS doc-example-bucket. So what do you think this allows? Well, this allows somebody to not only see what's on an S3 bucket, but also get an object. Right? So they can open a file and they can read they can pull a directory listing, if you will. Well, that seems pretty straightforward. And that's the type of interpretation you may or may not be required to do on the exam. And if you do, there might be one question. So don't freak out when you see something like this. They're actually pretty easy to read. They're not so easy to write from scratch because the syntax is a little ugly, right? Make sure you get the colons and the semicolon, and all that stuff in the right place. But so there you go. So this is a policy. But let's face it, does this policy doc do anything by itself? Not really, right? This policy doc declares what would be done, assuming that this policy is assigned to some user or to some group. Right? So the policy doc by itself just says what can be done. It really doesn't do anything until somebody gets it. We like groups. And again, I feel like I'm preaching to the choir here. If you've done any level of user management in the past, you never ever manage individual users. You always create a group. You put the common users into that group. You assign the policy to the group. The users then get that policy, job done. If Bob leaves and is replaced by Mary, no problem. We take Bob out of the group. We put Mary in the group, job done, right? Bob loses his permissions. Mary gains the appropriate permissions. It's fantastic. And again, this is no different than any other group management process. By the way, one thing I haven't mentioned, which I think is worthy of mentioning at this moment, we do have tools which allow you to integrate with other user account management systems. A lot of people are using things like Active Directory. The IT folks already have accounts in Active Directory. You do not want to create another set of accounts that they have to remember different passwords for. We have an Active Directory integration module, which would allow you to then take this same idea, declare who are the AWS users, assign the permissions to them, but they are being assigned to Active Directory accounts, right? So that's, again, a very important aspect of this. You don't have to build a separate IAM account structure if you already have something like Active Directory. You just simply link the two together and use IAM to assign the policies to those Active Directory accounts for groups. So again, same rules as always. One account, get to log in and check your email, and also manage your AWS stuff. A role is a different thing, right? This is the piece that's very, very different, and it's a bit of a mind twist, but it's a very cool feature if you look at the overall big picture. So let's say that my manager has the ability to create S3 buckets, and he's going on vacation. So first things first, that owner gives my account permissions to switch to a specific role, right? And then my manager, someone with the right permissions, creates a new role which declares what I can do, in this case, create S3 buckets, when I take on that role. So it's not an assignment of the permissions to the individual. So Andrew is not getting any new permissions. What's happening is a role has been created that has permissions associated with it, right? So there's been a policy document applied to the role. When Andrew needs, so let's say the boss goes on holidays, and all of a sudden Andrew, as his backup, gets a request to create an S3 bucket. Okay, but Andrew doesn't have permissions to do that normally. But the boss, before he went on holidays, gave me permissions to switch to that role. So in the user console, I switch to the role called create S3 bucket. I, Andrew, lose all of my other permissions, and I inherit the permissions associated with the role only. I then go ahead and create whatever bucket it is that I need to create, and then I switch back to my normal role. I lose the create bucket permissions, and I gain back all of my other regular permissions. It's a really cool feature because what ends up happening in the security world, and one of the downsides to it is, the boss goes on holidays, gives Andrew the ability to create S3 buckets, and then when he comes back, he forgets. But Andrew has all these other permissions, and then somebody else goes on holiday and gives me permissions to do something else as well. And now all of a sudden, Andrew realizes that he can not only create an S3 bucket, he can transfer company financial data into said S3 bucket, give himself permissions out there in the real world, and copy the entire company's S3 data off. Right? And that's bad. So the whole idea of this temporary access through using roles, right, allows you to ensure that even if they do get extra permissions, they do not get them at the same time as all of their other permissions. So while they may normally be able to see that financial data, when they go to create an S3 bucket, they've lost access to that financial data. And then when they go back to get access to the financial data, you get the story. Right? Again, I'm trying to come up with a great use case for that, but it's generally speaking, the temporary assignment of permissions is one of the biggest security holes in most organizations. So don't do it, right? Create a role that you force somebody to change into to do those special tasks. And then they can change back to their normal day-to-day role. Are you guys familiar with multi-factor authentication? No, the boss would typically revoke that when she gets back, absolutely, right? Andrew can switch back and forth between the roles as he has been assigned permissions to do so. But, in the case of Mary being the boss, she would come back from vacation and go, okay, Andrew, you've had your fun. That's it. You don't get to do that anymore. and just take me away from being able to even inherit that role. So yeah, it's a cool function. So multi-factor authentication, for those who are not familiar with this, typically you log in with a user ID and a password. I've got this enabled on my AWS account. It then prompts me for an additional piece of information, which you can get from any number of different resources. Back in the day, I used to have an RSA security dongle that actually hung off my keychain. It was that numeric string of numbers that changed every 60 seconds. In my case now, I've downloaded the Google Authenticator to my phone, and I only use that one because I used it with a previous organization. And I get prompted for this. I set it up within the AWS environment, and then I launch Google Authenticator. It says, for AWS, you're going to enter this string, and it's about to expire in 10 seconds, so maybe I better wait, right? If you're interested in this, MFA, multi-factor authentication, and we jump over here, and it talks about the various different multi-factor types that are available. Generally speaking, the multi-factor authentication applications are the ones we care about, things like Authy, Duo Mobile, LastPass, Microsoft Authenticator, Google Authenticator, etc. Right? There are security keys that are available too, U2F security key, should you choose to go that direction. But again, your organization will probably have a standard using one of these, and we can integrate any AWS user account so that it's forced to use multi-factor authentication. So somebody cannot just give away their user ID and password. Right? That's the message. Cool. Now, AWS organizations are going to wrap up this module before we take our next break. AWS Authentic Organizations is a really cool tool. But you got to understand the scenario. And again, hopefully you guys are appreciating I like to kind of set the stage before we jump into the tech. In some cases, because AWS has been an interesting, it's just available, you'll find that some companies have got 5 and 6 different AWS accounts, meaning they've got 6 different root accounts. Well, why would that happen? Well, maybe the accounting department discovered that they could actually do backups using the storage gateway. So they could actually do on-site backups to S3 buckets using the AWS storage gateway. So they opened up an AWS account, they deployed the storage gateway, and now their third-party backup tool can actually back up their on-prem accounting servers to S3 buckets. Well, great. It's good for them, right? But then the IT department, unknowingly, has gone off and got their own AWS account. And somebody else in the organization wanted to do test and dev, so they got out their own. And of course, they're all billing back their AWS expenses to the accounting department, right? So how do we consolidate that, right? I could tell everybody who has their own AWS account, all right, you need to decommission your accounts and we'll create your entire structure inside our environment. How well do you think that's going to fly if they've got 50 or 60 EC2 instances built and a whole bunch of S3 buckets? Like it's just not, is it? I mean, you're not going to ever get anybody to decommission what they've deployed. But how do we bring them in under the same umbrella? And that is the job of AWS organizations. So what you do is using AWS organizations, it's a tool, you essentially create a new root level account. So let me go back to sharing here just for a moment. Okay, discard. So here we are, AWS organizations. So this could be the accounting department. Oops, sorry, don't mind me. Back up the bus. Remember, 3 different accounts created at different times. These are all independent root level accounts. The way you solve this problem and bring them together into one is you use AWS organizations, you create a new root account, in quotes, right? And then you invite each of these guys to participate in your new root. And the huge advantage to this is that it keeps their infrastructure below their account intact. So if they're using a bunch of S3 buckets, they keep them. If they've created some IAM users, they keep those. All of the stuff that they do is kept together, but it brings them together under a single umbrella. And now I can use what are called service control policies to dictate, just what kind of permissions these folks have in other parts of the environment. Okay? So very, very cool tool, but it's got another very, very strong side effect. So bear with me while I get through some of this material to show you that second side effect. So at the root level, I can bring everybody into these new ones, right? I've got these two accounts that they're both finance. And what I might choose to do is build an organizational unit to bring two other accounts in, because I want to assign, permissions for this guy to that OU, which will then have trickle-down effects this direction, right? This really only impacts the users at the top level and what access they have to resources in the other portions of the hierarchy, okay? But the big advantage of organizations, so great, we got this tool, we can bring together all of these disparate AWS accounts that are in use by this one company. And you may run into this. As a partner, I'm quite convinced you will, actually, because there's a whole bunch of customers out there that have got many, many accounts. But here's where it gets even more powerful. Because you've now tied together these what were separate accounts into a single account, you now get a single bill, all right? However, you get an itemized bill, which still maintains the billing that was accumulated on the part of each of the individual old accounts, right? And so let me talk about that just for a moment. And I'll show you some other side benefits. So what ends up happening here is we've got these three accounts that were brought together. They each spent some amount of money, right? All right, cool. So when the bill arrives, you get a summary for the bill, right? Which includes each of these accounts. So if you're doing any kind of chargeback to these various different departments, then you can still do the chargeback because you know exactly what they consumed. And of course, it's reasonable to assume that if you're going to build a new management account, that new root, that you're probably going to deploy the odd EC2 instance or maybe whatever, then that particular account will also accumulate some cost, okay? And then of course, there will be a bill for the whole thing. And the cool part for me is, hey, I maintain my separation. I keep track of the, who spent what where. A single bill comes into the organization rather than having to worry about expensing 4 or 5 different accounts. And it's all consolidated. And there's still a further benefit, right? Ishak, that would really depend on how you've assigned those service control policies, right? Can account 1 have access at account 2? Again, because they've now been brought together, we can determine exactly how those root level accounts have access. Okay, so that's the consolidated billing piece. But check this out. That's actually not the big reason. I mean, that'll be great. Accounting will love you, right? They don't have to, 4 separate AWS bills. They've just now got one. All right, fantastic. But here's the real big deal, right? Each one of these accounts is consuming a certain amount of S3, for instance. This example is just showing S3, but other services fit into the same category. Account 1 is doing 2 terabytes of data transfer in S3, right? Well, let's just call it data transfer because that's the value they're using here in my example. Account 2 does 5 terabytes, account 3 does 7 terabytes. What's interesting is that you get a discount once you reach 10 terabytes of data transfer. Well, remember, all 3 of these accounts, before we used organizations, are actually being paid by the same company. What's their total consumption? Well, 14 terabytes. And guess what? They're paying for 14 terabytes at the maximum price. Because we don't know them as a single account, right? As far as AWS is concerned, those are 3 different accounts, and none of them are actually consuming the 10 terabyte threshold. But as soon as we tie them together using AWS organizations, then that gives us 14 terabytes of overall usage, and we end up with a discount on 4 of the 14 terabytes, right? Because you get a discount as soon as you hit 10. Anything over the 10 threshold, you get some more discount, right? And of course, the next threshold I think is 50 terabytes. But the same rule applies to many other services. There's lots of services where you do in fact get a deal based on more consumption, but you got to hit the base level. So this is a great way to do that. All right, let's talk about compliance. I'm going to go a little bit longer on this module, just on our time frame. I'll probably take us closer to the bottom of the hour here, so that we'll take one more break before we do the last stretch to finish up the class. So compliance is, I think it follows the conversation nicely. Remember I said to you, there are tools that we have available so customers are a little more aware of what's going on, particularly from a security perspective. So let's take a look at some of these tools, some of them directly impacting security, some of them impacting things like compliance programs. So we'll start with AWS Artifact, which is, again, it's a tool in the user console. This allows us to view compliance reports. And the cool part is, if you as a partner go out and find some compliance report for AWS and you provide it to your customer, how does the customer know where you got that from? Well, they don't, do they? You've just gave them a PDF of some sort, and you say, oh yeah, here's the latest compliance report from such and such an organization, whether this is, from ISO 27001, this is the latest version. How do they know? Well, they don't, right? They just have to trust that you got it for them. AWS Artifact allows them to go and pull down any compliance report for any of the assurance programs that AWS participates in, and it will always, always be the latest and greatest version. It's not coming from some random website that was posted somewhere. Okay? So this is cool. Customers can self-serve compliance reports. If they end up in an NDA situation with AWS, maybe they're going to be beta testing a particular process, they would use AWS Artifact to sign any of those documents. And also third-party compliance reports from auditors. So we will not open up our data centers so that customers can go in and audit. Right? We don't, but it's part of our security protocol. But we will allow third-party auditors in that have the right access, and then they publish their reports that are now available through Artifact. Okay. And again, that's a huge deal for a customer because they can just go to a single point. They can either pull down compliance reports or auditor reports through the tool. Single tool, and they always know they're getting the latest and greatest. It's not coming from some random website somewhere. This is a very, very small snapshot of some of the compliance programs that we participate in, right? You can find all these in AWS Artifact, and there are a bunch more, right? There are some that are region-specific, some that are state-specific, some, we've got Canadian ones, there's federal government ones, there's provincial, there's state-level stuff in the US, the whole deal, right? Tons and tons of different assurance programs, and you can get access to all of this information through AWS Artifact. Now, the other thing that we have available to customers is something called the Customer Compliance Center on AWS. Customer Compliance Center, again, it's not just the reports, it's more about understanding how compliance fits into the big picture, right? There's technical papers, there's documentation, plus they could, if they're so inclined, complete an auditor learning path so that they can become an auditor inside their AWS deployment, right? And again, the compliance reports will typically be about how the AWS services are compliant with the various different services, right? And SOC 1, et cetera, is all there. Yeah. Again, I think, and again, this is Andrew shooting right from the hip, so bear with me here. Let's give this a try. Hey, look at that. Pulls it off. So security standards and compliance certifications than any other, including PCI DSS, HIPAA, FedRAMP, so on and so forth. So if you want details around this, going into the compliance story, this is kind of your main landing page for any of the compliance pieces for either security services, data protection. We've got a whole pile of stuff under the security umbrella. Okay. So Daniel, I think to answer your question, probably best spending a little time poking around in here to see what you can find. And hopefully that's slightly useful. And back to the conversation. There we go. All right, so let's talk application security to wrap this thing up. This is another reason that people are liking AWS, because just because you deployed in the AWS infrastructure, we provide certain services for you that will automatically protect some of the applications that you may be running in the AWS cloud. And the first of those tools is this thing called the AWS Web Application Firewall, or WAF, right? Again, it's an optional tool, but it is available to you. And it works with both CloudFront and an application load balancer, right? Essentially, this is a filter, right? It's another level of firewall. The web application, it is called the Web Application Firewall. The idea is this. It's a repository that we can use to place known bad IP addresses on the internet. And believe me, there are thousands of these. You know, there are some of the security organizations spend time actually figuring out what they are on a daily/weekly basis. They publish updated lists. And in some cases, some of those guys are actually a part of the AWS marketplace so that you can actively download a new version of the list and plug it into the web application firewall on a weekly basis, which I think is really cool. And what ends up happening is if somebody comes to visit your website from one of those bad IP addresses, it's just outright denied. And you don't even have to worry about it, right? If it's listed as one of the, the IP addresses that's been determined on the internet is bad, those are a bunch of bad actors behind there, they do terrible things, then we can have the web application firewall just say, forget it, you're not getting in. So it never even gets through into your environment, which is really cool, right? So that's a cool feature, right? We also have a service which helps us with denial of service attacks. Denial of service is typically where a hacker will write some code that causes a service to respond, but in a way which is non-productive. In other words, the hacker is causing your server to be busy doing nothing, or doing nothing productive. The worst of these is the distributed denial of service attack, where they create a bunch of bots, deploy them on unsecured servers throughout the internet, and then they attack your environment. Well, again, what are the odds you're going to get attacked with one of these? Well, we don't know, right? I know one of the more famous ones was Sony was attacked years ago on the PlayStation Network right around Christmas, New Year's. What a great time for something like PlayStation to be attacked, right? So this was a major problem. So what happens with a denial of service attack is, generally speaking, there's only a limited number of these out there. We know what they look like. We've got history. We know what I'm going to call it a thumbprint, right? The traffic comes through the front door. We know approximately what this, hey, wait a minute, that's a denial of service attack. I recognize that string of characters, right? So we have a tool called AWS Shield, which is free, right? We do not charge anything for AWS Shield. And its job is to watch the inbound traffic looking for these recognizable thumbprints. And then when it finds them, it actually discards them, right? Right off the hop, it just discards them. So whether it's coming from a single hacker who's trying to do something or a distributed collection of bots who are trying to take down your environment, it will in fact deal with those. But it will deal with them only if it's seen them before, right? Does AWS Shield know about this attack? Well, as with all things on the internet, things change, and maybe some new DDoS attack comes out. Well, that's where AWS Shield falls a little bit flat, because it doesn't know what that looks like. If some new attack comes by, hey. So let's assume that you, as a customer, are under attack by one of these new unseen things, right? Something we've never seen before. You have an option to upgrade your security using what's called Shield Advanced. And Shield Advanced includes everything that Shield does, but it also gives you a 24/7 set of access to a DDoS response team. They will take a look at the traffic coming inbound to your environment. They will write a custom add-on to AWS Shield. They'll plug it in, which will then thwart the attack. But again, that could take a period of time. But better than that, if you incur any additional cost because you had to launch a bunch of auto-scaling groups to respond to the service. At the end of the month, AWS will offset the cost of those additional resources you deployed. Right? So Shield Advanced is kind of like an insurance policy. If I'm a particularly high-profile customer, I would probably subscribe to that. If I'm a corner mom and pop store and really it's not that big a deal, maybe I'll just stick with AWS Shield, right? And you do have to enable it. Yeah, Darcy, yes, you have to enable it. Shield is free, Shield Advanced is paid. You have to enable both. Pick which one you want. Yeah. Very, very cool. So aws.amazon.com/shield be where you'd find more. Amazon Inspector, another tool that gives you automated security assessments of your application. So it'll do things like taking a look at what operating systems you're running and figuring out if they're at the right patch levels, right? That's not hard to query. Application security assessments, security vulnerabilities and deviations from best practices. Do you have an open S3 bucket? I mean, maybe it's encrypted, but it's open access with anonymous. Well, do you want that? Right? That's really not a good thing. And then at the end of the day, Inspector will provide a list of recommendations on how to go about fixing what we find as security vulnerabilities. So Inspector, automated security assessments. Hey, this web server that you're running is actually running a Windows version of an operating system that's now way out of date and you haven't security patched it forever. You're going to want to know that. So, because otherwise they tend to be vulnerable to things like denial of service attacks. Okay, we've also got the AWS Key Management Service for any time you're going to implement encryption in your environment, whether it's across the wire or on-disk encryption. You typically need a pair of keys to make that happen. AWS KMS is built into the platform, and the coolest part is, if there is a service like, say, RDS, where you can encrypt the data, it already knows to query KMS. So you don't have to go and teach the application, oh yeah, the key management server is way over there, right? You just go into the application and say, we want to encrypt this, and would you like to launch a request against KMS? And the answer is yes, and job done, right? Again, the solution is much more powerful, much greater than the sum of the parts, right? Having a key management server is kind of cool. It's kind of fundamental, right? But the fact that it's already fully integrated with the services that might need it, and then you can log into the KMS to figure out how you control your master keys, right? Lots of options there. Incredibly powerful tools. GuardDuty is a tool which actually looks at the AWS product itself and looking at somebody trying to either hack their way into the AWS platform or subsequently do bad things to your environment, right? Maybe it's a valid user who has read-only access as a help desk and they keep on trying to log into very specific areas. We will track what we call anomalous activity inside the AWS account. So while things like Shield and the web application firewall protect the things running on AWS, GuardDuty's job is to actually protect AWS itself, right? The actual platform. And it can detect things like people trying to hack their way into your root level account. Okay. GuardDuty, aws.amazon.com/GuardDuty. And of course, we can tell you how to fix some of that stuff too. How do you make it more secure? So Module 6, we're going to wrap up Module 6 and then we're going to take our break. This is the knowledge check. Which statement best describes an IAM policy? What do you guys think? Varying list of answers on this one. Right, an IAM policy, remember, it is a document. By itself, it does nothing. Right? By itself, it does nothing. It defines what can be done, but in order to make that happen, you have to assign it to a user or group, right? So technically, even B is not a great answer. A document that grants or denies permissions to AWS services and resources. Yeah, sort of. Not until you apply it to a user or group, right? But still. Best answer out of the list. An employee requires temporary access to create S3 buckets. What option would you use? Yeah, you guys heard that story. That would be a roll. You bet. Which service helps protect the applications against, or your applications against, distributed denial of service attacks? Oh, gee, by the time I glance back at chat, you guys have filled it. That's impressive. Good deal, AWS Shield. That's the one. And which task can an AWS key management service perform? What's its job in life? Yeah, there you go. That's what I was looking for. Create cryptographic keys. Fantastic. And again, my apologies for going rather quickly on one of those, but there you go. All right, and don't forget, if you guys are here for your 60% of the time, you get the whole slide deck, including the review questions and the answers. So all good, plus some other stuff that I'll share with you later. So, all right, so that's Module 6. And that brings us up to monitoring and analytics. And that also brings us to our next break of the day. This will be our last break. Again, only because we have a certain amount of content to go. So I'll give you 10 minutes. I'm going to step away, get something to keep the voice working, and we'll wrap things up by my 5 o'clock deadline. At least I'm going to do my best. So anyways, have a great break. All right, and we're back. If I can get the old +1, if you can see the monitoring and analytics slide, we'll push for home. Some of you are inevitably concerned that we're only just starting Module 7 with an hour and 15 minutes left. Yeah, we'll take it. This will take us right out to the end, but timing is appropriate. So no panic on that. We've got 7 through 10 modules to go, so 4 more modules, and we'll get through it. These are not very long modules. So monitoring and analytics. Really, this covers essentially 3 topics: CloudWatch, CloudTrail, and Trusted Advisor. So I'm going to jump into this. CloudWatch itself, the best way for me to teach this is to ask you what it sounds like. So what do you think this thing sounds like? What does it do based on its name alone? Is it logging? Monitoring. Monitoring, there we go. And there's a subtle difference between monitoring and logging, right? Monitoring is the ability to look at what's going on right now, what's happening. And I can subsequently set metrics that I'm concerned about, right? Things I care about. And then I can set notifications around when those metrics happen. Now, the notification could be just tell me what's going on, or it could be do something else. And quite frankly, ladies and gentlemen, you guys have already seen CloudWatch in action in a previous module without realizing it. Do you remember auto-scaling? Auto-scaling was the idea that we added new EC2 instances when certain thresholds were reached. It's actually owned by CloudWatch. CloudWatch is the thing that does that. You configure the parameters inside the auto-scaling group, and it's CloudWatch's job to monitor what you've asked it to, right? So in the case of the coffee shop, maybe the owner is concerned about the average number of customers waiting in the past hour and the number of pastries remaining for sale. When they reach some value, do something about it, right? So CloudWatch is watching the cloud. You want to look at it that way. And again, folks, I'm trying to give you something that you can hang on to when it comes exam time, So it monitors the infrastructure, gives us the ability to view all of our metrics from a single location. Again, recognize that can be a little daunting as well because CloudWatch can view your entire infrastructure. And if you've got, 1,000 EC2 instances and, 56 different S3 buckets, to say nothing of all the artificial intelligence pieces and your databases and so on and so forth. I mean, if you start to see all that in one console, it's going to be a little scary. So what you can do is you can build custom consoles. So while you can access all of your metrics from a single location, you can build a custom console that will give you a focused view of the things that a particular individual cares about. Because quite frankly, somebody who's interested in S3 storage consumption probably isn't all that interested in how the artificial intelligence engine is running, right? So, think about that too. Yes, we can access everything from a single location, but is that what I really need to do? And here's a great example of that, right? Here we're showing you somebody is taking a look at RDS metrics, which is the relational database service, combined with EC2 metrics and EBS metrics all at the same time. Well, yeah, you can, but as long as you understand how these relate to each other, if they even do, right? So just be aware. Yes, you can monitor, but you don't necessarily have to do it all from one place. Let's talk about CloudTrail as a tool. So what does it sound like? And some of you have already answered this when you were answering the question for CloudWatch, so that should give you the hint. What do you guys think? CloudTrail. Auditing, logging, there you go. That's what I was looking for. Thanks, Rod. You caught my hint. I love it. Yeah. CloudTrail is all about auditing. And if you look at it another way, an audit trail, as some of you have suggested in chat, that's a great way to remember it. This is a historical view of the world. Remember I said that we automatically track every single API call that is made in the environment? Well, guess what? CloudTrail is your tool, right? All those APIs that get called, whether it's somebody logging in or somebody viewing or somebody creating an instance or an S3 bucket or whatever, it doesn't matter. If it's an API function to make it work, we keep track of it. CloudTrail is your source. Right? Very, very cool stuff. So it tracks user activities. You can filter logs by doing very specific requests. You can go looking for very specific things, whether it's based on an object type or a particular user ID that did the task or a particular API call, whatever it is, right? You can deal with that. And then we've got an additional option that you can enable called CloudTrail Insights that will allow CloudTrail to automatically detect unusual API activities in your account. Now, define unusual. These are things that AWS feels should probably not be happening in your account. So, again, there you go. So a CloudTrail event will typically keep track of what happened. So in this case, a new user. Hey, Mary, we created you a new account here. That's all good. It was the IAM user called John who did that. And you now know why I hate the idea of a user called Help Desk User 3. Because who is that? Whereas this is John. I can go find him. When did it occur? Apparently people are working on New Year's Day here, but I'm not going to go down that path. And how was the request made? Was it a command line tool? Was it an actual part of a software developer's kit? Or was this through the management console, right? So we talk about how it occurred. And this can give somebody who's looking to figure out, the details behind the details. Okay, so this was clearly John sitting at a keyboard, right? I can tell you that. And he was doing it at a really weird time. But maybe that's when he had available. I don't know. You go talk to him about it. All right, so great tool. CloudWatch, monitoring. CloudTrail, auditing. Trusted Advisor is a different tool. This can give you a view of your world to see how you could improve it, right? Trusted Advisor, just like it sounds, it is an advisor. And Trusted Advisor can give you real-time guidance for improving your AWS environment. Well, in what way? Well, we take a look at 5 different categories, and then we look at where you could improve based on best practices. So let me just cut to the chase. This is a slightly older view, so it won't look graphically like this, but it does in fact still provide the same content. The categories that we're discussing here are spread across cost optimization, performance, security, fault tolerance, and service limits. And check this out. This particular account, in the cost optimization section, we've gone in and had a look. We find 9 items that could use your attention. In other words, these aren't critical because that would be this, right? Where there's 11 that are, and by the way, between you, me, and the fence, whenever I look at Trusted Advisor, I look at the security item first, like that's number 1, and I particularly look for anything that's an exclamation point. Because by the way, this will also tell you that you've got open S3 buckets, right? So there's more than one tool will tell you that you're making a mess of your security, and here's one of them, right? But let's go back to cost optimization for a moment. So we got 9 different areas. If you drill down on the exclamation points, it opens up a dialog box which actually shows you what it found. And it's probably going to tell me that you've got a whole bunch of EC2 instances that have been running for more than 12 months that are running on demand. Well, if they've been running for more than 12 months, why are they running on demand? They should either be a part of a savings plan or they should be part of a reserve, create them as a reserved instance. And you got to like this. We're going to tell you how to save $7,500 a month. When was the last time you dealt with a service provider of any kind where they told you how to not pay them as much money? Think of your cell phone provider. When was the last time they told you how to save money? It doesn't happen, does it? I mean, I'm exaggerating a little bit, but I'm actually fairly proud of this. I think this is a really cool feature that AWS produces. But at the same time, you got to realize it is really self-serving, right? Because if we tell you how to save money on our services when you're using your platform on our services, or your services on our platform, as the case may be, you're going to trust us a little bit more. You're going to say, you know what? Those AWS guys are pretty cool. They told me how to save a whole bunch of money. Let me see what else I can deploy here. Or I'm looking at a new project. I think I'm going to look more aggressively because, look, I just saved $7,500 a month. Right? And at the end of the day, we're probably going to end up having you spend more money than what we saved you. But I think you get the point, right? Notice that in this area, we checked out some performance things, and 3 of them fell into the okay bucket, and 7 of them not so much, right? Here we've got 11 items that you want to look at from a security perspective, 5 things for fault tolerance, and 1 item for service limits. Maybe you're maxing out one of your EC2 instances, right? So Trusted Advisor is a really cool tool. However, one of the things you really need to realize, and we'll talk about this in the next module, is you don't necessarily have access to every single one of these reports in Trusted Advisor. You need to be paying for AWS support. You need to have either business or enterprise level support to get all of the Trusted Advisor checks. We'll talk about that in the next module. So on that note, let's do a knowledge check. Module 7. Which actions can you perform using CloudWatch? Looking for 2 here, ladies and gentlemen. 2 answers. You guys have all run away by now. It's like, oh my God, he's still talking. I'm used to it. Don't worry about it. Yeah, there you go. And D. A and B seems to be the popular response. And you are absolutely correct. Access the met. Remember, I said you can do this, but it would be better to filter a little bit what you can get from there. All right. Which service can you use to review the security of your S3 buckets by checking for open permissions? So Guard Duty's job was to look at the actual AWS infrastructure and was it vulnerable to attack and was anyone attacking the AWS pieces? So that's probably not it. CloudTrail and CloudWatch, CloudWatch is looking at activity, CloudTrail is looking at audit, what has happened. Trusted Advisor is actually the one that will tell you that things are not living up to measured standards, right? So Trusted Advisor is the best answer in this particular case. Now, you could argue that you could look back on CloudTrail and you could filter through the logs looking for when that S3 bucket was created if you knew that it had it. But if I've got 50 S3 buckets, I just want somebody to tell me which one of those has got open access on it, right? That's where Trusted Advisor will come to play because it compares against known best practices. Which tasks can you perform using CloudTrail? Looking for 2 again. Remember, the whole idea behind CloudTrail is anything to do with API requests, so B is definitely part of the answer. And you can use a filter to assist with operational analysis. I mean, the problem with gathering all that API information is, man, that's a lot of data. So you're going to need a way to filter it, and CloudTrail is the tool that will allow you to do that. So you can search, filter, do whatever. Okay. So Module 7, quick summary, CloudWatch, CloudTrail, and Trusted Advisor. More on Trusted Advisor shortly. So pricing and support. I also want to set the stage properly on this module. You will never, ever get asked how many dollars and cents an AWS service costs, or at least not in the context of the exam, okay? And I'll tell you why. I mean, there's a couple of really good reasons why. First of all, it varies by region. So what region are you in? What region do you work in? What region have you deployed resources in? And on top of that, every single EC2 instance alone of 400 different instance types carries a different price tag. How are you going to remember all that? Well, you're not, right? You're going to look it up. So we don't care about that. What we care about as AWS is, are you delivering the services to your customer in a way that they get the best value? Right? That's what's relevant about this module. And it has to do with things like, how are you pricing your resources? And how do you understand what you can get for no money, right? So we'll talk about things like the free tier and AWS organizations and consolidate. Well, we already talked about that. AWS budgets is a great tool for looking at. We'll get there. So hang tight. So the free tier categories, and I do want to use the website to explore this because I think this is really cool. And again, remarkable URL. aws.amazon.com/free. Oops, sorry, that is not going to work. Let me copy and paste that into my chat. To fix it, you need 2 T's in there. There we go. Yeah, so HTTP. So the free tier. So if we take a look on this page, and again, it's a bit of a repeat of what's shown on the slide, so I prefer to use the website. I can look at filtering this based on what we have known as 12 months free. So when you first get your AWS account, you get access to a certain number of services that we do not charge you anything for a period of 12 months. And those items are, you get 750 hours of EC2, remember that's a virtual machine, and that's per month, by the way, notice per month. And it is T2 micro, T3 micro for both Windows and Linux. So you want to deploy some Windows workstation. And by the way, these are licensed versions of Windows that we're giving away. Now, they're not very capable, right? They got 1 gig of memory and they've got a single CPU. But hey, at the end of the day, if you need a Windows workload to play with, this is a great tool. We give you 5 gigs of S3. We give you 750 hours of very specific configurations of RDS, including, MariaDB or SQL Server, right? We give you OpenSearch service for 750 hours, 1 million requests to the API gateway. I won't read all of these to you because it's getting ridiculous. But in short, you should be able to build an AWS infrastructure using a free account and not have it cost you any money. So there's no reason why anyone on this call does not already have an AWS free account, right? You need a credit card to open one, but at the same time, it's free, right? If you pay attention to what you're doing, you'll never get a bill. And I can speak to that from personal experience, right? Been there, done that. Well, that's cool. But here's another one. What about always free? Well, always free means no matter how long you've had your account, you get a certain amount of this stuff for free. You get 25 gigs of DynamoDB every month for free. You get 1 million Lambda requests and 3 million seconds of compute time for free every month. Doesn't matter whether you've had your account for 1 month or for 373 months, which is longer than we've been around. But that's a side issue, right? Amazon SNS, you get 1 million publishes. Cognito, which we haven't even talked about, you get 50,000 MAUs each month, whatever those are, right? You get 1 terabyte of CloudFront activity. Remember caching services for it. So what happens is this. As a customer, you deploy these resources, you start to use Lambda. And if you deploy Lambda in your environment and you don't hit the threshold where you go over into anything more than 1 million requests and 3 million compute seconds, then your Lambda services for the month are completely free. If you go over the threshold, you only pay for the amount you go over. Very cool stuff. The other thing that I think is reasonable to talk about here is what's known as trials. And these are a period of time to use some of these services so that you can figure out whether they work for you or not. So things like SageMaker, which is our machine learning model, Redshift, data warehousing database, right? AppStream 2.0, Lightsail, Comprehend Medical, Amazon Inspector. Remember we talked about what Inspector can do? It's a paid-for service, but you get 15 days free if you want to give it a whirl. Right? SageMaker, Ground Truth, QuickSight, GuardDuty. Right? We talked about GuardDuty as well. Should you want to enroll that, yeah, we'll give you a free trial. Right? WorkDocs, Device Farm, Security Hub. I mean, the list of things is never ending. And we'll give you a certain amount of time to try these things to see if they work for you or for your customer, as the case may be. Okay? Please leverage this page. It's a fabulous page to actually get your customer excited about stuff. You may have a new project to help modernize their environment, which is using a new service. They're not quite sure about, gee, do I really want to spend any money on that? Heck, that service might be available to them for 60 days for free. Right? So it's an option, and it's actually a very valuable sales tool. Okay? So, free tier categories. Our base pricing concept, since this is the pricing module, is pay as you go. We've talked about that many times. Pay less when you reserve. Remember, reserved EC2 instances cost you less. Or pay less with volume-based discounts. If you hit a certain utilization threshold on certain services, you get a discount. Those are the basic pricing premises. And it's up to you as a partner to help your customer achieve those, right? And how would you do that for volume-based discounts? Well, if they've got 5 or 6 AWS accounts, combine them. Use AWS organizations and stop them having 6 different accounts so their combined usage gets added up and maybe they get a discount, right? You're not going to use any more resources, but you're going to simply put them together into a single account. So let's talk about the pricing calculator. And again, in the interest of being more interactive, this is a bit of an unusual URL. Oops. It's really unusual when you spell it wrong. There we go. http://calculator.aws. That is correct. So here's the pricing calculator, and I'm going to do a quick demo here. First thing you do is start by creating an estimate. So this refers back to a comment that was made some hours ago in the class. How do you come up with the annual budget for what you're going to spend on this thing? Well, part of it is determining what you're building. So you as a partner will have sat down and said, all right, this customer needs 4 web servers, going to be up and running all the time. Well, let's just add those to the quote, right? So those are going to be EC2 instances, right? So I simply browse through the environment, or I can search, and I choose EC2. There it is, right? And I say configure, all right? So what have you got? So enter a description. This is the EC2 web servers. Yeah. Maybe I've done an architectural diagram and, whatever. So we're going to deploy it in the US East region again, because don't forget, pricing is region specific. I'm going to do a quick estimate. If you really want good details, choose the advanced estimate, but be prepared to answer a lot of questions. For the sake of keeping us on track here, I'm going to choose quick estimate. I'm going to be running Windows Server, sure. Windows with SQL Server Web, sure, why not? Just an arbitrary number I pick, right? And it says, well, what do you want to run? So here it's suggesting we do 4 CPUs and 16 gigs of memory based on a typical Windows Server build, right? You can alter that. If you don't want to do that, make it a different size. And then it's going to make a recommendation over what type of instance we should do to give us good value, right? The pricing calculator does in fact do that, but you could choose your own, right? How many of these are we going to run? I'm going to run 4 of them all the time. And the utilization, it's a bit of a weird number here. Utilization does not mean CPU utilization of the actual Windows servers. It means how long are these going to be up and running in the period of a month? Are they up and running all the time or not? I know it says percentage of utilization, but it is what it is. And you'll understand why when you see the pricing, right? Percent utilization. So it's up and running 100% of the time per month, not necessarily at 100% CPU time. Okay, good to go. So how do you want to price it? Do you want to do an instance savings plan, right? Savings plans are good. Do you want to do a compute savings plan, right? A little bit more generic. You can use it for more things. Pricing may differ a little bit. You could do reserved instances. And if you do reserved instances, it's not letting me pick it for some reason. Being really grumpy here. Oh, there we go. No, it's still not letting me do standard reserved instances. Okay, so convertible reserved instances, 1 year with no upfront. This is the thing I wanted to draw out is once you've chosen a reserved instance, you get to choose the term. We talked about this, either 1 or 3 years. And then what helps dictate the price is if you pay no upfront, partial upfront, or all upfront. Partial upfront usually means 50%. Okay. And what it can show you here, this is where I find it interesting, is it says when I do it this way, convertible reserved instances with no upfront for 1 year, it's going to cost me $729.12 US per month, right, for all 4 of those servers. Okay, cool. If I say partial upfront, the upfront cost is going to go to $4,284 US, and then my monthly payment is going to go to $357.12, right? So, bit of an upfront bill, pay for it over time. Theoretically, I should save money over time. If I do on demand, notice my price jumps up, $851 per month, because on demand is the most expensive. Okay. So it's a really interesting process, but wait, you're not done. Remember, that's EC2 compute. Every EC2 instance has storage, right? It has a boot drive. And remember that that's an EBS volume. So what we're doing here is they're suggesting to us that each of our EBS volumes or each of our instances is going to get a 30 gig disk. I can alter that, right? Maybe I want to do 100 gigs because I want a 30 gig drive C and a 70 gig drive D. I don't know, right? I can choose what that is, and then if I hit tab, I can click show calculations, and it'll tell me that that 100 gigs times 10 cents US dollars times 4 instance gives me a $40 per month cost. Well, big deal, right? But the cool part now is that I now know that if I do on demand, which is the most expensive, for both my storage and my EC2 instance, I'm going to run basically $900 for my 4 web servers per month, right? And I say add to estimate. And then what you do is you go back and you say add service. And now you build the EC2 instances for your application servers, or maybe you go and you build an RDS instance for your database server. So you go through and itemize all of the items that you're actually building into this environment, and at the end of it all, it will produce you an actual estimate for your customer based on data that you have provided. And I find a lot of times, this is not a private link, this is something that customers can get to as well. You could actually sit down and work with your customer and say, hey, I can show you how this changes based on how we actually price it. Okay? You can actually use it to show the difference between doing a, let's say a T3 instance, an extra large, to going to maybe a T5 or something, whatever the next logical progression of bigger servers is. Maybe you don't want to shortchange them on server size and capability, so give them a more capable one and show them the difference in price. Right? So the pricing calculator is an extremely cool tool. I strongly recommend, if you're going to use the pricing calculator, well, I strongly recommend playing with it before the exam. You don't have to get detailed. Just what I did there was more than adequate. But make sure you understand what it does. So that is the pricing calculator. So Lambda. How do we price Lambda? It's based on number of requests and the amount of compute time. It's a combination of the two, right? Remember, you get a bunch for free by default. You can save money by having a compute savings plan, because you're committing to saying, all right, we're going to use a certain amount of this stuff. And here's an example of a Lambda report. And in this case, you got to like this, Bill, right? We did 254.575 seconds of Lambda compute time across 680 requests, neither of which was enough to break the threshold where we actually gathered a bill. Oh, that's kind of cool. And notice it shows you your Lambda usage per region. This is Northern Virginia. EC2 pricing, we've talked about extensively. On-demand instances, you only pay for the time that they're running, but if you're running on-demand instances 24/7/365, you could probably get a better deal, right? Go to a reserved instance or go to a savings plan of some sort. Maybe spot instances would be good if they're interruptible workloads, right? So here's an example of an actual printout where they take a look at, hey, EC2 running Linux. They're running 2.2 micro instances for 106 hours. They didn't break the monthly free tier. EBS, $0 for SSD configured because it was only 11.294 gigabytes per month, which is, again, under the free tier. So we're looking at a free tier account when these reports were produced, and this guy's not breaking the boundary, right? And elastic load balancing, again, $0 per application load balancer hour or partial thereof. You only ran 268 hours, which is, again, underneath the free tier. I love these reports. But the point is to show you, hey, we break it down for the customer, and even if it's a $0 bill, we show them it's a $0 bill. Right? S3 is based on 4 different things. Okay, S3, remember, that's storage, object storage. Generally speaking, object storage is about the amount of data you're storing. But the other thing that it's based on is the amount of data that you transfer off of an S3 bucket. Well, what do you mean transfer off? Well, think about Netflix. Netflix themselves puts their videos on S3. The act of putting the video onto the S3 bucket does not cost them anything. We charge them nothing for that. So data inbound to S3 is free. As data lives on S3, it incurs a cost, right? There's a cost to store your data there over the month. And then there's a cost for data transfers away from S3, right? So from, again, the Netflix proposition, if they transfer the movie to the customer, that's costing them, right? So they're paying for the storage, and they're also paying for the data transfer from that storage to the customer. Now, if they use CloudFront, there's probably going to be CloudFront charges in there, and we probably won't charge them for the data transfer to CloudFront because the bill for CloudFront makes up for that. And then if they do any kind of replication, one region to another, or any kind of management like we talked about with the S3 auto tiering, then there are bills for that as well. Okay. Generally speaking, it's about the amount of data stored and the amount of data transferred away from the S3 bucket. Those are the 2 big hitters. Here's an example of a report which tells us exactly what we did. And again, we fell underneath the free tier, so I won't bore you with that. Right? Again, we break it down, but recognize that we're still showing you a $0 bill. The other thing that we give you, and I think this is really important, and it's even more important when you realize a couple of extra pieces. The first thing is this. If we move to a monthly model for billing, right? Let's assume that the customer is going to go all monthly. They're not going to do any upfront stuff or whatever. And even if they do upfront costs, there's going to be an element which is monthly somewhere along the way. Let's assume that on the first day of the month, the accountants were all sitting down going, they looked at last month's bill and they say, oh, last month's bill was $100. Okay, great. So what do you think this month's bill is going to be? Well, if it's status quo and we're a growing organization, maybe this month's bill will be $120, right? Because we're growing. We expect to have more traffic. And I'm using fictitious numbers, but just bear with me. So last month, we know it was 100. So it's now the first of the month, and I'm expecting to spend 120. You can use this tool called AWS Budgets, which will, at the very core level, you could just set a monthly budget and say, hey, tell me when I hit 50% of my monthly budget, right? You could simply plug it in and say, I expect to spend $120. Notify me when I hit some percentage thereof, right? Or I could be more diligent than that, and I could break it down and look into each of the services that I'm using, and I could allocate a budget amount to each of those, and then you could tell me when I exceed my budget amount or when I've reached a portion thereof. When I've hit, say, 70% of my EC2 utilization that I anticipated, let me know. And you guys go, okay, Andrew, that seems pretty simple, right? But it's way more important than it initially assumes, right? And you can mess with your month, right? Whether it's a calendar month or a billing cycle, it is monthly. I think it's a calendar month-based billing cycle. But here's the trick. One of the problems you bump into is this. Last month you spent $100. This month you expect to spend 120. What happens if somebody inside your organization discovers that you can template your entire AWS infrastructure and deploy it into a new region with about 6 clicks of the mouse? Would you be surprised if I told you you can do that? And yes, you can do that, right? It's an amazingly powerful service. And when you think about it, it makes a lot of sense. If I'm going to be a growing organization and I want to scale to other regions, why would I want to deploy that stuff manually? I got a perfect example of it right here. Let's just templatize that whole thing, deploy it into the new region, and job done. But you just doubled your resource utilization in one day. Well, what if you were just experimenting? What if this was a, hey, I want to play with this tool type thing? And what if you forget to turn off the resources? So accounting is expecting a $120 bill. On day 2 of the month, you just doubled your resource utilization. Well, that means you're probably going to get a $240 bill at the end of the month. What if accounting set a threshold on the budgets to be notified when half of the budget is spent? Well, heck, they may get a notification of that 3 days from now. And they're going to go, hey, wait a minute. We spent half of our budget and it's not even the end of week 1? Okay, what did we do? Right? Who did what? Why is this costing us so much? And it avoids you from getting that big bill at the end of the month. You get the notification to say, hey, this is unusual. And you can now take actions, namely turn off all those extra resources that you were just playing with, so that you don't continue to receive that. I mean, obviously you got to pay for what you used, but you can turn off stuff that you're not using so that you don't have to keep paying for it. There's nothing worse than having an expected bill and then having the resulting bill be 3 and 4 times what the expected bill was. Because, of course, guess what? Accounting comes back to you, right? And particularly as you're the partner. They'll be coming back to you saying, how the heck did this happen? You said it was going to be a certain amount every month, and we just got a bill that was 4 times that much. You go, I don't know. This tool helps your customer, right? So this is set a threshold. When the threshold is exceeded, be notified. If everything's cool, keep going. If that raises a red flag, then you can do something about it, right? So kind of cool process. Cost Explorer is a tool that you use along with budgets. Cost Explorer is how you know what you spent last month. Cost Explorer is a 6-month look-back tool, and it actually breaks down your utilization of your AWS resources. So you can take a look at where did I spend my money during those previous 6 months. I spent it apparently in October on a whole bunch of T2.micro EC2 instances. Right? We're looking just specifically at EC2 right here. But Cost Explorer is a great tool. So it's the look-back tool. Budgets allows you to set thresholds for notification when a certain budget value has been reached. And again, you set the threshold. So support plans, we actually have, you want to call it 4 support plans. The first of which is basic support, which is free to all customers, right? Everybody has basic support. You don't need to pay for it. You don't need to sign up for it. If you've got an AWS account, even if it's a free account, you get basic support. It gives you access to technical papers, documentation, the usual noisy stuff, right? You do get the 7 core AWS Trusted Advisor checks. Remember I said Trusted Advisor, that great tool that gives me the view on what's going on and how I could save money and all that stuff? Well, we don't give you everything. If you're just a free user, you get the 7 core, which includes S3 bucket permissions. Great way to know that you've got S3 open buckets. Security groups for ports unrestricted. IAM use, multi-factor authentication enabled on your root account, EBS snapshots, RDS snapshots, and service limits. We'll tell you what's going on. But those are the only things you get through Trusted Advisor if you have a free account. You could step up and purchase developer service. Developer, last I looked, I think is $29 US per month. Again, you will not be asked the price. But it's a per user, $29 per month per user. It gives you some best practice guidance. It gives you client-side diagnostic tools and building block architecture support, plus all of the other stuff that the free account gets, because let's face it, we don't take that away from you. But recognize, at developer, you don't get any more Trusted Advisor stuff, nor do you get tier 1 help desk support where, hey, drop everything because we got a production system down, right? This is, you're paying for developer level access. We're assuming you're playing with AWS. The first time where you really get serious, where you get a little bit more high priority on your support tickets, is business. And that is where you get all of the Trusted Advisor checks, right? So what I showed you on that screen earlier in the class, this is the all Trusted Advisor checks are delivered as soon as you purchase business level support. Now, business level support's based on a percentage of your monthly AWS spend. I think the minimum is $100 US, but it is based on, if you spend $10,000 monthly in AWS actual costs, then your support is a percentage of that. Right, so it's based on how much money you spend on your AWS services, with a minimum being $100. Enterprise support is a different animal, right? Again, you get the highest level priority, you get all the good stuff in terms of architectural guidance, etc. But this is the big deal, right? And by the way, I'm highlighting those 2 items on this slide, the things I've circled, because they are extremely exam worthy, right? At the enterprise level support, you get access to a dedicated technical account manager who ends up being your first line of defense for support. You ask them for support first. They know your environment. They understand the architecture of what you've deployed. They know what you're using in your AWS environment. They know why you're using it. They know how it's configured. They essentially become an extension of your IT staff. Now, folks, this level support starts at about $15,000 US per month. In other words, this is the rough equivalent to hiring a very skilled architect to work full-time at your organization. But they're paid for by AWS. You just pay us a bill, right? Business level, much cheaper, you go to Emit, but you're still responsible for your own support. And yeah, you can make some calls and they'll help you out, but there's nobody on site to help you with that. So, cool stuff. Technical account manager, we already talked about briefly. Okay. So which of the following is the lowest cost support plan that includes all AWS Trusted Advisor checks? And I just circled this as an exam-worthy option, so I'm hoping you get it right. No pressure. The answer is A. Absolutely. Business is the first level where you get all of those resources. Right. So the AWS Marketplace, this is a really neat tool. This is actually, think of it as the app store for AWS. So digital catalog of listings of third-party software that runs on AWS. There's all sorts of things listed here. There's additional security functions, one of which I really like. You remember the web application firewall? That was that firewall where you could plug in IP addresses of bad actors on the internet. There are third-party companies that publish updated lists that plug into the web application firewall that are published through the marketplace. And so the way we get to the marketplace so that you can have a poke around, should be that, AWS Marketplace, right? aws.amazon.com/marketplace. And then you can choose to search for things however you feel appropriate. We've categorized them. These are all tested and validated by AWS, right? In order for a vendor to place them up here, they have to be integrated. Because what ends up happening is if this service, if they charge for this service, whatever the service is, it adds to your monthly AWS bill. And then when you pay your bill, we pay a portion of that to this service provider that you enrolled in, right? So I'm going to show you a couple here that I think are kind of cool. And again, I'm going to go looking, actually, we'll just cheat, go straight to security. Might as well just go find the one I was talking about. So if I jump into security, again, lots and lots of options for figuring out delivery methods, who the publisher was. Maybe you're looking for one from F5. Great. You know, I'm looking for one specific here. There it is. Fortinet Managed Rules for the AWS Web Application Firewall Classic, right? So this is for the Web Application Firewall Classic, which may not be the one that we care about. But my point is, here I can go ahead and enroll in this. It's $30 per month for each web ACL using the managed rules per region. And it gives you $1.80 per million requests inside the region. So if you like this, you'll find that there's pricing, usage, support, and reviews for every single thing that shows up on here, right? If you continue to subscribe, this will now add this service to your AWS account, right? It's almost as simple as what you do on your phone, whether you're dealing with the Google Play Store or the Apple App Store, right? You simply log in with your AWS account, continue to subscribe, job done. And now the service is added and it gets added to your monthly bill and off you go. So it's a pretty cool setup. I like the reviews, right? You know, there can be some very interesting things. You know, they tell you that, hey, in this case, not able to see the conditions. I'm not able to see the actual conditions that are defined in the rule set. It makes it too hard to whitelist specific URLs. Well, okay, fair enough. So there's a valid complaint. And if that's important to you, then maybe this isn't the service you want to buy. And I think we've all done this at the App Store, right? Whatever App Store you're dealing with. So a fascinating tool. I think partners often shy away from this, but remember one of the tenets of AWS philosophy and Amazon in general is earn customer trust. You may be good at doing one thing or the other. You've got a contract in place where you're supporting your customer to do, you know, an overall implementation. There's nothing wrong with going to third parties to get plugins that will enhance your implementation. There's nothing wrong with encouraging your customers to go and get tested solutions that are going to work hand in glove with the thing that you're building for them, right? Don't necessarily understand that you have to build everything. Sometimes delivering a service to the customer and making sure that they, as a customer, are satisfied will mean they'll come back to you much more rapidly for the next project, right? Always a good idea. So the marketplace is a great tool. I showed you the categories already. You know, you can dig through and away we go. So module 8, let's check. Which action can a customer perform with consolidated billing? This one's actually out of a previous module, but that's okay. Consolidated billing. Yeah, there you go. I like that one, Willie. Yeah, that's what we're looking for. Combine usage across accounts. So this was really a part of AWS organizations, right? That whole consolidated billing thing that we talked about a couple of chapters ago. Which pricing tool is used to visualize, understand, and manage AWS costs and usage over time? So pricing calculator is an estimate, right? So it's not actually dealing with costs. Budgets allows you to set a threshold where it can be monitored when you exceed your budget. Cost Explorer allows you to look back over what you've actually used over time. And the AWS free tier is simply a classification of your account. So the answer is, in fact, Cost Explorer. Yeah. Budgets is a great tool, but it is a looking forward tool. right? It allows you to set a threshold, and when you reach the threshold, it'll notify you. You want to understand what you have spent? Cost Explorer is the tool. Okay. Which pricing tool can a customer use to receive alerts when their service exceeds a customer-defined threshold? This one hopefully makes sense now. There you go. AWS budgets, right on. Company wants to receive support from an AWS technical account manager. What should they use? Wow, you guys are fast this afternoon. I'm impressed. Actually, I'm impressed that you're still out there. That's a good thing. And I'm happy for that, by the way. So yeah, enterprise would be your answer. All right, so that's module 8. Module 9, a brief module. So we got 2 modules left, both of them relatively brief, with, of course, the last one being the one that you probably care about most. But bear with me while I walk you through module 9. So the first thing I want to share with you is module 9 is all about migration and innovation. Migration is the act of taking a customer's existing environment and moving it to the cloud. Of course, that could take a long period of time. It depends what they've got, how much data, how many workloads, how sensitive they are, how much they're linked together, etc. So we'll take a look at some tools, we'll take a look at some frameworks, and we'll give you the tools necessary so that you can actually make some good headway with this. And then innovation is all about, all right, now that you've landed in the cloud, what can you do? Right? What's the cool stuff? Could we go to more serverless-based applications? Could you implement maybe a data warehouse or a data lake where you can make business-level queries of your data for the last 30 years using a plain English language command set? Could we deploy a text-to-speech engine so that you can satisfy vision-limited users when they visit your website and have your website essentially talk to your customers? Right? How cool would that be? And I'm here to tell you that if over our broad partner ecosystem, most of our partners are reporting that they're getting 60 to 70% of their revenue from the modernization or innovation phase of the migration. Migration is a very small foot in the door, if you will. Do a good job on the migration, and you're set up for loads of projects later on because customers need your help to take advantage of the really cool things that can be done with AWS. So this should feel pretty good, right? If you get your customer to the point where you do a good job on the migration, and then that results in an even bigger consulting opportunity, that's fantastic, right? Okay, so we're going to talk about these items. Great, wonderful. Cloud adoption framework, non-technical, right? Generally speaking, this is a tool, and again, I've given a link here, plus in the follow-on email, I give you a link to an e-learning course that's about 30 minutes long. I strongly recommend you take that little 30-minute course before you take the test. The Cloud Adoption Framework was built by our professional services group, and it basically looks at a company's readiness to adopt cloud. And some of you guys go, yeah, they got a data center. But do they? If they move their stuff from on-prem to the cloud, do the help desk people that manage their end-user customers understand that a change occurred that either did or did not impact them? If someone on the help desk can't answer a question and that somehow gets back to a C-level individual, how is that C-level individual going to respond? Right? So it's a very tricky game. And the Cloud Adoption Framework is basically built around, evaluating, is this customer, do they have all their pieces in place so that they can move to the cloud successfully? Do they have a training plan for the help desk users? Is there a C-level individual who's bought in? Are they the ones driving the program? Because you'll find that cloud adoption works way better if somebody from the top is driving the migration, right? They're saying, yes, we're doing this for the good of the business. That way, when a question comes up and it gets escalated to that C-level person, they go, yeah, no, wait, we know this. Yes, I get it. We shouldn't have had that error, but hey, we're going to manage it anyway. Again, the course it's a URL that I'm going to send you, so don't worry about the name. Very simple e-learning project. So again, you could follow that link. Will also give you a lot of the background around Cloud Adoption Framework. So talking migration strategies, this is where we go to say, all right, I'm going to move some stuff. So you go into the customer site, you figure out what they've got. You do an inventory or go through discovery, as it were. And then you say, all right, for this particular application, I could just take it, if it's running on a virtual machine now, I could simply run it on a virtual machine in the cloud. That's the simplest version of migration. It's known as what we call rehosting or lift and shift, right? Simply, yeah, if it's running, if it's a Windows workstation running some application on a VMware virtual machine, it will now turn into a Windows system running that same application on an EC2 instance. Job done, right? Almost no reconfiguration involved. It's very simple, very straightforward. You could re-platform, and an example of that would be taking your database server running on Microsoft SQL Server and choosing to run it on RDS, but still keeping Microsoft SQL Server. So it's not running in the same way that it was, but it's still the same thing, right? It's still SQL Server. Replatforming. Refactor usually means you're going to rewrite the application. Whatever you're running on-prem ain't working for you for whatever reason. You're just going to rewrite it. Maybe you're going to go to a serverless version, or you're going to convert it to a containerized application. Honestly, this ends up being a very small percentage of things that we move, because we don't often refactor during the migration. What often happens is we'll do a lift and shift, and then during the modernization phase, we'll re-architect the application. But some people do it, hey, they got teams of people, they can do one or two applications because they make sense to do so in the cloud. Repurchase is a little bizarre. Maybe you've got an on-prem, contact management tool that you're going to say, you know what, this thing has been limping along for a long time. Let's just take some of the data out of it and we'll migrate that over to, say, Salesforce.com, right? Contact or customer relationship management will now move over to Salesforce.com. Abandon what you are currently using, replace it with something more modern. Retain is always an interesting one. Sometimes customers have got applications that work flawlessly. There's nothing wrong with them. They've got support contracts in place to keep them, whether they're running on a platform that could be moved, or perhaps they're even on a platform that would be very difficult to move, like a mini computer of some sort. Maybe what they're running is on an old IBM AS400 that just still won't die. Well, great. Leave it alone. As a partner, trying to, browbeat your customer to move an application that provides no value when it moves to the cloud is not going to win you any favors, right? Listen to the customer. Hey, this application works. We're prepared to keep it. If you hear that from a customer, unless there's some other critical reason where it has to move, you simply put that one on the back shelf. I have had servers that I found in data centers that are doing nothing. Hard to believe, but yes, that's true. So you retire them, you turn them off, right? It's a valid use case, again, assuming they are actually doing nothing. And then the last one, which is the seventh of the migration strategies, this used to be known as the 6 R's, right? Rehost, replatform, refactor, repurchase, retain, and retire. Well, now we've added relocate, because the VMware Cloud on AWS as a product allows customers running a VMware infrastructure to extend their VMware infrastructure directly into the AWS cloud. And as far as the customer is concerned, all they see is more VMware, right? They see an extension to their VMware data center as it exists, so they can move virtual machines from their on-prem environment to the cloud live. They don't have to shut them off, and they still manage their entire infrastructure using the VMware management tools. Okay, that's known as a relocate, because quite literally the virtual machine itself does not change. It simply changes its location. So relocation. Okay, cool piece. What happens if you bump into a customer who's got a lot of data to move? What do you mean by a lot? Well, a lot is a relative term, right? If their internet connection is relatively limited, a lot of data may be actually a fairly small amount compared to what other customers think is a lot of data. And if they have to migrate that through a slow connection that they're currently using for business purposes, that may be seen as a barrier to moving to the cloud. So AWS has developed a series of hardware products that we will actually, we'll call it, rent to a customer. And these are known as the Snow family. These are physical devices that we ship to you or to your customer. You place them in the data center, you migrate data to the device, you then power it off, you ship it back to the AWS data center, and we upload the results of your migration into the cloud. How cool is that? The smallest of these is known as the AWS Snow Cone, which is 8 terabytes of usable. This is a very small device, briefcase size, small briefcase size. It's rugged, so your data is safe, ship it back, all good. We have snowball devices, which look like what I consider old mini tower computers. They would sit underneath a desk somewhere. We've got storage optimized and compute optimized, 2 different versions. The storage optimized version has 80 terabytes of disk, that's 80, and it's also got some compute capabilities, so you could build EC2 instances on it to be able to deal with your data that you're transferring, transfer all that stuff over to the system, shut it down, ship it back to AWS, upload to the cloud. The compute optimized version has a little more compute and a little less storage, namely 42 terabytes, if you consider that less, which is pretty cool. But the big one, the real heavy hitter, is what's called Snowmobile, which is a 45-foot ruggedized shipping container delivered by a tractor unit, a good old semi-tractor, backs it up to your loading dock, fiber cables it into your data center, comes with its own security team, comes with its own air conditioning, power, etc., and can handle up to 100 petabytes of data in one shot. Now, this is only available in certain regions, and you might actually be surprised as to how inexpensive it actually is. And again, don't get lost in the price, because remember, that's not really a part of the course. But for a lot of people, that's such a cool resource, right? So aws.amazon.com/snow to find information about these data transfer devices. So really, really amazing capability, right? So if you've got a data transfer challenge in front of you, we have a solution for you, right? You don't have to use the internet. You can use a physical means of moving stuff. So innovation with AWS is really all about understanding what the customer is trying to accomplish. Well, great. They've been working in an environment where they've been using a good old static database for years. It hasn't really done anything great for them. Maybe what you want to do is move them up to an Aurora database, give them a born in the cloud environment, and then maybe you want to convert some of their applications, give them some better insights into what's going on, maybe launch an artificial intelligence engine to be able to solve some critical business platform. Whatever it is, it needs to be documented, it needs to be understood as to what the goal is. And then you can take a look at the resources that are available. So things like serverless applications. Turn off all those Windows servers that they're continuously patching on a week-by-week basis. Rewrite the code that those Windows servers are running so that it can run serverless, upload it to Lambda, and just pay when the service runs. And you also, as a great byproduct, don't have to pay for Windows licenses, nor do you have to pay anybody to patch those Windows servers. Focus your IT efforts on things that actually drive customer value, right? Artificial intelligence is seen as being a very, very large part of what customers are looking to deploy. Machine learning, similarly, there was a study done back in 2019 that said that 40% of all IT projects that were going to happen in the next 2 years were going to have some form of machine learning involved in them. Now, again, I don't know who they were surveying, but, that's what the IT directors wanted. AWS also provides a well-architected framework that you can leverage to actually sit down with your customer and understand the solution that you're proposing for them and how it measures up to several different pillars, namely operational excellence, security, reliability, performance efficiency, and cost optimization. Again, another great, there's another video that comes out as a part of this, as part of the post-class email for this one. Again, I recommend you have a look at it. They're not long. give you an opportunity to see what goes on with the well-architected framework. This is what our guys actually work with when they're consulting on site. They're evaluating the proposed solution according to these 5 operational pillars. And there's a really neat tool that goes with it called, surprisingly, the well-architected tool, that gives you 80 questions that you can sit down with your customer. And they are open-ended questions where you can sit down and actually understand how this solution actually provides operational excellence and security. It's a really, really cool framework. And that is the basics of Module 9. So let's finish things off. We get about 11 minutes left, and that's usually good. I can give you everything you need here, along with all the stuff I'm going to fill your inbox with at the back end. So let's talk about the exam, right? Let's talk about how to be successful on the exam. So first things first. When you go to take the exam, it's broken down into 4 chunks. These 4 chunks are listed here, and we're showing you what those chunks are. I'm going to break out of the slide deck right now, okay? I'm going to follow this link, which takes me to the AWS Certified Cloud Practitioner environment, and I'll post it in chat as well. So don't panic, coming your way. Here we go. Let me start this by saying bookmark that. Like, even if you've ignored every other one of the URLs I've sent you for now, bookmark this one if you're going to do the test. And for several reasons. This is where you go to register for the test. Good start anyway. Notice that link that says schedule an exam. It's a good one. It gives you a little bit of noise around, hey, it costs $100. It's foundation level. It's 90 minutes. There's 65 questions. You can take it, by the way, in person at a Pearson VUE testing center, or you can do it remote. But if you do it remote, you have to be in a private room with no IT staff around or IT stuff around, right? I did my first version of this when I did the Cloud Practitioner exam. I did it in my office. It was a nightmare because I had to get rid of so much stuff. I learned from that, and when I did the architect level exam, I actually just did it in the spare bedroom. I grabbed my laptop, sat down in the spare bedroom at a desk, nothing else around me. It was quite clearly just a spare bedroom. And when the guy came on the webcam and he wanted to look around the room, he said, yeah, that's good. We're good to go. I didn't have anything that would be considered cheat worthy as such. Okay. So you can schedule it either way. I don't mind the online version. Again, you got to schedule it. You got to have a webcam. You got to have a microphone. Your environment has got to be clean of all that stuff. They give you all the rules when you sign up. It's no big deal, right? But here's what I really think everyone needs to focus on. So again, I'm about, one page scrolled down here? Yeah, right near the top. It's like in the second paragraph. There's this thing called download the exam guide. Do that, right? Just click on it. It's a PDF. It opens up, right? Exam guide PDF. I would save it. I would print it. Okay? Never mind this stuff at the top. If you scroll down, you can read that at your leisure. This is where that chart came from. So on page 3, I guess, it talks about domain 1 is cloud concepts. That's going to be 26% of the exam. And you guys go, well, great, Andrew, you had that in your slide. And I did. What I didn't have in my slide is exactly what cloud concepts are. So here's how I use this. And again, most of the certification exams that I've taken in my history have got something like this available. Okay. And just so you know, let me give you the direct link to the PDF just so that everybody gets it. Okay. I'm a little old school. You've probably figured that out since I started teaching in 1991. I prefer hard copy. So I print this out. I take my favorite comfortable chair. I've usually got some sort of a computer at my fingertips, and I have this piece of paper. I then say, all right, define the AWS cloud and its value proposition as it relates to security. Okay, well, can I do that? And I'm honest with myself. I try to be anyway. I sit down and I say, well, how would I describe that? And if I'm not sure how I would describe it, try it. If your pet is sitting there, talk to the pet. You don't need them to talk back. But trust me, my cat's tired of me talking to him, but that's a side issue. Or talk to your significant other, whatever it takes. But be honest with yourself and say, could you articulate the security benefits of the AWS as part of the cloud proposition? Well, what's the advantages of security? Well, security is very well defined. It's broken into two components. The customer is responsible for some, AWS is responsible for some. We provide these incredible tools that will give a customer insight into the things that they're doing incorrectly as it relates to security. We give them an enormous number of tools that are available so that they can set their security. Right? There's, that kind of, if you can have that conversation and go through those items one at a time, cross them off as you do them, and some of them will be really quick, right? It'll be like, yeah, I got that, done. And some of them are going to be like, wait a minute, I think I better go look that up. And then what do? aws.amazon.com/ whatever it is that you're struggling with. Right? This document, and you'll notice that domain 1 is significant. Domain 2 is significant. Domain 3 is significant. It's going to take you a bit to get through this. But trust me, ladies and gentlemen, if you're honest with yourself and you actually look at this content and do your research, whether it's going back through my slides or following some of the links that I provide in the additional document or just doing your own searches online, you will be in a fine position to take this test. Because what I just told you is exactly how I prepared for the exam. And it was relatively straightforward. I won't say it was an easy test, because it was not. I mean, if I had not prepared, I would not have been successful. Okay. Yeah, Cloud Practitioner certification, which is what this is about. Yes, that's correct, Howard. I realize you sent that to me privately. Yes, it's a stepping stone, right? Because the assumption on the architectural exam is that you already know the stuff out of Cloud Practitioner, and it is multiple choice. Across the board, it's either multiple choice, pick the best answer, or choose 3. Right? No essays. They haven't figured out how to mark those yet. So the way it goes. And ladies and gents, I've got some more slides to just kind of wrap things up here. I'll rip through them very quickly just to make sure that everybody's good. So that's the exam. I've shown you the link. This is all the details, which is great. We do not subtract wrong from right. It's you either get marks for getting it right or you don't get the marks. And that's okay. You can mark answers to come back and look at later. If you're struggling with a question, do not let it derail you. Just mark it and move on. But here's my recommendation. Go with your gut, right? If you mark it and move on and then run out of time, but you didn't guess at an answer, then I guarantee you're getting that question wrong. If you guess at an answer but mark it for review later, if you run out of time, no problem. You've committed an answer. You might get it right. Everyone follow that? Make sense? So yeah, it's a good idea to mark. And folks, do yourselves a big favor. When you go back to review the question, make sure that you slow down and read the question. I can't tell you how many times I've made a mess myself and gone, oh, for crying out loud. I wish I'd read the question first, because I'm trying to answer a question that wasn't being asked. It happens. You see keywords in the question and you think they're asking something. Make sure you know what they're asking, right? And there you go. Often an exam taking tip is to eliminate what you know is wrong. And hey, if I can eliminate 2 bad answers and I got to pick between the remaining 2, at least that's a better percentage of just guessing them across 4, right? We got some more URLs for things that you may or may not want to read. These are again included in the slide deck plus the links document that I send out after the class. And here's the best part. Ladies and gents, this is a part of the email, also part of the slide deck. This is a URL that will take you to another practice test. Okay, but folks, please, you've got to recognize this. And I do say it in the post-class email, but I still get emails on it always afterwards. This link takes you to register for what looks like another course. And that is exactly what it is. Just go ahead and register for the course. As a partner, they're free, right? It's an e-learning course. So again, and frankly, you don't have to take a course. Go to the resources section and there's a practice test there. But the only way you get access to the practice test is to register for the course in the first place. And like I said, it's free. Please, let me emphasize, this is a free course that you have to register for, and all you're doing is registering for the course so that you can get access to the practice test. Okay? Again, I give you all that information in the post-class email. It's on this slide as well. Just recognize, if you click on this link, you will not see a practice test. It'll ask you to register for a course. That's good. Okay? And that's it. How about that? 2 minutes to 5. Well, 1.5 minutes to 5. I sincerely hope that you guys felt that hanging with me today was of some value. I know I certainly enjoy those. The percentage to pass the exam, it's a 70% exam. And again, there is no, like, the link to that certification thing. It all comes out in the post-class stuff. So you'll get it as part of the post-class follow-up. So, and you're quite welcome. Hopefully it shows through that I do enjoy doing this. I'd like you guys to have an opportunity to win. I think the content is right on point. And you guys asked some really good questions too. I hope I was able to adequately answer them. So, and there you go. So what's going to happen from here, folks? I'll make it the formal class wrap-up. All you need to do is exit WebEx. WebEx will automatically track your attendance. I will get a report sometime. But by tomorrow morning, you will have a copy of the slide deck and all the post-class follow-up stuff with the links to register for that extra course, the whole deal, right? So you'll get all that stuff from me in one shot. You will also get an email from the system which says that you successfully completed the course, right?